session on DevOps tutorial by Intellipaat. This session is conducted by multiple experts who are having more than 15 plus years of industry experience. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Before DevOps came into limelight, IT had two separate teams in an organization. One is the development team and one more is the operations team. The operations team will be checking the application and its performance and reporting back any bugs to the development team. But sometimes when the operation team ran the same code, it wouldn't work. The reason for this could be the difference in the system environment or any missing software library. This resulted in a lot of back and forth between the developers and the operations team, which resulted in wastage of lot of time and effort. To bridge this gap, development team and operations team collaborated, giving rise to DevOps. DevOps is not a tool or a team. It is a process of using various tools to solve the problem between developers and operation team. With DevOps, there is no wait time to deploy the code and getting it tested. Hence, the developer gets immediate feedback on the code and therefore can fix the bugs and make the production faster. DevOps engineers are in huge demand and are one of the highest paid professionals in the IT industry. So, if you wish to learn DevOps and make a career in it, then this DevOps tutorial is the right start for you. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to DevOps. In that, we will tell you what is DevOps and why do we need it, and also tell you how DevOps works. Post that, we will be learning about what is software development and also explain you about software development lifecycle. Then we'll move on to different models of DevOps like SDLC, waterfall, Agile, and also tell you their advantages and disadvantages. Post that, we will be learning about different DevOps tools like Git, Docker, Puppet, Kubernetes, Nagios. In each and every tool, we have also covered hands-on demo to give you a better understanding of the subject. Then finally, we have also covered DevOps interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
Let's quickly jump to the introduction to DevOps. DevOps is all about solving the problems we had earlier. Okay, DevOps is not something modern. Okay, DevOps came from the pain points which we were facing earlier, and that's what DevOps is. It came up with a set of practices and a set of principles which were mostly fixing all the issues we were facing in the last decade, and also to ensure that the newer generation of applications being developed can be developed rapidly, and it's going to help support the development and the agile and the company's digital transformation. Every enterprise today is going through the phase called digital transformation, and DevOps is going to help it. Now, so the first thing is, what is software development? We'll go from a little bit starting level so that everyone will relate to it, what we're trying to understand. So what is software development? The software development is nothing but it is a process of transforming the customer requirements into a complete software product. That is what we all do in the IT industry, right? We always engage with clients, and when we engage a client, the client gives us his requirement. It can be a web application, it can be a mobile application, or it can be both mobile web application and also even today's new generation of applications, the voice applications. So we are going to take his requirement, completely transform into the product which the customer needs. In the high level, that is what we all do. Okay. Now, the next thing is when we want to develop software, right? We are not going to simply go and write some code and give it to him. So in the IT industry, when we want to write some code, or when we want to develop some code, or even we want to change an existing application, already application is there, but still you want to change your application a little bit, then you would be doing that through a specific process called SDLC. So we all follow SDLC, which is called as a software development lifecycle, to perform application development or application maintenance. And any SDLC always features these 5 stages: the requirement phase, the design phase, the implementation, the verification, and maintenance. So these 5 phases are part of every SDLC, whether you choose waterfall or whether you choose agile. So let's try to quickly understand what are these 5 phases. Okay, because it is very imperative that you should understand them, because DevOps is not some what you call small corner, or you're not going to be something working in an isolated way. Okay, so DevOps is about completely working together with multiple teams, and that is why it is going to be a kind of coordinated effort, and we work and communicate with multiple teams, and we help multiple teams. Okay, now when we are going to start with the requirements, the first one in the requirement phase, this is the most important phase in the software development lifecycle, where we are going to gather the requirements from the client. So the client has his own requirements. He wants the website to be designed in a way, or he'll tell you how to design his application, or he'll tell you his requirements, like I want this feature, I want this functionality, I want this specific thing. And you're going to gather the requirements from the client, and then you're going to also do the feasibility, because whatever clients tell you, it's not feasible, or sometimes it may take more time, or sometimes it's not impossible, right? It's not that whatever client will ask you, you can achieve, right? There are time based limitations, there are what you call technology limitations. So you would then analyze and tell the feasibility of the requirement, how fast it can be done, or how much effort is needed. You then take the requirements and tell whether it's feasible or not. And most of the times we ensure that we take the requirements or the mail, and we take a sign off, so that we have a clear idea of what were the requirements, instead of you talking over the phone, or you have a Zoom meeting and he'll tell something you forgot. So it should not be like that. So people take requirements over a mail and they get a sign off. Then we go to the design phase. In the design phase, we are going to then hand over this requirements from the business analyst to the actual application architects. The application architect will go through the requirements, and then they are going to actually design the application. Design means they'll write the workflow. Okay, page 1 to page 2, or in the page 2 what should happen, then it should go to next page, or it should go to error page, or it should go to a success page. So the high level design of the application, how it should respond to, right? And they create flow charts, okay, small diagrams in a high level technical way, that what should happen, how the application is going to interact, everything. They're not going to write code, but they're going to actually convert that that customer requirements into technical specification, right? Customer will tell his own English, right? He does not know all technology terms. So they will understand that customer requirement and convert into technical specification, which can then be planned to write the actual software. And that's where your implementation comes. In the implementation part, we'll actually hand over the software specifications provided by the architect to the developer. It is up to your enterprise which development language you choose. Okay, and based on that language, uh, the developers are going to fulfill the technical specifications. So they are going to write the code. It may take 1 day, 2 day, whatever the time effort, they are going to write them, and they're going to complete. Once the developers are going to write the code to complete or fulfill the technical specifications, we go to the verification stage. In the verification stage, what are we going to verify? The testing team does two things always. Verification means verifying the application, whether it is actually performing as expected or not. The most important thing is, first I should understand, or I should first try to understand whether the developers have fulfilled the client's requirement or not. If it does not fulfill, whether he writes outstanding code, it is useless for me, right? Because he should be writing the code which is actually fulfilling the client requirements, but not something different. Once it also qualifies, the next thing they see is the performance, right? Okay, it is working, but it should not be very very slow, right? It should also fulfill your SLAs, service level agreement, right? Your client will tell, I'll have 1,000 customers logging in every second, so your application should have at least 1,000 transactions per second of a processing, right? Your application should process like that. So it's not just about working fine or not, it should also sustain the traffic, right? Some people will have a million customers, some people will have 100 customers. So based on the business requirement, your application should work, other it should not simply crash. Okay, so those kind of tests they do, they test whether it is working as expected. Post working as expected, they'll also check whether this is going to sustain the client's traffic requirements or the user requirement. Once we do that, we then maintenance phase comes in, and then we are going to take the code and deploy it to the production environment, right? Production environment is nothing but the live environment where the customers are actually accessing the application. The production environment, prod environment, or live environment, there are multiple terms, but what it means is the server which is actually serving the traffic to customer is called a production server. On that server you will update. What is server? I hope you all know by now. Server is nothing but a hardware on which you install a server operating system is called server. Okay. Now these all things are always followed. You can come and tell me like, Gopi, I am only changing one line of code. Just for one line of change of code, do I need to follow this process? Yes, we all follow, because we do not know what is the outcome of that single line, right? That single line may affect a database performance, or it may affect a one more transaction. So we always go through this, and you do not change the code without telling the client. Until unless you don't inform, you don't change it, because it is his code, right? So we tell, okay, say that we identified a bug, we want to change the code, and then you take approval from the client, and then you write it, you test it, and you release it. So it's always that, it's always mandatory, and that's how we ensure that we are always reaching the deadlines or the targets set by the customer or the client. Now there are a couple of terms you should learn before we go. The first thing is release. A release is nothing but one complete cycle of an SDLC is called a release. In the IT industry, you always keep listening the word release every day. They'll tell what is a release, which release it is. They'll tell August release, they'll tell July release, or they'll tell this is a first quarter release, or they always use the term release. A release is nothing but one complete cycle of a SDLC is called a release. And today we have multiple releases in a month. Today, most of the enterprises are currently having a 15-day release, which is the newest generation of enterprises. But most of them still have 1 month, 45 days. But that's a release. And part of a release, when do we get a release? Is only two reasons. There are two types of release. A feature release. Feature release means part of this code change, we are adding a new feature or functionality. Then you call it as a feature release. If it is a bug release, you're only going to fix bugs, like, because there may be some problems identified by a customer when he's using the application. He'll report that, and we will make it as a bug. And when we fix that, it is called bug fix. So only bugs fixes are there. See, when you go to your mobile app store, right, you see app updates every week, right? And the companies write only single line bug fixes and improvements, right? They do not tell you what is a bug, what is a detail. No one will tell you until unless it's a very, very critical bug. They will tell, but 99% of the time they don't tell. They just tell bug fixes, bug fixes. You open your app store right now, you'll see that. So it means that there are two types of releases always happen in enterprise, and it's a feature release and a bug release. And a release is nothing but this. And as I told, even if you want to make a simple change, you should go through SDLC. Now this is all good, and these SDLC are implemented through SDLC model, which is the waterfall and agile. A waterfall model is the old one which has been mostly phased out from the market. Today 90% of the enterprises are all using agile or agile based some variant, because in agile there are multiple variations now in the last 4 or 5 years, but foundationally they're all agile. Okay, so we'll try to understand what is waterfall quickly, and then go to agile, and then try to understand how it is relating to us. Okay, so the waterfall model was initially written in 1980s. Okay, it's not a new one, it's very, very old, but it was used till very recently until 2005 something. Okay, so waterfall was started using 90s. We as the IT industry, we started using waterfall in the 90s. And the first thing you should understand is waterfall model was never designed for IT industry. It was used for a different automobile industry, but we have actually taken it because at that point of time people did not even know that okay, IT companies should also have their own special SDLC methodologies. We did not know. We thought okay, some people are already using, then let us use it and implement for the IT industry. So the waterfall model was initially designed for a different what you call market, but IT people also adopted it because they saw it looks good. So the waterfall also, it's also still fundamentally same. It also has all the 5 phases we spoke. requirement gathering, design, implementation, verification, and release. So then waterfall has some special properties to it. That's how waterfall model gets differentiated from agile or other SDLC methodologies. One of the first what you call feature or the way waterfall works is it is a linear model. Linear and sequential. Linear sequential means in the waterfall model, until unless you complete a specific phase, you can't go to the next phase or the next stage. For example, if you talk about this, for example, you're writing code, for example, okay, until unless you write the code, you can't go to the testing. Okay, so means until unless the code is completely written 100%, then only I can proceed to my testing. We can't proceed, okay, I wrote 20% of the code, let us do the testing of it and come back again, write the code. That kind of a loop is not there. In waterfall, everything is a linear, means this should complete, then only you'll come here. Otherwise, you'll not come, you can't go forward, you'll be stuck here itself. Okay, that is one of the main drawback of waterfall, but that's how it was designed. Okay, in a waterfall, it's a linear sequential model. And the next big problem with waterfall is during the release, the client understood that he did not give you a requirement, or he gave the requirement in a little in a different way. Now now the client realized that, okay, this requirement I gave you is not correct, or I want some modifications. The waterfall model does not allow to change the requirements post the requirement phase. See, once the requirement phase is completed, waterfall does not allow you to change or modify the requirements or add any new requirements. That's a very hard lock. You will tell the client, sorry, this method does not allow you. When you come to the next phase again when we are going with the next waterfall release, that time we'll handle, but now I cannot, because that's how it is designed to. Okay, so these were the big major things which waterfall methodology had. But see, it's not that people knew this, because initially the waterfall looked very, very good and people were very much happy. But once we started having the websites, right? See, we only had internet only from 2000s, guys. It is not we are having internet from 50 years, right? So internet is very, very new for us. It's not much. I don't think it is 20 years also. So yeah, it's only 20-year-old. Now, once people started getting the websites or the client server architecture, then people started expecting the release faster. Means people expected change faster. But if you follow waterfall, the typical release will be anywhere from 45 to 60 days. So means if you want to make or do a change, it will actually take 45 to 60 days for actually to release it to the customer or market. This was something clients started to face problems with, because they wanted to engage with clients faster, or they want the releases faster. Okay, they wanted to keep up with the pace with the market changing, and that's when waterfall started looking bad, because people did not want to wait. And that's where the waterfall started losing its use cases, and it was quickly out of market very, very quickly. And then the agile came. So if you see, if you're only using waterfall, earlier people had a lot of advantages, like they had clear objectives. Okay, and waterfall gives you very specific deadlines for every stage. There are no ambiguous or doubtful requirements. Every requirement is clear, crystal clear, and people understand their milestone. Milestone means development team this 15 days, testing team this 10 days, like that. There are clear milestones set with specific deadlines and times, and the process and results are well documented. In waterfall, there is a lot of documentation to be filled up. So waterfall is a documentation heavy SDLC. You should do a lot of documentation. It is mandatory. So all of this is looking good when you are only using waterfall initially. And see, when compared to not having anything, if you have waterfall, these are all the benefits you get, because you have a specific order and process, objectives, clear milestones, everything. But the problem, as I told you, is a working product is not available until later stage. What is this working product? See, when you're using waterfall to add a new feature, right, that feature cannot be verified by the client until unless at the ending stage of your life cycle. So means if you're making a feature change, and if you're using waterfall, the client will not be able to use that or test the feature until at least the ending stage of your release. That's again a problem, because if we can identify faster, we can make improvements faster. It is poor model for large and complex projects, and it cannot accommodate changing requirements. The biggest problem, it cannot accommodate changing requirements, and there is a high risk and uncertainty. Why you have high risk? The problem with risk is a waterfall tends to make a lot of changes part of every release. Means client gave you 20 requirements, you'll handle all the 20 requirements in a single release only. Okay, no matter how much amount of effort you are having, or number of what you call requirements, all the requirements will be clubbed into one single release in the waterfall. So if you're having lot of changes, moving parts, there is also a high risk and uncertainty that the release will be a failure. Release failure means you may not be able to fulfill the requirements on time, or even though you deliver on time, there may be some bugs or issues. That is the uncertainty. So, and right now you don't need to worry. No one uses waterfall. There is nothing much to put effort and learn, because we are all today are on agile. Everyone uses agile now. Okay, the whole market, and the agile model was designed in 2001. Means it was written in 2001, but no one used until 2008 sometime. Okay, so the agile model, again, agile is an SDLC. Okay, Agile SDLC model, it was created to overcome all the challenges faced in that waterfall, because companies were not fine. Now, the first thing Agile did was to fix all the problems of waterfall. The first one is waterfall is a linear model, right? Agile is not a linear model. Agile is a circular model. Means once you complete requirements, again you can change the requirements, and again you can start the cycle. So in Agile model, for example, client gave you a requirement. Now client told, no, I gave a wrong requirement. Can we change it? So Agile methodology actually encourages or allows you to change requirements during the release. Means you already wrote or something part of it. Again, you are going to allow your client to change the requirement. And also in Agile, we always plan a very small release. What is a small release? Your client came and told you, I want you to add 5 features in the the app or in the application. Now you tell, these 5 features will take me at least like 50 or 70 days. I would try to break it into a 15 days small releases. We will give you one feature every 15 days instead of doing all the 5 features for 70 days, and it's going to be huge risky. What we do, we will try to do a single feature, and in a 15-day period or in a short period of time. So Agile always believes in shorter development life cycle. Means you always make shorter. Means you're not going to write code faster, but you release it in a small shorter release cycles. Agile always believes that, and Agile always enforces it. If client comes and tells you, you will tell, yes, we will do it, but we'll do it in a shorter cycle, so that the amount of code you change is small. It is easy to find bugs, it is easy to detect the bugs, and it's easy to fix. See, if you're changing code in 20 30 locations and you test it, it will be very hard for you to figure out from where the bug is coming, right? But if you are only changing small amount of code, you're writing small amount of code, it's easy to detect. And if you're writing less amount of code, you also can easily what what you call demonstrate it or verify it, right? It's easy because you're only writing a small amount of thing. So in Agile, you also do something called as incremental model. Incremental means client will give you something, right? You quickly design something and you show that prototype to the client, and you actually take the comments or the feedback of the client and you again iterate it. You have this iteration model in Agile. In waterfall, you never engage client will only engage at the ending. But in Agile, you engage with client more, and you actually deliver a working product, and you take a feedback and you change it. So it is incremental model, you make incremental changes. So there are a lot of benefits, and most of the time Agile is more what you call concerned by our developers, and developers will be knowing more. But from our perspective, you should understand that enterprise are all following Agile model. Means to sustain Agile, you should have everything faster, everything should be quicker, there should not be any human involvement, everything. Because within 15 days you should release. So you should understand 2 weeks or 3 weeks is a common time frame for a release in the agile based model. If you go to 4 weeks, it doesn't matter, but again you're trying to go to waterfall again. Okay, now in agile the customer satisfaction is high because you're going to actually involve him. You allow him to change requirements, you provide a kind of a prototype during the release. So agile is very good, and agile requires less planning. In agile you keep writing code, that's what planning is. Okay, requirements can be dynamic, so changing requirements can be entertained, and functionality can be created and tested quickly. Why functionality tested quickly? Because you're writing less functionality, because you're writing in a shorter cycles. That is why today most of your apps get updated very very often when compared to 3 years back, right? 3 4 years back, right, your apps were updated like once in a month. Now every app you get once in a week update now, right? So that you can understand the changes, because most of the companies are now agile is not 15 days mandatory, guys. Agile will allow you to drastically cut down. Lot of companies will have multiple releases in a single day. Okay, if you go to google.com, right, google.com has at least 20 releases every day, because they change the google.com algorithm 20 days, at least 20 times a day. So it's not that 15 is mandatory. A lot of people will have a 4 day 5 day 1 week. So because it actually has the provision to complete it very very quickly, it's not that mandatory 12 weeks. I'm just telling you an example. Okay, so there are not much disadvantage to agile, but people think that knowledge transfer is a problem, because in agile there's not much documentation. Your code is actually considered as your documentation. Okay, so and agile gives emphasis more on interaction than what you call documentation. So there are a couple of what you call, you we can't call them disadvantages, but in a because agile gives importance to individuals and interactions over process and tools. So process will not be much important, where the individuals and interactions are more what you call emphasized. So that's why people think it is kind of problematic, but no one thinks like that, because we know everywhere agile is used now. Okay, so why did we understand this? Because see, when as a DevOps engineer we are supporting them, it is obviously that we need to understand what we are helping them. Because you are, as a DevOps engineer, you're not going to sit in some corner in the office and you're going to work only together. Okay, yes, earlier admin teams, right, you were like that. If you are working in some admin job, you don't need to talk to anyone. You'll get simply some mail, you'll work it and close it. You don't need to interact with anyone. You're a Linux admin. Someone will tell upgrade the OS, you'll upgrade the OS. Someone will tell install something, you'll install. Someone will tell fix the permission. So you never need to interact. You never need to know the application. You never need to know anything. But in DevOps, you need to know the application cycle. You will be working with development teams, test teams, and some automation team, so to ensure that we're actually understanding this what you call reaching our release cycle. Okay, so we don't need to worry about disadvantages, guys, because this is not our headache. So as I told you already, understanding agile is not our headache. Okay, so let us not break our head on what we don't need to. Okay, now let's try to understand how does an application lifecycle look like in an enterprise. Okay, from the standpoint of operations. Okay, we don't need to much worry about development, right? Anyhow, we'll never do, that's not our headache. But let's go and try to understand the life cycle of an application. Okay, now, so let's understand what happens to an application. See, everything is an application. See, a lot of you from maybe from admin, so you should start thinking one step or above, or one stage above. You are never going to talk about server. Okay, we think beyond server. Okay, for us the most important thing always is going to be application. Okay, so for us always important is an application. We always think about from the standpoint of application and above, but not something below. So here every enterprise has at least 30 to 40 applications within a single department, right? Because you won't be supporting the whole company, because when we work there will be multiple internal teams, multiple businesses, multiple ways of running, right? So whenever, typically most of the time when we work in an enterprise or within a single department or single what you call a specific function of your company, right? You're working in a banking project. There may be investment, credit cards, uh, personal loans, finance loans, right? There'll be so whenever we work in one whenever we are working, right, it is very typical that you will encounter anywhere from 10 to 20 applications. Okay. And these applications may be a front end applications and a back end applications. So an application is nothing but one complete copy of independent copy of code, which is performing one specific function in a company. Okay. So here we will understand from the standpoint of what happens after the coding. We all know, yes, the developers will follow agile process or agile methodology. They will get the requirement from the client. They will write the code. That is not going to change. So here, once the developer write the code, what they would do is they would store the code in a version control system kind of software. Okay. So like GitHub or any multiple examples. But once the developers complete their work, right, what do? They are going to ensure that their effort they have put in writing the code is stored in a secure location, which is backed up, all those things, having backup, high availability, everything. Now once the developer writes the code and he's storing the code in a versional system, then the life of a DevOps engineer starts. Okay. Or it's not DevOps, but let's understand from the older generation application. Okay. Now what happens once the developer write the code? Okay. Once the developer has written the code, we should actually, most of the programming languages we use go through a phase called a build and a package phase. Because when you are choosing the programming language, right, see, when you are writing a business application, right, you want to write an e-commerce application or a banking application, or even it's oil and gas or retail industry or anything, right? Or if you're a car company, you want to display your cars on your website, right, for to show specifications or what you call the plans, anything. So when you start writing a business application, there are a lot of choices for you, right? You can write in Python, you can write in Perl, you can write in Java, but most of the times the companies choose a language which is always compiled languages. Compiled languages always are chosen more when compared to the other category of type of languages. The Java, .NET, okay, they come under the compiled languages, and most of the time you see these languages will be used. And now the third category of the programming language which is more popular is now the Node.js. Node.js also is more extensively being used now. Okay.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, once we write the code, when the developer writes the code, it is the responsibility of the operations team to get the code, download the code, compile the code, and package the code. Okay. And we have some tools called Maven for Java, MS Build for .NET, NPM for Node.js. Like that, we have small tools which are going to help us perform this compile and package activity. Okay. So, and this is called as a build phase, the build phase on application. And earlier there used to be a build and release engineer, but this job is now completely extinct due to the DevOps role. This was mostly kind of converted into DevOps now. So earlier we used to have build and release engineer whose only role was to talk to development teams, write build script, execute the builds, and compile the code, package the code. And once you package the code, you get something called as a file which is readily deployable. Okay. So once you have the file which is readily deployable, which is the output of the build activity, right, you get something called artifact. Okay. So, and the next thing is going to be deployment, right? Once the code is actually in a state which it can actually deploy, deployment is nothing but taking the code written by the developer, placing on appropriate server, and starting the application, right? because developer will write in GitHub, but that is not where the customer will come, right? Customer request will come to actual server to serve the request. So deployment is a simple process of taking the updated code, copying this to the server, then replacing the old code with the new code and restarting the application. It is the same thing for any programming language, whether it is Java, .NET, or you write for Python, it doesn't matter. It's the same formula. Deployment is, that is what deployment is. And when you're deploying applications, we always have three categories of servers in an enterprise. Okay, those are web servers, app servers, and databases. See, we all follow three-tier architecture. Okay, so I would like you to go and try to understand these terms. Okay, some of the terms are, okay, let me write here itself. Understand what is three-tier architecture. Okay, understanding will foundationally improve. Also understand what is the web servers and app servers. Okay, so you all know what is database. I know that, but some of you may already know, but if you want, you can go and update. So fundamentally, we always follow three-tier architecture. That is something we have been following in the last 2 decades, and will continue to follow. Okay, it means that when we are writing an application has two things: the UI part of it and the actual business logic of it. And the UI part is today mostly written and always written and served through a web server. Okay, and there are multiple web servers we have, but Nginx is the most popular web server. And web servers only serve the static content, means images, CSS, SVG, font, all of this kind of static content which do not change will be developed and deployed in your web servers. And the most popular your front end code we write is the React.js. The React.js is the most popular, and the React.js developer today is a gold mine. Okay, if you know React.js, then you are like everyone will kidnap you. Okay, it's that popular. So the React.js is the most popular way of writing the UI part, right? Today we have very, very responsive websites. That's where they write. And when you go to the back end, the actual business logic, right? Business logic means when you click buy button, right? There is a lot of processing happens, right? It will go and get the money from your bank account. It is going to go to the inventory. It is going to actually generate. So, or even you do a simple thing, right? For example, show my past 6 months purchases. Showing past 6 months purchases means someone should write a business logic of this user, get the user details first of this user, only calculate the last 6 months and go to the database, get the information. So this is business logic, right? Business logic is about actually performing the logic of application. Their UI will not do anything. UI will only display, but what will UI display? What are the backend will generate? That is what UI displays. So backend is a business logic. Okay. For example, you want to send money. That is a business logic. You want to send money to your friend. Then the backend application will actually process that. And finally, database. We all know databases will store the information. Whether it can be structured information or unstructured information. Structured means like name, mobile number is structured information. Unstructured is photos, right? Addresses. They're not much structured. Okay, so these kind of image, right? Someone uploaded their profile photo, right? Photos are not structured. So data will be uploaded and stored with the customer. And when you're deploying, you deploy appropriate application, appropriate servers, right? You can't deploy UI code into web servers and expect it to work. Okay, now, so once you deploy, then once you deploy, right? See, the developer wrote the code, you actually compiled the package, and then you deploy it and you restart. See, if you don't restart, the new changes won't reflect. So you restart the application, and then it goes to testing, right? So, and it goes to testing, then the testing team will be involved, or they'll be notified that, okay, the latest code is reflecting in the server now. You can go and test it, right? So they'll go and actually go and do the testing, whether it is 1 hour, 2 hours, or whatever it is, they will do the testing. Okay. And once they do the testing, then they are going to go and give the results, right? these testing they'll do. At the minimum, they may do integration testing, regression testing, load testing, UI testing. The testing team, they have their own ways of testing. Once they do, if they discover the bugs, they'll give the to the developers again. They'll give back to the developers. Clear? So this is the typical life cycle which is followed. No matter you go to Bank of America, you go to Wells Fargo, you go to Walmart, it doesn't matter. It is always like this. Okay, it's the applications will be designed in a 3-tier architecture. They'll be have a high availability. You have a HA databases, and this is the operations of an application. Okay, once the developer checks in the code. Okay, so this thing, what happens, right? Getting the code from the version control system, then performing the build activity, then deploying, then doing a sanity, then doing the testing, doing all the stages of testing. Testing is at least 4 levels. Okay, this is the smallest, and this is the easiest testing. This is a complex testing. Okay, this is the order of complexity of testing: integration, regression, load testing, UI testing. Now, earlier, before DevOps, what happened is this activity was being performed at the end of the release. End of the release means means tomorrow we are going to go live, or next week we are going to live. So before the release only, this used to happen. Or in a more specific way, this was being done after the complete coding activity. Means whatever the requirements were given by the client, the developers write the code, the required code. Once the developers have written the code completely, then only this stage would have been started earlier. Why this would have happened? Because performing this thing actually takes at least 1 day, where you coordinate with multiple teams. Each team performs their activity, whether they do it manually or automated, or they have their own shell script, it doesn't matter. But when you want to perform this activity earlier, people or enterprises took at least one day. Okay, and they did not have appropriate tools. So what happened was, this was called as integration. This complete thing what we talk is called as integration and deployment. Okay, integration means checking whether the code written by the developers, new code, is whether properly integrating and working as expected to the existing application. Right, already there is 1,000 lines of code, you're adding 100 lines more. That 100 lines of code, is it friendly or is it unfriendly, or is it actually making the application faster, application slower, or is it introducing more bugs? So there'll be some outcome of it, right? So that is the integration part and deployment part. That is what this we saw. But earlier enterprises used to do this only at the end of the coding part. Means once the code was completely written for the release. For this release, you are supposed to write, for example, 600 lines. So developers write all the 600 lines and they start it. Why did companies only did this at the end of the coding, but not during the coding stages? Means developer wrote some code. Let's say he wrote 100 lines of code. Why did we not do this? Because there was a lot of time and effort needed to do this, and at least 1 to 2 days of time. Companies were not willing to wait, right? See, developer writing 100 lines of code, now waiting 2 days to get the result of it. Okay, whether it is working or not. Again, he'll write some code. Again, we'll wait for 1 day. This does not work, right? We can't have developers sitting idle for 1 day, because we are all accounted based on hourly of our efforts. So that's why enterprises earlier, this actual activity took lot longer than expected. So enterprises did not do this during the development activity. They only used to do it post development activity. That's why it was always called integration and deployment. Okay, and now let's move to what actually DevOps mean. Okay, so that we'll understand how did it change everything. Okay, now when we talk about why DevOps, the first thing is what enterprises are looking at. Enterprises are looking at something called as a digital transformation, or something they want to engage with customers more often or faster when compared to earlier, right? Today enterprises wants to reach out to the customers. They want to ensure their bugs are taken on priority and they fix them, and they always ensure that the customers are getting the utmost what you call experience from their, either from their website, or their from mobile application, or any of the touch points from the customers interacting. They want it to be efficient and faster, so that if they detect something, they want to fix it faster. They don't want to wait for 40 days or 50 days. Out of all these outcomes, right, DevOps is something has become a mandatory, because if you want to ensure that you want to have a faster release. The foundation of DevOps is about faster releases. Companies wanted to push the changes faster out of the gate, right? Earlier it used to be 45 days, but once Agile came, when Agile came, right, people thought, okay, we are all the problems of IT industry is fixed. That is what people thought. When Agile came in, people thought, okay, with Agile now we'll write the code faster. Then it means that we'll our it's not writing faster, but you breaking it into small parts, right? Where you write it, you break it into smaller functionality. But the problem was Agile did not fix everything which was there. Okay, so as I told, it allows you to chance to test it faster. You have a rapid feedback from client, and we take the feedback and make changes. This is what we understood Agile. But applications were still not performing as expected after release, and there were a lot of delays in the release timelines. After companies implementing Agile, like Scrum methodology or Kanban, once companies migrate from waterfall to Agile, right, they did not right away get all the benefits what were discussed, because Agile told that you can now release faster, now you have this kind of benefit, those benefits. But when people implemented Agile, due to Agile, companies did not get all the benefits they expected. Why? Because the Agile methodology, if you go to Agile, right, Agile is nothing but set of rules, guys. Hard-coded rules you should follow. Agile is not flexible. Agile means these are rules Agile will tell you. You will follow the rules. Then you will become Agile methodology. So when you follow Agile methodology, like rules of Agile did not put enough emphasis on testing, efficient testing, and Agile had a complete lack of operations or high availability or maintenance. And Agile did not also has a way to efficiently integrate your application of what was not happening. So Agile have not what you call did not put enough emphasis on other things apart from development. See, if you follow Agile, then you will write code efficiently, you will plan efficiently and write efficiently, right? See, you planning and writing code is not what the whole company is, right? You need to integrate the code, you need to check whether this application is working fine with other application, right? Whether this application is actually performing better. And when you want to release faster, right, if you're not doing this properly, then what happens is the release were getting delayed. Means people thought that okay, they can actually release in 15 days, but they were never able to achieve it.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
See, Agile came in 2008 2007, as I told you, but people were not actually able to release actually in 15 days because they did not have the better outcome of this. If you don't do enough testing, how can you release it? If you simply release it faster without enough testing or enough things, you know that obviously some bugs will be discovered by the customer itself. Customer telling you application not working is a huge issue for us, right? It's kind of a lot of problem for the companies cannot bear that kind of right, people will start now blaming you on Twitter that okay, you don't know how to develop mobile application, right? People will start blaming you or scolding you that what happens if the app will keep crashing. So companies, we did not understand, they thought we implemented Agile, but why are we not getting? Because there were a couple of things Agile was completely missing, and those were lack of efficient testing, lack of efficient integration, okay, and lack of complete operations and how the high availability and everything should be maintained. And then people started slowly observing a pattern. Okay, these are the things which are our problems, so now let us fix them. So people fixed all those problems and they gave a name DevOps. Okay, from that's where DevOps came. DevOps is about going to help work along with your SDLC. DevOps will not replace your Agile, right? No, DevOps is not SDLC methodology, guys. That's a very important you should understand. DevOps is not SDLC methodology. As DevOps is a set of rules and practices which will help you actually achieve your SDLC as expected. So DevOps came from these pain points once companies observed that okay, there are certain aspects of our application lifecycle which are not actually managed by SDLC. SDLC is about only writing and planning code, but there are a lot more things we do, right? We will create infrastructure, we will do deployment, we will do testing, we will do integration. All those things were combinedly and made a set of best practices. Like, okay, if you do this, this is the efficient way. And from there, the DevOps term came. Okay, it is about ensuring that the development teams and operations team were working together so that we had an efficient application, so that we can release as expected, and also the application will be working as expected. Okay, so that's where the DevOps comes in. When we start talking, right, when you talk about these two major categories of people, developers and operations, they both of them have separate goals. Developers goal is to keep writing code and releasing faster. Developer will not care whether high availability is there or not, or whether servers are working or not. They don't care. Developer will only care one thing: I want to write code faster. i want to uh, I want to write code faster, then move on to next activity, right? Developer will not care about high availability, all these things. For an operations engineer, he does not require speed. What he requires is stability. Operations team always want developers to write stable code, so that his application, his server will not crash, application will not crash, he'll not get memory issues or file system issue, or what you call server slowdown. All these things will not come, so that operations team will be happy, right? So both of them have separate goals. Now the problem is developers want to write code faster and test faster, but the existing enterprise, the way it was developers did not have a way to test multiple times or test each time they write code. So developers were writing safe code. See, if you are a developer, I am not giving a chance for you to test every time you write code. Then what you will do, since you're not able to test very often, you try to write some safe code which will always expect to work, but you may not be actually writing efficient code, because you actually suspect, okay, if I do a lot of experimentation, the time will come, right? For the release time will come. So if the release time comes, then you'll get actually a problem. So enterprises wanted developers to be more productive, and also the DevOps operations to be more productive. So let's talk about how can we make these teams productive. Remember that a DevOps engineer's role is to ensure that every person in the enterprise is more productive. That is your single line goal. Okay. So you need to make everyone more productive and get more benefit out of that resource. So, and we only have two categories, right? So how can you make a developer productive, right? How can we make a developer productive? There are multiple things we can do. One thing is we can help him all required tools on his laptop, right? He wants Visual Studio Code, he wants Java installed, he wants something. So one of the ways is improving developer is providing all the tools he wants. That is, for that you don't need. Okay, the next thing is the next or the big thing we can make a developer productive is when he writes a code, if we are going to give him a chance to get the results of the code, what is the outcome of this code on the application? If the developer can know that, he'll really be more productive. What does it mean? See, developer wrote some 10 lines of code. Okay, now this developer want to know, due to this 10 lines of code, how is my application behaving? Is it actually crashing? Is it actually working better? Or is it actually performance is going down? If we can give that to developer will be very, very happy and he'll be more productive. Why? Because he'll write code, he'll understand what is the outcome, so that he'll continue to write code faster, instead of he doing guessing game or understanding, not understanding, right? And that is called as the developer feedback loop. We can actually close the feedback loop. But if today developer wants that in a company where DevOps is not there, what developer will do? Developer will send a mail to this build and release team telling that I want you to get the code from this specific GitHub, this branch of the code, this repository. Then they'll get the code, they'll compile. Then you may need to send out mail to other two teams like web server team, app server teams, or you may need to send it, you may need to open a ticket like change ticket, right? We all have service now or remedy, right? So you actually work on, you go to some tool and raise a ticket. Who will raise the ticket? Developer only should raise ticket, because developer wants the work done. So developer will raise ticket. Now this team will do when they're free, because they may have some other work. Then testing team, you need to send a mail to testing team, test it, right? This is what developer doesn't want. Today developers do a lot of things apart from development, is managing the release. Managing release means, see, someone should actually try to understand, right, where is the release. Means what is the progress, how much code is written, how much is tested, what is tested. If you want, who will know? The developer only will know it. But we actually want the developer to be actually writing code, but not sending mails, opening tickets, following up, checking it. That is not his job role. But a lot of developers do it today because they actually cannot progress without that. So how can we fix it? So you can fix it by removing all of this from the developer's responsibility. We will tell developer, see, you write a code, you run some job, you will get the results within 15 minutes or 10 minutes. So we will tell developer, you don't worry about sending mails or asking, you write the code. Moment you write the code, we will get the code downloaded, compiled, packaged, deployed, or even do a normal verification or a complete verification and give you the results in a very, very short period of time. That is where a DevOps team is going to make the developer productive. Okay. Then how can you make an operations team productive? A lot of times operations team want to do a lot of new experimentations, or they want to actually spend time to improve something, but operations team will be very much busy because they may be doing some patching activity or configuration management, or some activity they'll be recurringly doing something same over and over, right? So a DevOps engineer can actually use some of the new generation tools to actually completely automate most of the operations activities. So the operations team can actually do what they want to do to make the environment stable. So who is going to do? You as a DevOps engineer are going to do. Okay. And we ensure that these two important teams are more productive. Okay. Clear? That's what DevOps is. But since there was no actual person to coordinate or achieve all of these higher level efficiencies, the developers and develop operations teams were a lot of times having back and forth, and they used to have conflicts, and this also actually earlier impacted efficiency. Why? Because the developers would never tell what is happening to the application to the operations team. Operations team will never tell to developers what is happening on servers because they don't communicate much. So DevOps is all about ensuring that we have a proper collaboration and communication with the teams, and in an automated way. It doesn't mean that they should have meetings every day. We should have a visibility into what is happening. That's where the DevOps comes in. Okay. So through DevOps, we create this a continuous integration, continuous delivery, continuous testing, continuous. There are multiple continuous terms. Okay. Through this, we create a kind of an automated continuous loop wherein everything being made can have visibility, and so that people can understand what's happening so that they can be more productive. That's what a DevOps is. Okay. So here DevOps is software methodology. This is wrong. I told them to update, but they don't update. But don't read this line. So DevOps is not software methodology, guys. DevOps is nothing but it's a set of practices and set of rules. Okay, which has been designed to improve the collaboration between the development teams and operation teams using various automation tools. Okay, and these automation tools are implemented at various stages of the DevOps life cycle. Yes, DevOps has a life cycle, but DevOps is not SDLC. Okay. So DevOps has multiple stages, and part of it, we implement specific tools at specific stages. Okay, and there are totally actually 5 stages we talk about when we talk about DevOps. Okay, and they are continuous development, continuous integration, continuous deployment, continuous testing, and continuous monitoring. Okay, so some of them will be not our responsibility, like continuous development. We don't write, but we help facilitate code or the tools which are going to be used for writing. Okay, and out of all these 5, right, these 2 are completely our responsibility, and this is where most of the DevOps role, what you call his work, will be there. Okay, so that's why we simply call CA/CD, but DevOps is not just CA/CD. It is also about ensuring continuous testing is happening, continuous monitoring is happening, continuous development is happening. But these are very minor or sometimes not our responsibility. So continuous monitoring is minor thing, but the other 2 are, it's not, they're not just they're not minor, but they're not our responsibility. But we also provide anything we want. So development teams want to code better, plan good, anything we can do, we can do it. So let's see from the each and every one. Okay, the continuous development. continuous development means this stage involves about the code committing and also the code build activities, or kind of tools which are going to help facilitate the developers to write code faster. So write code and also collaborate better. So the newer generation of version control system tools like GitHub and Bitbucket are more commonly used when compared to SVN and Tortoise SVN, or other clear case or TFS, Microsoft TFS. These kind of older generation tools were not much productive, and they were actually what you call making developers slower or not much productive. So in a continuous development scenario, providing better tools for coding and versioning are something we can do, like providing newer generation of tools like GitHub or Bitbucket is something, and also providing proper tools like the build tools like Ant and Maven. So these things come into your continuous development, okay, like better coding and versioning tools. So here is it, there is nothing much to do, right? Once you have a GitHub in your company, that's it, there's nothing much you'll do. So that's why continuous development is not much. But once you come to continuous integration, this is where the most of the DevOps comes into picture, and the CI is the heart of your DevOps. If you're not implementing CI, then you can forget about word DevOps, and you should not even use the term DevOps, because the whole CI is the, what you call, you can call it as the, what you call, epicenter of DevOps. Like everything is, for everything DevOps, the CI sits in between or the center of everything. Okay, so it is the most important or the most critical stage of your DevOps lifecycle. It deals with integrating the application cycle. Okay, so if you need to understand what does integration actually means, okay, then only you'll understand what does continuous integration means. Integration means there are actually 3 to 4 things. Let me see if it is somewhere here. Okay, it's not there. Okay, so continuous integration means code checkout, then compile, then run unit test cases, then run any static testing, okay, and then package the code. So these stages actually compromise your continuous integration. Okay, running static testing means, so go back and check what is static testing, you will get to know some. So static testing tools will be like your Sonar Cube, okay, or Veracode. There are actually so many tools. In DevOps, one headache is like you'll have hundreds of tools. Over a period of time, you'll easily remember 100 tool names. So Sonar Cube, Veracode, Black Swan, Synopsys, NextIQ, White Source, like there will be too many. Okay, WASP 25. Only this stage itself, I can tell you 30-40 tools.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Based on the company's requirement, they'll do. Okay, so they are called static testing. Okay, so there are 2 types of testing, guys. Testing overall is categorized into static and dynamic. Further only everything will come. Okay, so try to understand what is static testing and dynamic testing. Okay, so these things are actually part of integration. Okay, the integration stage. So the question is, I already told you multiple times till now, earlier integration was happening at the end of the coding. Now when we come to DevOps, we get the term called CI, or continuous. Continuous means we will perform this activity each time the code is changed. What does continuous integration mean is, each time a developer is changing the code, I would try to perform the integration completely. One complete integration cycle should be executed each time there is a change of the code. Okay, so how do you know whenever there is a code change is whenever there is a push activity on your virtual system, then that signifies that it is a actually a code change. Whenever there is a push activity on your version control system, then you will try to set up some automated triggering mechanism like webhook triggers like that, and then you will perform it. Okay, so that the developer doesn't even need to come to some tool and trigger a job kind of thing. Okay, so continuous integration means, the foundation of continuous integration is, every time there is a code change, we expect the code to be compiled, unit test case, run static testing, and package the code and check if you're having any issues, because performing these things earlier will safeguard hundreds of hours for us, because sometimes we may get code conflicts, or unit testing will be failing because you are changing some functionality, right? Some kind of code quality can come, sometimes some security your application security quality may come down, or your packaging sometimes may have issue because class not found or some kind of issue. So all of them can be detected very very early stage in the development. Okay, that is continuous integration. And companies, developers want to perform this. Earlier it used to take multiple hours or half a day or a day. Now it can be completed within couple of minutes. That is what continuous integration is. And trying to perform continuous integration, see, DevOps is not just about telling how to do, it is also about performing it in a highly automated way. So now I told you what you should do. You can do this in two ways. You can hire 100 more people and do perform this actually manually every time the developer is changing, or you simply get some automation tool and simply automate it, so that you can still remove the existing people also from your company, right? So DevOps will tell you that every time there is a code change, I expect you to perform this. And how do you perform it is actually your responsibility. You want to go and use, for example, Jenkins, it's up to you. You want to use Bamboo, it's up to you. DevOps will never tell you tool name. It will only tell you how it should be actually performed in a proper way. The tool is up to your choice. That is why in DevOps there are so many headache tools. Okay, DevOps is not telling use Jenkins only, or use Bamboo only, or use what you call Circle CA or Travis CA or Team City, or what you call Harness, or GitHub Actions or GitLab CA. There are at least 15 20 CA tools. No matter the tool, your responsibility is to perform this every time code changes and inform the developer the outcome of it, whether it is successful or failure. Okay, clear? That is what a CI is. Okay, now that you know what is CI, like what happens actually part of CI and what we try to do. Okay, so once you, the CI is planned to run at every stage of your what you call your what you call at every time the developer is changing code, so that we have a very very quick insight of how the code is actually working on the integration part. Here I'm not deploying the code, right? See, I did not tell you deploying the code, starting the code, running the code. CA does not involve deployment, restarting the application, deploying configuration files, all these things. CA is only about compile, unit test, and packaging, so that we know what is happening, so that we can find out further. Now the question comes, the same question always is there. Now if I, in my company, if I only implement these two stages, right? Let's talk about the first two stages. I have set up GitHub to my developer. Okay, GitHub, due to GitHub my developer is now more productive because he's able to collaborate faster. He's able to now actually work better. So now if you implement these two stages, okay, you have implemented continuous development, continuous integration. This is also the order in which we set up, guys. The DevOps lifecycle is actually in a specific order. It's not that I have written like this. The DevOps lifecycle has a specific order. This is one, this is two, like that. Okay, this is actually in a specific order. So in this order, if you have installed these two stages, do you think it is good? It is already good. When compared to not having DevOps, you're already in a better position to understand what is the outcome, and also try to find a lot of problems during the each time you're doing the development. But if you want more clarity about the clarity about my application, because we are all concerned about the application, right? See, for us everything is code. Okay, see, when the client is running, right, client does not care whether you're writing, whether you're using which tool. The client expects the efficiencies in the release, right? See, when you see only till manager, senior manager, people talk about software. When you go to vice president or when you go to directors, right, they don't care about what tool you're using. They only care about the outcome and the quality, right? See, if you go to CEO and CIO, they'll not talk about Jenkins. They'll talk about the business plan. They'll tell, okay, this feature will release. This is the target. This is the revenue will target. This is the business will target, right? So the business doesn't much care about the tools always. They only care about the outcomes, right? So now the business wants more visibility to the application. Due to these two, we are already giving a better visibility. But if you want more better visibility, then the next thing I can do is I can actually take the code, deploy onto my server, start the application, and then do a better way of understanding. Because if you further deploy it, we'll also know the deployment issues, server issues, or any what you call platform issues, OS related issues. All these issues will further know, means we will further get more confidence, right? It is all about giving more confidence to the enterprise, right, about what they're writing, what they're planning. So if you implement now the continuous deployment, we are further adding more clarity to our application. How do we do that? When you go to continuous deploy, when we talk about deployment, right, in a high level, the deployment is about what you call getting first getting the latest packages or latest code. Let's not go to these terms. Now let us be a little simple in terms. Getting the latest code to servers, right? Because you need to get that on the server, and then uh, you replace old code with new code, uh, and if you have any configuration changes, right, there are a lot of configuration changes like xml files, config.xml, server.xml, application.yaml. There may be a lot of configuration files. You update the configuration files, and finally restart the application. This is your deployment. Now if now continuously perform continuous integration and continuous delivery along with your continuous deployment, now I am going to get further insight into my application each time developer is changing code. So next time the developer is changing code, not only it is going to perform the CI steps or the integration steps, it's also going to perform the deployment steps, right? And the question is, today the development teams and the operations teams most of the times are not in under the same management or same manager. Sometimes they may be in different locations, or even sometimes they may be in different companies, right? Because for example, you have a bank. That bank, right, see, remember that in IT industry it is very rare that all the departments will be given to same business. Means your Infosys, right, Infosys will get the development and testing project. For the same company, that same company will go and give that operations team to HCL. It is very often you see that. Okay, it's not like rare, it is very common also. No company will be given the whole end to end, because that time the company which give project will be in a very very tight situation, because that time the service company will own everything, right? So companies will not do that kind of mistake. That's a different story. But what happens is, sometimes you're not in the same company or in the same building or same business or same manager. What happens is, these two teams most of the time are completely disconnected, right? They are disconnected. Their goals are different, their managers are different, their work style is different. Developers does not need tickets and incidents, but operations team always work on tickets and incidents only. So deployment part also was taking a lot of time, lot of effort, lot of people to be involved. That is why companies were not doing every time they changed. But if you bring the concept of continuous integration now, or continuous deployment now, means having a system in place where without human intervention I can continuously deploy the changes to my applications with a very very minimal effort, and reuse the same automation every time. I don't need to write new program every time. Whatever I write should be always working without human intervention, which should be very scalable, which is easy to implement, and it is easy to understand. That's where the continuous deployment means not automating. It is about having a system in place to propagate the changes at any point of time into our environment or to our servers without human involvement. So again, there are multiple tools in the market which will help you achieve your continuous deployment. Okay. So there is Ansible, there is Puppet, there is Chef, right? There is SaltStack. If you don't like anything, you also can write shell script or you can write Python. Again, DevOps will never tell you which tool to use. DevOps always tells you what does continuous deployment mean. Continuous deployment means you should perform the deployment, how complex it is, without the involvement of a operations engineer or anyone, and have the capability to do that over and over with minimal effort. That is what continuous deployment is. Okay. So again, it is giving you a choice. So you choose the tool which is best for your use case and you do it. But again, there are popular always choices. Ansible is the most popular choice today for the continuous deployment in an enterprise. Okay.
Now that you have more insight into your application, right? Because now you're deploying the code, and during the deployment, there are a lot of things which we would like to know the outcome of that deployment. And through continuous deployment, every time we are developer is making change, we now perform the CI part and the CD part. So when you deploy the code, and deployment is nothing but replacing the old code with the new code, and then updating the required config files for the application, and then restarting the application. Now this is all good. Now you have what you call automated a lot of part, and you're giving that insight to the developer a lot now by going into these three stages. Okay, continuous deployment. Now when you go to continuous deployment, you have a very good insight, and now it is that you are completing all these three in an automated way, and that too, it is happening every time there is a code change. But you want further insight into your application. When do you get a complete insights? Insights means when do you get a complete understanding of the code change is when we are actually going to test the application, right? Testing means logging into the browser, or making a REST API call to the backend application, or checking the UI application through a browser, right? Until unless you go and verify the application and check the result, that is when you get a complete insight into the application. So part of the continuous deployment, though you implement continuous deployment, yes, there are multiple areas we get a clarity, like whether it is deploying correctly, whether the config files are properly working together, are there OS issues or platform issues, or all of them will be actually known very early stage in the development cycle once you implement the continuous deployment. But the continuous testing is also a very, very important part of the DevOps. Why? Because once you implement continuous testing means continuously testing your application, whether it is what you call backend testing, UI testing, or integration, regression. See, there are different kinds of testing we can do, right? Doing those testing, part of your code change will further give the confidence to the developer, and be making the developer more informed about his code changes, so that he'll actually know whether the application is loading correctly, UI is loading, or the buttons are still up and running, or the page interactions are running fine or not, whether the pages are moving, all of this. Because you're actually doing testing. But again, doing testing manually is nowhere going to allow us to be productive, because again, I need to stop my automation, then move out of the automation, send an email to the teams responsible for doing that manually, and they will do that based on their bandwidth, right? You can't ask testing team to do your testing. He may be doing testing of other applications. So based on the bandwidth, the testing team will test it and come back and give the results. This is where the importance of testing will come. The continuous testing means it is about the performing that continuously without the need of human intervention. Okay, so this stage deals with automated testing, and it also means that to execute this automation testing, I again do not want my automation testing person to go and click that button. I also want to automate that also. It doesn't mean that, okay, I will write some Selenium program for doing UI testing, and when I want it, I will send a mail to testing team to start the testing. No, I don't even want to do that also. Even though it is an automation testing, I do not want that to be manually triggered. We want that to be triggered in an automated way, so that I do not want the testing team to be completely eliminated from the execution part. Yes, I need the automation testing team to write the test cases, update the test cases regularly based on the code, but we do not want them to be involved during the runtime, because we want them to be triggering automatically, and the triggering will be happening through CI/CD jobs only. Okay, so continuous testing gives us the most and the complete insight into the changes being made by the developer, so that the developer will quickly understand what happened to the change. If we close this feedback loop to the developers write code faster, they test code faster, they develop faster, they understand the application, and they continuously, iteratively move faster, which is ultimately going to provide the companies with a more stable and more error-free applications, right? If you're detecting the problems at early stage, it is going to be having a huge impact. Let me tell a simple example. So part of your release means this release is a feature release. Part of the release, you have decided that you should write 600 lines of code to write a feature to your mobile application or web application. You have concluded that around 600-700 lines to be written, and what you do is you write 100 or 150 lines a day, because you can't write hundreds of thousands of lines every day, right? You only write 100-200 lines every day, because developers should write it, test it. So hundreds of lines is possible there, not 1,000 lines. So developer will write 100-150 lines a day, and it will take 4 or 5 days for him to complete it. So the problem is, and you all know that every time we write the code, they are interconnected, right? It's not that all the code is completely independent. You write some code, and on top of that, the other code will be written. On top of that, other code will be written, because the code is all related, right? It's all same application. So this way, the code you're writing will be interconnected and always connected. Now, since let's assume that you do not implement DevOps. You wrote the code first day, you write the code second day again, and then you write the code third day, fourth day, like that you're writing. Since you do not do continuous integration, continuous deployment, there was a bug in the first day of code, okay, which was not something you do not know. Why? Because it is a bug with the runtime. You only can know when the code was actually running on the server, only can know, because it is interacting actually with the database or everything. So since it was not doing, it did not know. And now you wrote some code, related code from day 2, on day 3 or day 4, you wrote some interconnected or related code. Now when you go to testing, once you complete the coding and do the integration and deployment, that day that bug will become a very, very big bug, or the problem will be in a very high level. Why? Because now to fix this code, you fix it, but the problem is there is some related code. Now you go and fix it. Now you go and fix it. Now you go and fix it. So the time taken to fix the bug or defect, when it is detected very late into the development cycle, is going to take more effort to fix it, and more code changes, and sometimes a lot of design changes. So that is the major difference. You performing continuous integration will allow you to find the problem on the day one itself. You fix it properly, and when the subsequent code you write will also be written fine without any changes. So these kind of advantages you only get when you're implementing DevOps. And also substantial cost efficiencies when you go to continuous deployment, right? Today you are having a lot of operations team who are manually doing a lot of things. If you automate, you are going to get a lot of efficiencies, not from the cost perspective, for the stability perspective, right? When you are deploying changes to your enterprise or any application deployment, if you are deploying this changes through automated way, we do get a lot of benefits. The first benefit is you are going to have a stable running environment. A stable running environment is very, very much needed for us. Okay, so now when you have this continuous deployment, right? A lot of people think that, okay, due to automation, companies will save money by removing people, right? The cost of the employees is not a big effort for a company, but the importance is the stability of the environment. See, you constantly make changes to your infrastructure. That is always guaranteed, right? You'll be upgrading your OS, you'll be upgrading your Tomcat version, you'll be upgrading your Java version, you'll be upgrading your database version, you'll actually upgrade your OS version, your kernel version. So there are multiple different components which will be constantly upgraded. You do patching, you do upgrade, or you do minor patching or major patching. There are always changes happening, right? A change is always constant. So when you have so many changes happening, the stability of the infrastructure is always very important. And when you are making these changes in a manual way or in a semi-automatic way, right, they are not scalable and they take time, effort, and which is going to be actually delaying your actual releases. So automating these activities is actually going to provide the companies with a stable running environment so that you can actually have the confidence that your applications always run fine without any infrastructure issues, right? So you don't need to worry about configuration drift, right? Today you made some change. You are not confident that tomorrow it will be looking the same because someone will go and change it on one server. Now what happens tomorrow? Developers will start complaining. This is working on server A, not working on server B. Now, as a DevOps engineer, you should now go and check multiple layers. Is the OS same? Is the kernel same? Is OS properties are same? Application properties same? Is code same? Right? Developer will tell code is same, but even though the code is same on two servers, it is not working. So then we config issues. So this is very common thing, right? Infrastructure having some drift in changes or infrastructure not stable enough is a huge problem, and continuous deployment is actually going to fix it. Okay. And today, most of the enterprises are looking for continuous testing or automation testing, right? Today, no one has manual tester. Very rarely, yes, it's not that manual testing is gone. Banking projects, you still need manual testing because banks always want manual testing. Okay. Yes, they have automation, but they still trust in humans. But that is not the case for everything. Most of the enterprises today do not need a manual tester. They always need a automation testing team. So it means that companies also are now finding efficient ways of testing, and that's happening. Okay. And part of this continuous testing, we are going to integrate. But where do we integrate? I told you, there are three different tools, right? Three or four different stages. How are we going to connect together to have a seamless, what you call a kind of a complete visibility, right? That is where again your CA tool will come. The CA tools are very, very what you call flexible tools, and they are highly customizable tools. So we are going to integrate the continuous deployment, continuous development, continuous testing, monitoring tools into a CA tool itself. Remember that when you talk about the CA tools, there are a lot of examples for CA tools. And one of the popular example of CA tools is your Jenkins, and others are your what do you call GitLab CA, or no, we have new. Okay, I will not confuse you much. Let me write two more. These are the popular ones. Okay, out of popularity also. This is out of popularity. These guys are very, very less popular. Most of the times you may not even hear them. Okay, but they are there. So this is a CA tool. Jenkins is a CA tool. Never tell Jenkins is CA/CD tool, DevOps tool. No, Jenkins is a CA tool. But these CA tools are very efficient in integrating the other tool categories. Means we integrate our developer tool like your GitHub into Jenkins. We'll attach it to Jenkins. Okay, and we'll attach your deployment tools like your Ansible or your Docker or Kubernetes. And you also attach your testing tools like your Selenium or your Cucumber. These are the two popular tools. Okay, so the complete visibility, the whole CI/CD, what comes into picture is through this CA tool itself. The CA tools actually allow you to perform the other stages also through the CA itself. But just because it is done, then that doesn't mean that it's CD tool. Okay, so we integrate our continuous deployment tools, continuous testing tools, and continuous development tools to the CA itself, and that's where you have the CI/CD pipeline. Okay, the CI/CD pipeline where we integrate all of the DevOps tools to have a complete visibility and perform them in a specific order of activities. Okay, first we do the continuous development to related tools. Then we do the actual CI step. You know what is CI? These are all things we do in CI. Okay, and then we integrate the CD tool. Then we integrate the testing tool, and then we further, and finally we have kind of a notification system. We send an email to developer, or you can send a Slack message, email, or a Teams notification. Anything is fine. Okay, Jenkins will integrate any of the tools and can send a notification. Okay, so that's where you as a DevOps engineer are responsible to manage them individually most of the time, and also sometimes integrate them. Okay, Ansible is not there to always integrate to Jenkins. Okay, but sometime you want. Okay, Docker and Kubernetes is not there for you to always integrate to Docker. Docker and Kubernetes, they are by themselves very large independent tools, but when we come to deployment time only, we'll integrate. Other times they are not integrated, they're not on same server. They have their own dedicated hundreds of servers running for them, but only deployment time we will integrate them. But these all of them are independently running tools, but we integrate them in certain fashion so that our application delivery or application lifecycle is interconnected, but they are all not on same server. They are different servers. They have their HA, everything, but in a small fashion, in a simple level, we connect them. Okay, so that this tool and that connector person is the CI tool. That CI tool is the actual glue or kind of a middleman who actually brings everyone together and runs as a single pipeline or a single flow, and that single flow is called as a pipeline. Clear? So continuous delivery, continuous deployment, there is a minor difference. They are not same. I mean, they are same only, but there's a minor difference. They are both same only actually. But the difference is continuous delivery is most of the time, that is what we implement in companies. We don't implement continuous deployment always. We always implement continuous delivery only. Okay. But when we are talking about the term, we talk deployment, but the delivery and deployment both are completely same. There's only one difference. The difference is if you implement continuous delivery, it means that you are performing automated deployment till non-prod. For production, you actually implement through a kind of a how do you call it? Kind of a approval process. Means, see, you are a banking project. Banking project will only have certain time when you can deploy, right? You can't deploy during the business hours. But a social networking website doesn't mean business hours. For him, there's no business hour, right? Facebook does not have business hours. Every time, everyone will keep using it. Morning, midnight, doesn't matter. So some companies, based on their company policy, or based on their business way, right? They want to release to production at a certain point, like on the weekends or the end of the business hours or midnight of the day or weekends, right? So in that situation, the production deployment will be approval or kind of a where we control. In continuous deployment, once the code is fine, that code will be automatically deployed till production without any human intervention.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Okay, so wherever there is a kind of simple intervention, means it is not manual deployment, but it is controlled through a button. Like you put a button for production, like until you click that button, it will not automatically deploy. For continuous deployment, there is nothing, no person will come. Like it will directly take the code, perform deployment directly to the production without any human interference. Okay. So if you want to achieve continuous deployment, it's actually a very, very tough thing. And most of the companies do not need it, or they don't, it's not implementing, it's not easy.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Every time we always do continuous delivery only. Means production is automatically deployed only, but you don't allow it to be run automatically. You run that button when you want, like when you want to release or the weekend or whenever it is. Now, we are already using monitoring for a very long time. It's not that monitoring is a new concept in the IT industry. We are always using monitoring tools. There are a lot of monitoring tools available in the market. We can choose and buy. But what does continuous monitoring means? Most of the time, right, when we talk about monitoring, people are only concerned about monitoring production servers only. Right? People are only concerned about monitoring production servers. We do not monitor non-production environments at all. So then how can we monitor a non-production environment, or why do we need, or what does continuous monitoring means? See, when we are doing continuous testing, we always will know, okay, that application is how it is running, what is the performance, what is the stats, but what there are some more things we can understand from the monitoring perspective is while your application is running, what is the memory usage, what is the CPU usage, what is the disk usage, is it generating more logs, is it generating less logs, or are there any threads issues, are there any what you call any system error messages, warning messages, like how are you going to know, right? Most of the times people ignore these important signals and they go to production. Suddenly you'll get alert 90% CPU utilization after production go live. So continuously monitoring means understanding the importance of monitoring in the lower environments during the dev environment or testing environment, right? During the testing environment, testing servers, we also enable monitoring, and we are actually going to then gather the stats of this monitoring and understand what is the outcome. And companies always have something called baseline. Baseline means they will tell when this Java application is running, it should only use 600 MB RAM, not more than that. That is a baseline. And companies expect that no matter how much hundreds of lines you're adding, it should not go beyond that, because it is not that easy or not unnecessarily going. Until unless you write a large functionality, most of the time memory, CPU usage should always be exactly same. Okay. So now you wrote something, suddenly it is not efficient, right? Suddenly what happens? Memory usage will go up. Or you wrote a code which is not processing properly, the CPU usage will increase. Or due to some things, there are some database warning messages being printed. So continuous monitoring is about collecting this deployed application feedback, collecting this and sending as a feedback to the developers again, because developers are going to be responsible for writing code, right? So we get that and we do that. That is what continuous monitoring is. Instead of just blindly monitoring production server, production environment, we enable monitoring to load environments, and then we gather the stats whenever we perform the deployment or perform the testing part of it. Okay, that is continuous monitoring. And continuous monitoring, again, DevOps will not tell you to go and download ELK stack or something or some many tool. It will tell this is what we should do. The tool is your choice. Okay, and when we start talking about these tools, right, like now we spoke about there are multiple stages and each stage is a tool. So let's talk about the tools again. Continuous development, the tools we will discuss mostly part of the training will be the Git, GitHub and Maven. Okay, so those are the tools we'll be talking, which will be categorized under the continuous development. For the continuous integration, we'll always use Jenkins. Jenkins is the most popular continuous integration tool. Even though Jenkins is open source and freely available, it is quite a bit complicated. It has hundreds of thousands of plugins, right? There are more than 2,000 plugins available in Jenkins, which provide you a huge customization. Okay, and every enterprise on the planet supports Jenkins. Okay, and that's one of the popular, and it's the most popular one, and it also has a powerful features when compared to other CA tools, and it's completely free. So the Jenkins is the most popular choice, and we will be learning Jenkins only part of CI, not any other tool. Okay. In continuous deployment, when you come to continuous deployment, right, the platform is rapidly changing now. Is if you are using a virtualization, right, then it will be your configuration management tools, which are going to be part of your continuous deployment tools category. Okay. If you are using virtual machines, whether it is an on-prem virtual machine or a cloud virtual machine. But if it is a virtual machines, is your target of deployment, then you'll use configuration management tools. Configuration management tools are used when you're using virtual machines or a physical machine, whether it's an EC2 instance or whether it's a VMware or it's a bare metal, it doesn't matter. If your platform of deployment is virtualization, you use configuration management tools. But if your platform of your deployment is a container platform, then you use Docker and Kubernetes part of your continuous deployment tools. Okay, and specifically Kubernetes is your tool where you'll be using it to deploy into your container platform. Okay, so it means that in the container platform is the most tools we'll learn. So we'll be learning your Ansible, we'll be learning Docker, we'll be learning Kubernetes. Okay, and then we'll also learn in a high level what is Puppet. We'll not go deep into Puppet. Okay, but Ansible is something we spend a lot of time and try to understand. Puppet is not something we'll go much deep because Puppet is not easy to learn. It's mostly legacy now, but we'll still try to spend some time and understand how that legacy thing works and how it's going to go forward. Okay. Continuous testing, we'll not learn anything here. Continuous monitoring, we'll learn Nagios. Okay. So that's the tools. So when you talk about that cycle, right, the cycle starts when developer makes a change to the code and checks into the GitHub. Then the whole DevOps cycle starts. Like this code will be then downloaded by your CI tool, because CI tool is actually connected to your GitHub. It will download the code. Once it downloads the code, it's going to perform its activity, the CI activity, right? The CI tool will do the CI activities like compiling the code, packaging the code, running unit test cases, running static test cases, packaging the code, and then once it packages the code, it's going to invoke the continuous deployment tools based on the platform of your deployment, like virtualization or containers, and it gets deployed, and then it's going to, if there is any monitoring enabled, that stats will be again sent back to the developer. Okay, not only the monitoring stats, but also the test results, part of your CI/CD tests. Okay, and developer will be, and this the most typical time for a CI/CD pipeline will be anywhere from a couple of minutes to 15-20 minutes is the actual time. Okay, and that's not a lengthy time. Developer can actually wait for that couple of minutes or 4-5 minutes and get that completed. Okay. Monitoring tools, as I told, Nagios is there. There are a lot of tools in the market. Okay. Prometheus, Grafana, ELK. Rollback also happen. Yes, rollback also happen. You also can write that logic. Okay. Post your deployment, you write a logic. If this is not hacked, then you go back to previous. So it's all about the how effective your testing is. Okay. Terraform is an infrastructure as a code tool. Okay. So Terraform comes. It is not continuous delivery or deployment tool. It is. It does not categorize there. Okay. Terraform is infrastructure as a code tool. It is an infrastructure automation tool. Okay. Now let's try to understand what is version control system. The version control system is a software which is going to help us record changes to a document over a period of time. So it is kind of a tool which will remember what changed to a document. So you have a small file called, for example, hello.html. So today you created, for example, August 1st. Then again you change the file. You keep changing the file every day. Again you send on second and third. So, but first day you added, for example, 100 lines, and next day you added again 10 lines and changed 2 lines. So how are you going to remember? One of the simplest ways to take a backup every day, right? I'll take a backup called hello.html _ August 1st. And again, I'll take backup one more file. So this way I'll exactly know every day what changes I'm making. So tomorrow I can open this file and open this file and compare the changes. That is one of the simplest way to ensure that you are versioning a code where you have multiple files with the same name, but ending you have some difference, and you'll do it. But managing like this is going to be very, very highly manual, and it is impossible to track. So for this, in the market, in the IT industry, we have a tool called version control system. A version control system is a software which is designed to record changes to a file or hundreds of files in a highly efficient way. Okay, which is scalable, which is collaborative, which is
everything we need in the market. Okay, so when you keep changing a file every day or once in a day or once in a week, you need to ensure that your recording these changes. And when you are working in enterprise, you are not the only person who will change the code. You have a team of 3 or 4 people, so these 2 or 3 members or 4 members can be changing. So we need to record, okay, today Gopi changed, tomorrow Ravi changed, tomorrow XYZ changed. So this system or a software is going to record these changes. That is what a version system tool is. Okay, it is going to manage changes to the files or multiple files over a period of time. Means it is never going to forget. It will store forever as long as you want. Okay, that is a versional system, and it helps us track changes when multiple people work on the same project. Project is nothing but an application, right? Small component. Like that, you have multiple components in an enterprise. Okay, so that's a versional system software. And version control system software is not new to market. It is there from a very, very long time, at least 30 years now. I don't think 30, but I think at least 20, 25 years it is. Okay, it is not a new software, but it is a new software which is learned by the DevOps team, or more probably an operations team, because the virtual system tool is predominantly a developer tool. So you are not going to be developer, and we are not going to learn in depth as a developer. So you'll ask me what is okay. Now let's talk about the distributed virtual system. Okay, so the virtual systems, as I told you, is nothing new. So earlier to the Git, there was something called SVN, the most used one from 2005 to 2015, around this time. Okay, so around this time frame, we had a very, very popular version control system software called Subversion. Okay, it was called Subversion. So this was popular earlier to the Git, but the Git has been now more than popular from the last 8-9 years now, at least 7-8 years. So it is very, very popular, and there is nothing kind of competition or tools. There is only one tool we use. It's only Git. That's how the market has become. There is no alternative. There is no option. So Subversion used to be the most popular older generation of version system tool, which Git has completely replaced. So before Git, what people used is SVN. Now we are using Git from the last 7 to 8 years extensively, and there is no trace of SVN at all in the market. Okay, so this is the old thing. We don't need to learn because it is completely extinct. No enterprise is using it. So we'll try to learn the latest generation of the version system tool called Git. So Git is designed on the basis of a distributed version control system. Okay, so distributed version system is a kind of an architecture based on which the Git is designed. Means Git will have some logic, right? How it will work. This is the logic. The logic is distributed version system is a logic on top of which the Git is designed. Means it is having this DNA. Okay, so before you understand Git at all, there are some terms you should understand. Okay, the first term is called as a repository. So a repository is a term which means the whole virtual system concept or VCS concept is built on this single word, repository. A repository is nothing but it's two things: the files and folders of our application, whatever the application. It is a demo application, very large application, very small application. An application nothing but group of files, right? You'll write one Java file, two Java file, whatever it is, plus version history. What is version history? The version history is nothing but actual history of what happened to these files over a period of time, right? You are having 10 Java files from last 1 year. You would have changed it multiple times. Not only you, but your team members. So somewhere it should be recorded, right? Okay, this person changed today, this person changed tomorrow, this person deleted a line, other person added a line. So that is recorded under the version history. So a repository, from the terms of in the terms of version system, is nothing but the files and folders of our application plus version history is repository. Okay, so the version history will stay along with your code. Okay, normally most of the people will think, right, whenever a software is there, then it is having some database where it is stored. Git will not have any database. Everything will be local to the repository. If you're having 10 applications, there is no central location for version history. The version history will be stored along with the code itself. Okay, so it is not separately stored somewhere outside. It is within the application itself. One folder will be created. Inside the folder, version histories will be recorded. That's how the Git system works. So there is no central database, nothing like that. Whatever changes are happening, it will be stored along with the application itself. Okay, so within repository there are two terms: central repository and the local repository. The central repository means when the repo is located on the VCS server. When the repo is located on the dev machine, dev laptop. Okay, so central repository means, see, obviously you should have some software, right, who has the brain of doing all these things. That brain is nothing but version control system software, which is nothing but, in our terms, Git. Okay, so when you write code, multiple developers are writing, we will upload in one central location all the code. That code is VCS server. So if your code is in the central, if your code is residing on the VCS server, you will call your code as central repository. For example, you want to make some change, you will download the code from central server to your laptop. That time, the copy which is downloaded on your laptop will be called local repository. The only difference is the location. Same code, same everything, but when it is residing on your local, it will call local repository. When it is already available in the central, you call it as central repository. Okay, so these are the three fundamental terms we should understand when we are trying to learn a version control system tool, and specifically Git. So in the distributed version control system, okay, so there are three developers, and we have one copy of code, because you know that for one application we will not have one developer, because the application will be big. 3, 4, 5 developers will be working on the same copy of code, because the code will be hundreds of files. So let us assume that you have an application, okay, and that application name is, for example, sales. So sales is my application. For sales application, there are three developers who are writing the code for the sales application. Now let's assume that you are starting a release. You know what is release now, right? A new change. It can be a bug release or a feature release, but we are starting a release. When you start a release, for example, on the August 1st, right, they all download the code. All of them downloaded their code to their laptop. Okay, so everyone downloaded the laptop, their code, because you always try to download the latest code, right, so that your changes will be properly reflected. So all three developers, they downloaded the code. Sorry, they downloaded the code to, they downloaded the code to their laptop, okay, from central, which is nothing but from the Git server. So they all downloaded on August 1st. Now based on their task, they'll start writing code for the new release, whether it is a bug release to fix existing bugs or to add a new feature. Now once the developer A, right, let's assume this is a developer A. Developer A has completed his task a little faster. He wrote the code, and once he wrote the code, he'll store the changes, right? The changes will be first recorded to the local repository. Means your changes will not be directly synced to the central. In turn, it will be stored in the local repository. Your changes will be first stored in the local repository. Okay, and you keep making changes. Once the developer feels that okay, the changes I made are good, he will then sync local repository to the central. Okay, there are all commands I'll tell you, but let me tell you the operations. He will sync the local repository to central repository. Once he syncs, now what happens? Earlier there was version 1 code. Now he wrote version 2. Now version 2 came here. Now there is no version 2. Let's assume. Now developer B also wrote his code, because he also got the work he did. Now he stored in his local, okay, version 3. Now once he stored his changes in the local, when he'll try to push, right, he will get an error. Why he'll get an error? Because he does not have the v2 changes. So if you try to update his the v2 changes will get overwritten. So Git is very, very intelligent. It will right away tell, boss, you don't have the latest changes. You first download the latest changes, then add your changes on top of it and push it. So he will run one small command. He will again download the latest changes, then add his changes on top of it, and he'll push it, this time successfully. Then your code will become V3. Now again, one more developer will be there. He'll also try to do push the same thing. He will write version 4 code. Again, same thing. Git will tell you, boss, you don't have latest code. I will not allow you to sync. So he will again download the latest changes, add his changes on top of it, and he'll push it. So it means that there is no concept. I know that you all will ask me corrupting same second, nothing will happen, guys. Okay, there is no question around it is getting corrupted. What if they do it the next same millisecond, microsecond, or nanosecond? There is nothing like that. Okay, it will always record the changes, and if the changes are not with the in sync with the developer locally, it will tell you don't have the latest code. Get the latest code, then add on top of it. Okay, so this is a distributed version system architecture, and on top of this architecture, Git is built. Okay, it's very simple. It will always know what is the latest copy. If it is not there, it will ask you to upload. Then you add on top of it and you sync it. Okay, so every developer will clone a repo to their local system always. You can tell me what if I don't want to update? I want to update directly. It's not possible. No, you can't update always. We need to get it local, and we'll download and make the changes. Okay. And the next question is, when you're downloading the code, what do you get from central is the most important question. So when a developer goes to central and tries to download code, what does he get? Your developer or the developer or anyone who is downloading will get the source code plus version history. Okay. When we download the code or the central repository, the local also, we get the code plus version history. Okay. So means when you're downloading, you don't just get the latest copy of code, you get the code and you also get the complete version history. Okay. Complete version history means you will have the list of all the changes what happened to code till now on your local machine, which you can verify with simple git commands. Okay, so for everything you don't need to go to central. You have everything with you in local. Whatever central has, it will give you local copy to it. So you don't need to if you want to do some activity, you don't need to go to central. Everything is in your local. You can get disconnected from internet and you can have simple git client installed and run. Okay, but what you will do with git, there are 5 basic operations, or the maximum you'll do is only 5 things. Okay, let me tell you what are those 5 things. So there are only 5 things we do when we start using VCS. Okay, beyond, see guys, version system is a very, very simple tool, and this is not a complicated tool. Don't think this is important tool. This is not at all important tool, guys. Okay, let me be very clear. Git is not important tool. Git is not at all something you work every day. Okay, what is important tools are your Ansible, Docker, Kubernetes, Terraform, Jenkins. Those. Git is not at all important. It is a very, very simple tool. You don't even spend 15 minutes of time in a week. Okay, so put this in mind. Now, so what are the 5 things you would do when you start working with version system? The first thing is, we should be able to store the changes to version system easily, whether it is a single file or multiple files. So when you are using version system, the first thing you'll try to do is we should be able to store changes to the system, either it is a single file or multiple files. That's the one of the most basic things we do, right? We keep updating or storing code into the software. Then what is the second thing we do? Ability to see or access the version history easily. So you are updating your file every day or multiple times. So you want to go back and see what happened to my code yesterday or at a certain point of time, right? So ability to see. So we should be able to see easily or access the version history easily. Like whether your friend, how many changes my friend made, whether what changes he made yesterday, what changes he made on specific day, all those things we should be able to see. And also easily compare the changes between the commits. So you made a change yesterday, your team member made. Now you want to only find out what happened between the change 1 and change 2, right? So yes, then you can also pinpoint. For example, you made a change today, you made a change 2 days back. Now you want to compare what happened between last 2 days. So specific checkpoint is called commit in Git. Checkpoint means right now, after next minute. So every time you make a change, there is a checkpoint in Git that is called commit. So you can compare between checkpoints so that you will know what is the difference between two checkpoints. And if at all you made a mistake, right, what you will do normally, you try to remember what all you made change the code. You try to go and use the editor and change back. But what if you made 5 or 6 Java file changes and reverting maybe taking 1 or 2 hours, or you forgot in all what all locations you added code? You can go to Git, you can simply do a simple restore command. So what it will do, all the changes will be brought back. So it's as simple as running a simple command. So you don't need to break your head and try to remember what changes I made, which files I made, all those things. With a single command, you can revert to previous version. So yes, because since it is storing, it will also allow us to restore a specific version of the code, which is very, very handy when testing team will tell you there is a code issues. And also one of the biggest important thing is it should provide us the ability to easily collaborate with other developers. Okay. So ability to easily collaborate with other developers is also something the Git provides. So these are the 5 things we do, and there is nothing much beyond we do. Okay. And most of them, if you see, are not something our responsibility, right? You don't write code, right? We are only responsible for managing the infrastructure, or what you call automating them, or creating this feedback loops, or integrating the tools, writing automation code, but we never deal with. So okay, clear? So this is all we do. Okay, when we work with any kind of version system, not only Git, SVN, or there is there are other older tools like TFS, but anything we do these kind of 5 things when we work with a version control system tool. Okay, let's continue. Now let's try to, now that we know the architecture or how Git is designed, right? What is local repository, what is central repository, right? So let's go to the Git. Now the Git is let's go to the official website and let me show you what Git is. So git-svm.com is the official website of Git. Okay, so if you want Git to know, this is the official website. And the first thing to understand is Git is an open source version control system tool designed to be freely available. Okay, and it is a free and open source distributed version control system. Okay, so it is designed on the distributed based version system architecture. Okay, so it is a free and open source and designed to handle everything from small to very large projects with speed and efficiency. Git is it's very, very speed. It is highly efficient. It can handle very, very large projects with thousands of files, which was something SVN did not have. So that's why SVN completely went away. Okay. And it is easy to learn. It has a very tiny footprint in its lightning fast performance. So that's why there is no comparison, or actually there is no competition. So that's why we never discuss about Git versus anything. There is only one thing called Git in the market. Okay. So all the old things, they're all completely dead now.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay. So that's the meaning of Git. It is free and open source, and it's distributed version system designed to handle everything. Now, let's try to understand what is the life cycle of a Git. If once we understand the life cycle of Git, we will pretty much understand how do we operate with Git. Okay, because the whole Git depends on this understanding this simple called life cycle. Okay, now let's try to understand the life cycle of Git. Okay, so before we go to Git lifecycle, let's try to install Git, and we'll try to run instead of going to theory, right? Let's run the commands and try to understand interactively. That is better instead of me telling theory again. I go back and create. So that is better. So that and the first thing is Git can be run from any machine. Either you can run it in your Windows machine or a Linux or a Mac. The Git can be installed. Okay, so there is no server client anything. There is only one installation, Git installation. Okay, so you go to downloads tab. You can download for the three major platforms: Linux or Unix, Windows or Mac. Why do you see what you call consumer operating systems instead of server? Because Git is mostly used by developers, right? So it is kind of needed for us to actually be available on the desktops, because most of the time, or 100% of the time, developers will all develop the code on their laptop only, right? So there are also what you call client operating system clients also, like what you call client operating systems like Mac or Windows, not only for the Linux. Because Git is morely developer, right? So developers will not use some Linux server to develop, right? He needs a lot of tools, like he will use Visual Studio, or he'll use what you call Eclipse. They'll use a lot of UI tools to write, right? So that's why Git is also available, and it's always used on the what you call our general purpose operating systems, Mac and Windows, because that is where developers will always reside and write their code. So but if you want to install Git, it is exactly same. There is no difference. So, and there's no Git server, Git client installation. There's only one installation. If you go to Windows, if I click this button, it will right away start downloading me some 40 MB file. Okay, so if I click keep, you see some 48 MB. That's it. You download it and you install it, and the commands are exactly same whether you run in Windows or Mac or Linux. Okay, I'm never going to touch Windows. I just click the button. So it's exactly similar whether you install Windows or whether you are operating the Git commands or Git operations on any of the platform. It's exactly similar. So we'll try to learn on a Linux platform. Okay, as I earlier told, I would never be discussing anything related to Windows. So as I earlier told, we would be using what you call Ubuntu version 18 as the platform our of choice for installing all the tools part of the training. So I'll be using Ubuntu only, version 18 only. Okay, because Ubuntu is the most popular operating system in the cloud. Okay, it's not that we randomly choose it. Ubuntu is the most popular operating system on the cloud. No matter which cloud it is, Ubuntu is the most popular operating system we have today. Whether it is what you call AWS cloud, Azure cloud, or Google cloud, Ubuntu is the most used operating system. Okay, and most supported one. Okay, so here you can choose what are the operating system you'd like to, and what are the what you call the instance type you'd like to. Okay, okay, the Ubuntu instance is up and running, and let me click connect, and let me connect to this machine. So I'm in my Linux operating system. How can I confirm? I can run the command to see my operating system. If I run this command, I can see that I'm on Ubuntu version 18.04. So yes, this confirms me that I have actually logged into my AWS instance on Ubuntu. Now, how do you install Git on the Ubuntu machine? So the official website gives us clear instructions. We can go to the official website, go to this first git-scm.com, click downloads, then click Linux or Unix, and based on the type, because we know that there are a lot of Linux types, right? So here we are Ubuntu, so it is telling apt-get install Git. So this is the command we are going to install. Okay, so first we need to always run update command when you spin up a new Ubuntu operating system. So run this command. This is needed for whenever you create a new operating system. If it is already existing running, you don't need to run this command. But if you have newly created the OS just now, then this is one time mandatory. Afterwards, it's not needed. Okay. Then after this, my command is this. Let me copy this command and paste it here. Sudo, because I don't have root permissions, I'm elevating myself to sudo. So just paste the command, hit enter. So it's telling Git is already installed. It is fine, because sometimes Git gets installed. So if it is already installed, it is more than enough. If not, it gets you installed. Or if it is little bit older version also, it will get upgraded. It is for all kind of scenario. If it is already there, it will tell you already there. If it is little older version, it will get upgraded. If it is already there, it will tell you it's already there. So Git is already there. Okay, that's good. But this is the exact command to install or to get the latest one. Now, once Git is installed, how would you check whether Git as a what you call an application is installed? You do which Git. Which Git will tell you where is the Git installed. So Git is actually installed in the USR bin directory on my operating system. Okay, so now I can do git -- version to check the Git version, or to verify in a most basic way whether Git is properly installed or not is I'll try to check the version command. So Git version is coming means, okay, I come to a conclusion that okay, Git is installed, it is installed in this location, Git is available, and I run the version command, it is good. So these are all the basic checks you can do. Now, once you install Git, what is your assumption? That is it going to start tracking every file? No. Just because we install Git will not start tracking every file in your operating system. So what you do first, let's take a scenario here from the scratch. So someone asked you to develop a new software or new application. That is something you are calling it as a let's call it as a chatbot. Okay, someone asked you to write a chatbot, right? These days we have chatbots, right? When you go to website, some pop-up will come, they'll ask you have any question, right? That's called chatbot, like chat helper. So someone asked you to write this application. Okay, so what you do, it's a new application, that code is not there already. So what you'll do as a normal person, not a developer, let's think a normal person, what you'll do is you'll try to create first a folder, right? You'll try to create a folder so that it may be 1 file, 2 files, 10 files, you can place it. So we'll do the same thing. I'll simply create a folder, chat-bot. Okay, I can create a folder. I'll go inside this folder. Now what I'll do is I plan to write the code for this application in this folder only, not outside this folder, so that it will be organized or I can easily know. Now, whenever you want to start Git, you always need to create a directory, a main directory inside which your code files and folders will reside. So I have decided that this is a folder inside which I will further create folders or files, but it is my main folder. So Git will ask you to run a command here. So if you do ls-a, see right now there is nothing here. ls-a will show you hidden files. So right now I am not having any hidden files, nothing. So we need to always initialize the Git. So Git init, but before Git init, Git will ask you to run a couple of commands so that we will use those details when we are working. So there are 2 commands you need to run, and that commands can be run from any location. It's not that you should run from here. I can even go to my temp location and I can run, because they are global commands. It doesn't matter from where you run. Even I can run from temp location also. Okay, those are git config -- global user.name. I'm just taking example as temp. Don't go to temp and run this command, because it doesn't matter from where you run, because they are global commands. I will give my command, for example, something like this. Okay? Then git config -- global user.email. I'll give some name. Okay, so this is my name and email, and once you config, you can also list them. So this is only one time activity, but why do I need to even do it? I need to do it because, see, each time when you make a code change, you don't need to explicitly tell Git, okay, my name is this, my email is this. So you need to tag this. See, when you are changing, when your team member is changing, we need to tag that, right? Okay, Gopi made this change. It should be recorded. So when it is recording the change, like checkpoint, for the checkpoint, it needs some details. What details? What is the current time? Okay, who made it change? What is that person's email? Right? What is a file changed? Like that, it needs some details. So instead of you providing every time, it will take the details from here. Okay, so that's why we are doing it. So on your laptop now, if you are developing 10, 20, 30 separate applications, everywhere this data will be used. So you don't need to type in every time. Okay, that's all. And it is mandated. It's not optional, guys. This is mandatory. We need to run these commands. Now, After this, you can go to any location you want. So I will go to my application or location, and here the first thing we should do is git init. The git init command will initialize git. Okay, this is the foundation of what we do in git. So if I do ls, I don't see anything, but if I do ls minus a, I will see something called .git. What is this .git? The .git is the actual version history folder. See, when you start making some changes to the code, git will record them, right? Record means, okay, like Gopi changed this HTML file, he added 10 lines, or Gopi removed 5 lines, right? So it should record somewhere, right? The timestamp, the name, email, and also file names, content. That is .git. The .git is your version history, where Git is going to actually store the changes to this complete code. And this chatbot is your repository. What is your repository? Chatbot. Chatbot is a repository. Inside that, Git is managed. And here you can create multiple folders, hundreds of folders, but all the history will be stored in this main folder level, which is a main folder. Chatbot is my main folder. Here I have my Git folder. So here now you can create any number of folders and files, but all its history will be recorded in the .git in this location only. You don't get .git created multiple. Okay. And right now we can consider this as my local repository. Why? Because this is in my local laptop. I did not upload still. Still it is my local repository. So now this location and code is called as our working directory. So in the Git lifecycle, there are 3 stages or 3 directories we have: the working directory, the staging area, the commit area. So the commit area is this .git. .git is your commit area. What is working directory? Your files. Whatever the files you see is working directory. Right now my working directory is empty. Okay, but I'll place some file, that is working directory. Okay, so let's try to go to the working directory. The place where your project resides in your local disk means the place on your laptop where it is located on your hard disk. On my hard disk now, chatbot is a folder. This is where the code is located. That is your working directory. That is as simple as that. Okay, this project may or may not be tracked. So if you don't run git in it, it is not tracked. So in either case, the directory is called working directory, and the project can be tracked by Git. See, if you don't track the project, then there is no question of Git. There is nothing we can do with Git. Your code should be always initialized or tracked by Git using the command git init, which we ran just now. Okay. By doing git init, it will automatically create a hidden folder, which is nothing but the version history. So this is your working directory where the code is located. I don't have anything, right? Let's create something. Vi hello.java. Okay, let's get some Java code. I'll not write, I'll get some example. If you see, this is a very, very simple Java program which will print hello world. That's all. It will not do anything. So I am just saving this file. Okay, so part of my code, see here I'm not writing relevant code, because here for us code is not important, the workflow is important. So I wrote a code.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Now the hello.java is in your working directory. Okay, so once you write the code and place the code on your hard disk, then it is called working directory. So your code is in working directory. Once you place the code in working directory, is it recorded? Means, is Git going to track this? No. Just because you write file, Git will not remember, okay, that Gopi made this change. We need to explicitly tell Git to record this as a checkpoint. So that is the most important thing you should understand. Okay, in Git, it is your duty to explicitly tell that you are going to record the change. This is important. You just write, Git is not artificial intelligence. It will not understand, it will not auto save. There's no auto save. You need to tell Git, see Git, I wrote this much. I want you to create a checkpoint till now. Again, you write codes for after some time. Again, you can create checkpoint. So it is you telling Git, create a checkpoint till this. Okay. And what should be included, what not should be included, everything is in your hands. So once you write a file, now you consider that, okay, this I want to make a checkpoint. Okay. So when you're trying to make a checkpoint, that is what the whole Git is. So how can you make the checkpoint? Is you create a working directory, you wrote the code, it is there now. When you want to tell Git to remember till now and make a checkpoint for it, we need to first move the file to staging area. So we need to provide the file to staging area. So the staging area is nothing but we are actually marking the files which needs to be recorded. So it is like you checking mark or you tick mark. It's kind of tick mark or marking the files. Which file should be tracked by Git is called staging area. Staging area is not any specific location on your hard disk or laptop, but it is marking. It is marking those files and put in a temporary staging area location. So how do you mark a file? To add files to the staging area, we use the command git add. So what I'll do is I'll do git add file name. Okay, git add file name. Once I run this, you need to add the file name like this. Okay, and once you do now, git status, you will get changes to be committed, new file. So you will get something like this, changes to be committed. Okay, so new file, it is a new file now. Okay, so add means I've added to the staging area. It doesn't mean that your file is gone. Your file will be there, but your file is marked now. Okay, your file is marked as a file to be recorded. So to record a change to Git, it is actually two-step process. It is not direct. First, we need to mark the file through staging area concept and finally commit it. Commit means what? This is the most important thing you should understand in Git. What does commit mean? Commit is, we will not use a checkpoint anymore because the actual term is commit. So what happens during commit? Okay, so the commit is the most important thing in Git because this is where it's going to record the changes. Record changes means, see, we know that there is .git, which is version history. Okay, so when you tell to Git, I want to commit this file, Git will actually take the hello world.java file and place it inside the .git and create a checkpoint on it. Okay, so it means that it is actually going to take the file and store the file inside the .git, and that file you can't see, it will store it in its own format which it will only understand. Git, whenever I make a commit to Git, it means that Git will take all the files which have marked, only marked files, not unmarked files, guys. Very important. Here I only marked one file. Only one file will be taken and stored inside. Okay, whatever the files you have marked, all those files will be taken and stored inside the .git, and it will create a checkpoint for it. Okay, with a unique ID called commit ID. So you can add 20 files, 30 files part of a single commit. It's not that, okay, for each file I'll make a commit. It's going to be confusing. So for example, you are fixing a defect. When you're fixing the defect, you may be changing 4 files. So accordingly, you have changed 4 files to fix the defect. Now you have confirmed that the defect is fixed. So you modified 4 files, and once you modified 4 files, the defect is no longer coming. So when you are committing the code, ensure that all the 4 files are done in a single commit, so that tomorrow your team member will understand, okay, Gopi made changes to these 4 files to fix the defect. So it will be easy for people to understand. So don't make one commit, one file. You can make any number of files, you can mark and commit. Okay, so commit means Git will take that file and store that file inside the .git folder. If you do 100 commits, it will take 100 times same file. For example, you change today, you change, so every day you are changing one file. Every day you are committing. Every day it will take that file. So you made that file 100 times and committed 100 times. 100 files of your file name will be inside. Okay, but always you'll only see one file. You'll never see that 100 files. It is only recorded in a specific way, only Git will understand. And how can you retrieve that information? Is through Git commands only. You can't go inside .git folder, do ls, all those things. That won't work. There are simple Git commands we need to use. Through that commands only, I can go back in time and see, okay, how many times someone has made change, what is the content, what is the difference between today's and yesterday's, or 1 week back to today. All those are Git commands only. Next time again you make a change and again you commit, again it will store the file. Okay, it will not remember the delta. Delta means it will not just remember what changed every time you change. See, for example, you will have a simple question. I have 1,000 lines code. Inside 1,000 lines, I only made one line change or one alphabet only. You made capital A to small a, right? Git will now again store the whole file. Git will not care whether you made a one alphabet change or one string change or one line change. Every time it will completely take the backup of the full file and store it inside for its reference. Okay.
All right, so why do we need continuous integration? Let's understand this using an example. So imagine yourself being in a company and where there are 3 or more developers who have been asked to add features to an already existing website. Right, so in the beginning you all were given version 1 code and you had to work on this code to add your features. So developer 1 had his features to add, developer 2 had his features to add, and similarly developer 3 had his features to add. Right, so developer 1 added his features and he submitted first, right, and he submitted to the to submit his work. He basically added changes to the version 1 code, not to the version 2 code, right? So his changes in the version 1 code had to be integrated with version 2 code, and only then it would amount to become version 3. And at the same time, testing was also supposed to be done. Once this was integrated, testing was also supposed to be done to see whether the new features who have been added to the website, are they not interfering with the already existing features of the website? Is everything functioning normal? So this was the normal routine, or this is a normal, I would say, the life cycle of a software development methodology, right? So once the bugs have been identified in manual testing, everything was given back to the developer saying that, these are the bugs, please fix them. Now, there were problems in this structure. You would say that this seems perfect, but there are some problems in this structure. Let's understand those problems. So the first thing is that because it took a lot of time in integrating things, and it took a lot of times in manually testing things, developers used to work on 3 or 4 features together, and at once, say twice in a 6-month time or once in a 6-month time, they used to commit their changes or to the source code management system, and then a manual integration was done because such a large code base is there. So a manual integration took a lot of time because there were a lot of features which had to be integrated, and I'm just talking about 3 developers. Imagine in a company when there are 100 plus developers working in the company, right, and everyone is committing to the source code management system. Now integrating that takes a lot of time, and this was a problem. So first you have to integrate that, and of course after that you'll have to test him, and testing was also done manually, which again took a lot of time. And because of a lot of time in manual integration and manual testing, it affected the time when we will give the feedback back to the developer. Now imagine you submit your work to the company, but you have not got the feedback how your work is. And of course, no person is perfect. Every code that goes through the software development lifecycle will have some bugs that we'll have to fix, right? So the developers used to wait for the bugs to come back from the testing team, and took a lot of time, and this led to a big gap in the software development lifecycle. It took a lot of time to develop code or to develop applications with respect to the features that were requested from the application, right? And because of this, there was a high risk and uncertainty when you look at it from the business perspective, because you could not pinpoint on a date which would near to the customer expectations. It always took a lot of time to make changes in an already existing application, right? So these were the problems before continuous integration, and we had to solve this time problem that we have so that our release cycles become shorter, our work becomes more accurate. And because of this, we came up with continuous integration. So what is continuous integration exactly? So continuous integration is basically the process of having shorter release cycles by creating small features in our code and simultaneously integrating them to our source code management system. But there's a catch: the integration and testing now happens automatically rather than manually, right? And this is why continuous integration is such a hype, and it benefits a lot of organizations, because not only do you have shorter release cycles, that is, your features are going out every day, but also you have automated integrations and automated testing, because of which a lot of time gets saved, right? So how does the time get saved? Let me prove you using an example. So this is a classic scenario of how things happen these days. So you have a developer, the developer finishes his code and he submits his code to the version control system, which is picked up by the continuous integration tool. Now the continuous integration tool automatically deploys it on the testing server, and the testing server automatically has build suites which have been defined for your application. It tests all the features of the application automatically, and if there are any bugs which are identified, probably a test case failed or something like that, it gives that feedback to the developer. And all of this happens in a matter of minutes, right? That's how fast it is. Now imagine yourself in the earlier world, when I told you it took a lot of time to manually integrate things, to manually test things. So you used to get feedback in days, if not hours. And in this case, that is today, you get automatic feedback in a matter of minutes. And this has led us to improve our release cycles in such a way that today we are getting releases, 2 or 3 releases in a day. Earlier, we used to have releases twice or thrice a year, and now we have 2 or 3 releases every day. Obviously, it's shorter releases, shorter features, but that's how powerful our software development lifecycle has become with the use of continuous integration. And it does not stop here, right? With more mature continuous integration, or with more mature DevOps model, what happens is if your test succeeds, it is automatically also pushed on to production, right? And this is the power of continuous integration. Now obviously continuous integration is just a concept. If you want to implement it, it will be implemented using some tools. So we're going to discuss that in a few moments, but before that, let us summarize what we just discussed. Right, so the advantages of continuous integration include frequent commits and hence small feature updates to our website, but every day or every twice or thrice a week. Right, we have automated build and testing that saves a lot of time. It gives the feedback instantly to the developer, and also because of this, there's a low risk and faster delivery of products when you look at it from the business perspective. Right, now, like I was saying, that all of this is possible using continuous integration, but continuous integration itself is just a concept. Right, it can be implemented using hardcore tools, and we're going to discuss that in a few moments. So continuous integration is a topic for today, and the continuous integration tool that we're going to discuss today is Jenkins. Now Jenkins is an open source tool which is basically used for continuous integration. It is based on Java, and a lot of companies are working on Jenkins to get their day-to-day work in the DevOps lifecycle done. Right, so this is a brief introduction about Jenkins, and I already told you the features of continuous integration are all of them pertain to what Jenkins can do in your life, right? So without wasting any time, let's go ahead and start with Jenkins by first installing it on your system. So how can you set up Jenkins on your computer? Now there are a set of commands that you would need to run on your Linux box that would set up Jenkins, but there are 2 or 3 ways you can install Jenkins with. If you have Docker installed on your system and you are just into testing, you can have Jenkins installed in a Docker container. So with that, you do not have to set up your environment with Java. You do not have to go through the process of downloading things. Just download that container, and that would have Jenkins up and running on your system. Right, but this is a bare metal installation that I'm going to show you guys. So let me just switch back to my server that I've deployed on AWS to see how you can deploy a server on Jenkins. Alright guys, so this is how my AWS server looks like. So what I have to do is I have all the commands written over here in my notepad. So let me copy these commands. The first command will basically install OpenJDK 8 on my system. So let me do that. Okay, so it's unable to update. Reason is we haven't updated. So let me update the system first. Sudo apt get update, and once that is done, I'll install OpenJDK 8. Alright, so now it's installing OpenJDK 8. Next step would be to copy this command. This will basically add the Jenkins key in the repository. So let us do that. Alright, so this is done. The next step would be to install this command. Alright. So this is our next command. This would basically add the binary of Jenkins to this list. And now we're going to update. So our repository links gets updated. And now let's install Jenkins. Alright guys, so Jenkins is installed. So first of all, let's check the status for our Jenkins service. So for that, we can check it using service Jenkins status. Alright, so the Jenkins service is active. So our next step would be to open the ports of the EC2 server. So let us do that. So the inbound connections. Let's open all traffic to be on the safer side. If you want to be more secure, kindly open port 8080 because that is what Jenkins operates on. Alright, and let me click on save. Alright, so this is done. So now what I'm gonna do is I'm gonna come back to my dashboard. This is my Jenkins master. Let me copy the IP address, and this IP address I'm gonna use with the port 8080 to open Jenkins. So as you can see, the Jenkins dashboard is now visible. So the first time you install Jenkins, you'll have to enter the administrator password, which can be obtained from this path. So what I'm going to do is I'm going to go to this path and I'm going to cat over there. So this will basically, let me do a sudo. So this will basically give me the password, and let's copy it and paste it over here. Continue. And now Jenkins is booting up. So the first screen that you would see is customize Jenkins. So let's install this tested plugins. This would basically install all the plugins that we would require for today's session. So once you've clicked over there, your plugins will start to install. And we're going to wait a while till this finishes. All right, our next screen is going to ask us for adding a user. So let us do that. Let's give the username as Intellipaat, password as Intellipaat. Once you've filled out all the details, let's click on save and finish. And this would bring you to your Jenkins dashboard. So you would get the Jenkins is ready page and just click on start using Jenkins. All right, so this is how your Jenkins dashboard looks like. And we're going to come back to this. But before that, let's just go back to our slides. All right, so guys, we've successfully installed Jenkins on our system. Our next topic would be to understand the Jenkins master slave architecture. All right, how does Jenkins work in the production environment is what we're going to discuss over here. So the Jenkins master slave architecture is basically important to accomplish continuous integration. Reason being, your testing will always happen on the testing server, and your production code will always be deployed on the production server, right? So you always have to deal with multiple machines when you're working in a DevOps environment, and that is exactly why you need Jenkins master slave. So for in this kind of situation where you have to deploy your code to the testing server, Jenkins becomes your master server, and your testing server becomes your slave server for Jenkins, right? Similarly, your production server would become slave server for Jenkins, and the master Jenkins will only have the Jenkins installation. Jenkins will not have to be installed on any of the other systems which are serving as the slave of Jenkins, right? The third thing is, why do we need a master slave kind of scenario? So I've seen a lot of people basically just use Jenkins on the same computer where they have to deploy the code as well, and that is because they are not dealing with probably parallel jobs of deployment, or they're not dealing with complex builds, and that's the reason they have it on the same machine. But when you're working on the production environment, you have to have a master slave kind of an architecture wherein the testing and the production server would become slave for your Jenkins master. All right, so now what we're going to do is we are going to set up master slave on AWS, and let's see how we can do that. All right, so the first thing that we have to do is deploy two servers on AWS, that is slave 1 and slave 2, and then we connect it to Jenkins using the JNLP connection. So let's see how we can do that. So the first thing that I'm going to do is let me jump onto my EC2 management console and let me create two slaves. by specifying the number over here, that is 2. So we're going to launch the instances. So our instances are launched. Let us rename them as slave1.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And we have our other, which is slave2. Now, mind you guys, we will not be installing Jenkins on either slave1 or slave2. We will be controlling these slaves through the Jenkins master. Now, there are some settings that you'll have to do in your Jenkins master. Let us go through that. So the first thing, so this is your dashboard. So the first thing that you have to do is you'll have to go to click on Jenkins and go to manage Jenkins, go to configure global security. Once you're here, just scroll down and you will reach this section which talks about agents. Now over here we are talking about TCP port for JNLP agents. Just change this to random and click on save. Once you've clicked on saves, now we will go to manage nodes and now we will add a new node. Let's name this node as slave1 and now click on permanent agent and click on OK. Now over here you will have to add the launch method. You'll have to change it to launch agent via Java Web Start, and the current working directory path, specify that to /home/ubuntu and /jenkins. All right, just specify this and click on save. You will reach this screen. So I'll tell you what to do after this. For now, let's add one more new node. Let's name it as slave2 and we'll copy everything from slave1 and click on OK. All right, so everything is the same. So the remote root directory would be this /home/ubuntu and then Jenkins. All right, so slave2 is also configured. Let us check what we can do now. All right, so the next thing that you have to do is now click on slave1 and download the agent.jar by clicking over here. All right, so your agent.jar is now downloading. I had one before, so just ignore this thing. So this agent.jar is now downloading, and now I'll have to send this file to my slave1 server, and I'll show you how you can do that. Right, for now, just click on show in folder, remove the older agent, rename this as agent. All right, and now we'll have to send this to our slave1, and the way we can do that is by first selecting slave1, take the IP address from over here. You'll have to download a client called FileZilla. Just open that. In FileZilla, paste the IP address over here. Username would be Ubuntu for the Ubuntu operating system. Port is 22. And in the settings, you'll have to click on edit and then click on settings. Go to SFTP and you'll have to add the key file over here. I've already added that. Just click on add key file. Just go to your key file, select that, click on open, and it'll be added over here. This is important to connect because when you're connecting to AWS, the only method that you can connect to is using your PEM file or your PPK file, and this is the way you can add it in your FileZilla browser. All right. So once you have added that, just click on Quick Connect, and now you will be connecting to your slave1. So once you're connected, you will be given all the directories. So here are all the directories. Now I'll have to copy my agent.jar on my slave1. So just click here and it will copy your file to slave 1. Okay, so let us also verify that if our slave 1 has been copied or not. So let us connect to our slave 1. So we'll connect it using this IP address. Let us go to putty, click on new session, connect to slave 1, and let us give a special appearance to this. Let us decide a color on this. So let us decide the orange color. So the orange color is slave 1. So let's click on OK and let's click on open. Alright, so login as Ubuntu. Great. So now if I do an ls, I can see that agent.jar has been successfully copied. Alright, so slave 1 is done. Now we'll have to do the same thing for slave 2. So let us go to slave 2, download the agent.jar. While it's downloading, just copy the IP address for slave 2, enter it in FileZilla so that we can connect to it. All right, click on Quick Connect. So you will have the directory listed over here. All right, now we'll go here and we'll rename our agent1.jar to agent.jar, and the way we can do that is like this. So we'll just go here, rename this. All right, remove the older agent file and rename this to agent.jar. Once that is done, just drag and drop it on the server. And now let's connect to slave 2 using putty. So let's click on new session, SSH, add the file, and let us keep the color for this slave as white itself. All right, so this is slave 2, and if I do an ls over here, it's the agent.jar file has been copied successfully. All right, so now the next step would be to basically go to your slave and you'll have to execute this particular command at the place where your agent.jar is present. All right, but before executing this command, we'll have to install OpenJDK on both these servers, that is slave 2 and slave 1. So let us do that. So here's the OpenJDK command. Let us pass it over here. So we'll have to update the server first. So let us update it. All right, and now let's pass the command. All right, so while Java is being installed over here, let's do the same for our slave 1 as well. So let's update it first. So it's updated, and now let's install OpenJDK. All right, so while Java is being installed on this, I think we are almost done on our slave 2. All right, so slave 2, the Java is installed. So what I can do now is I can go to my Jenkins page and go to slave 2, and I can run this command over there now. And this is it. The moment you run this command, can you see it says connected? And the moment it says connected, just come back here, refresh the page, and your slave 2 is now connected. Let's do the same with our slave 1. Just copy this command, go to your slave 1, let's clear the screen, and paste this command. Alright, so now both the slaves are connected to your AWS Jenkins server and you're set. So if you see the nodes, you have a master now, you have slave 1 and you have slave 2. And this is what we were supposed to do. So let me come back to my slides. All right, so we have successfully set up Jenkins master slave on AWS. Our next task is to basically create a pipeline which would be triggered by Git webhook to deploy a project on Jenkins. So let us do that. So for that, these are the steps that we'll have to do. So basically we have a project. I've created a project on my GitHub repository. Now this project has a Docker file, and this Docker file can be built to basically deploy a website on Docker. All right, so we're going to deploy a website on our slave 1 first, which will basically act as our testing server. It will be pseudo testing kind of a thing, right? And if our website is successfully deployed on our test server, that is slave 1, it will then get deployed on slave 2, which will be our production server. So this is basically our job, and this should happen automatically. So a Git webhook basically means that the moment I commit on Git, it should automatically trigger a job on Jenkins. It should automatically deploy the website on my website on my testing server first. If it gets deployed successfully, then it should move forward and deploy the same on my production server. All right, so this is what we are going to do. So let us quickly go to our GitHub website to see how our code looks like. So basically this is my code, guys. I have the Docker file, I have the website in here. Docker Compose, please ignore it, we're not going to use it. So we're going to use the Docker file. The Docker file code looks something like this. So basically this is a container which it's going to pull, and after pulling the container, it is going to add the DevOps IQ folder inside the var www html DevOps IQ directory. This is inside the container. All right, so this will get deployed inside my server once I trigger it from Jenkins. Now to do this, first we have to install Jenkins on both the slaves as it is mentioned in the steps. And like it says, like we'll have to configure it in a way that if the build on Jenkins slave 1 is successful, then it should be built on slave 2. Once it's done, we should finally trigger the job using Git webhooks. All right, so let's do this, guys. Let's go ahead and start with the demo so that let's see how it can be done. All right, so the first thing that we're going to do is install Docker on both the slaves. So let us go to our putty terminal. Let's go to slave 1 first. Now remember, guys, you will have the connected state over here. Do not close this terminal, otherwise your connection will stop. So what I'll do is I'll just minimize it and I'll duplicate the session so that I can work in a different terminal. All right, so the first thing that we have to do is install Docker. So let's do that. Sudo apt get install docker.io. Okay. So Docker will start installing now. So while Docker is installing over here, let us do the same on slave 2. So just duplicate the session and go to Ubuntu. Now install Docker. All right, so Docker is being installed on slave 2. It has installed on slave 1. Let us check. So docker -- version, if we can do that, that means Docker is installed. Yes, so Docker is installed on slave 1 and is installed on slave 2 as well. Let's check. So sudo apt sudo docker version. Okay, so Docker is installed on slave 2 as well. Awesome. So our first job is done. We had to install Docker. Now our next job is to configure Jenkins to build the project on slave 1. If successful, should be built on slave 2. So for this, we will have to go to Jenkins. So Jenkins is over here and we'll have to create a job. All right. Now you can check the status of your slaves over here. So you can see that master is idle, slave is also idle, and slave 2 is also idle. Now first let's create a job for our slave 1. So our slave 1 basically will have a freestyle project, and let us name slave 1's job as slave 1. So, or let's name it as test. Okay. And then click on OK. All right, so the job has been created. Now the first thing that we had to do was to copy our code to the workspace. So let's just clone our repository, or mention the repository link over here, and by clicking GitHub project. Okay, and then go to source code management, click on Git, and mention your repository over here as well. Now because this job has to run on slave 1, we'll have to restrict where this project can be run and select slave 1, right? So slave 1 is job, and slave 1, once you select slave 1, this job will only run on slave 1. Okay, once you've done with that, the next thing that you would have to do is come down and click on add build step. But before doing this, let us check if my job is being built or my workspace is being populated by the Git repository content if I build this job on slave 1, right? So this would basically test our connection as well. So let's do that. So let me click on build now, and this will basically start a build wherein it will copy the Git content on slave 1 ideally, right? So the blue ball basically tells us that the job has completed successfully. So let us click over here, and I can see that it has been successfully been finished. So let us verify that. Let's go to slave 1, and if I do an ls over here, great. So I can see the workspace is there. Let me go inside workspace. All right, so inside workspace, let us see what do we have. We have test. So this is the job name. Awesome. So if you go inside test, do we have the Git repositories content? Yes, we do. All right, so my Git repository was successfully cloned into the test job. That basically means from my master, I'm able to build a job on the slave 1 node, which is great. So that basically means our connection is working fine. Awesome. So let's go ahead and go back to configuring our job, right? So what we want to do is we want to deploy the website which is mentioned over here in this repository to my project. Now the way to do that is by running this Docker file, right? For running this Docker file, I'll have to check what is the present working directory. So my present working directory is this. So let us copy this. And once you come back to Jenkins, you'll have to scroll down and click on add build step. Once you click on add build step, click on execute shell. What will execute shell do? So execute shell is basically used to run any commands that you want to run on the terminal of the other machine that you're trying to build on Jenkins, right? For example, we are trying to build on slave 1 from Jenkins. So what commands do we want to run over there? So I want to run docker build command. So I say docker build, and then docker build, and then the repository where the Docker file is. So it's over here. And then the name of the image that I want to give. So the name of the image would be, I want to say it's test. Okay. So this is the image name. Once the image is built, I'll have to run it. So let's run it on port 80. No, so let's run it on port 82. And then let's run the image like this. So this is the command for running the Docker image that you have just built, right? Once it's built, the next step would be to check whether it's there or not. We can do that on the browser. And I forgot one thing. I'll have to add sudo. And because this job can be built time and again, what we'll have to do is we'll have to remove the older containers which are running on the system, right? So for doing that, I can say that sudo docker rm -f, and for removing all the containers which are running, I'll have to pass in sudo docker ps -a and -q. This should delete all the containers which are running inside my slave 1. Now to check if my Docker file is building my containers or not, what we can do is we can simply copy the commands from over here. So the first thing that I want to do is I want to build it. Let's build my Docker file. So the file is now being built. Awesome. So it's been built. The next thing that I want to do is I want to check if I want to run this command, right? So for running it, the command is this. Let's copy it, paste it over here, hit enter, and my container is now running. So I'll have to check that if it's running or not. So I'll go to slave 1, copy this, paste it over here. So, and port number is 82. So I can see the Apache page. That means the container is working. Let's check if our files are being showed or not. So if I go to DevOps IQ folder, yes, I can see the website. So means these commands are running fine. But what I have to do is I have to check if it's running through Docker or not. So I have configured the commands over here, and these commands work on the terminal. They should work over here as well, right? So let's go ahead and save this. Okay, so our job has been saved, and the next thing that I would do is let me remove all the containers which are running over here. So for that, I'll have to do sudo docker ps. Let me remove this container. So the container is removed. Now let's go ahead and run this container, run this job. All right, so now let's go ahead to our Jenkins dashboard and let's build the project now to see if everything goes fine. So I've clicked on build now. All right, so it gives me a failed build. Let's see what the problem is. So the problem is over here. It says the first command sudo docker ps -a-q docker I'm require at least one argument. Okay, so I've got the problem. So the problem is there's no container running over here as of now, right? And that's why it is not able to remove any container, and that's why it is giving me this error. Okay, to solve this, what we can do is for now, let's in the configure part, let us just remove this line, or what we can do is we can start a container over there, right? So let's run any arbitrary container, docker run -it -d and then ubuntu. Let's run it so that there's a container running, because ideally there will be one container running at least on my system. So let's click on save, and now let's try to build the project. Okay, so the build has gone successful. Okay, for checking that, I'll say let's just refresh this, and yes, my website is being deployed over here. Awesome. So let me just do it one more time so I'm sure it's working. So let me just do a docker ps sudo docker ps, and let's remove this sudo docker rm-f, remove this, and now let's run our arbitrary container. Let's ensure that this website is now not working. So it's not working. Now let's build this project. All right, so now if I come here and I refresh this, yes, so the website is working successfully. Awesome. So it works on slave 1. Let us now configure the same thing in slave 2 as well, right? So let's come back to our dashboard. So the test job, this could be our arbitrary test job. So basically we are trying to deploy it on a server. If it gets deployed successfully, we are going to deploy it on the prod as well. So let's create a new job and let's name it as prod freestyle project. Click OK, and The GitHub project is going to be the same, this one. Let's paste the URL over here. And we have to restrict this to run on slave 2. Great. The source code management is this Git repository. And the build step also would be the same. So basically we want to delete all the containers which are running right now. So for that, it's sudo docker rm -f $docker ps -a and -q. Okay, next step is to build the file. So do sudo docker run -it -p, and we want to run it on port 80 because it's production, right? And the image name is test -d and test. And before this we forgot one command, which was sudo docker build, and then the directory, which is /home /ubuntu /workspace / the job name, which is prod, and then over here the docker file would be present, and I want to name it as say production. The container name would be production, and over here also the container name would be production. Awesome. So let's click on save, and let's now try to build it. But before that, we'll have to launch one container on test. So let's run an arbitrary container. All right, so container is ready. Now let's check by clicking on build now if this job is working fine. So I've clicked on build now, and if you want to see the console output, we can see it over here. Okay, so it says job failed, and the reason for that is got permission denied. Okay, so the problem is I forgot to add sudo. So let's add sudo. Let's add sudo over here, and that should be it. Let's click on save, and let's try it again. Okay, again we have a problem, but I think it's a new error, so let us try to resolve that. So it's unable to prepare context, and the path is /home /ubuntu workspace and prod not found. Okay, so let's check if this path exists. So if we do an ls, we have Jenkins. Okay, let's go inside Jenkins. If we do an ls, okay, so workspace is over here. So basically I'll have to change the path to /home /ubuntu /jenkins /workspace /prod -t and then production. Click on save. Let me check if there is a container running on my slave 2. If there is no container running, then I'll have to run one. So sudo docker run -it -d ubuntu. Okay, container is running, and let us also ensure that we do not have any website running on our slave 2. Okay, so this is the command that we are getting right. This is the output that we're getting right now. All right, so let's click on build now, and let's see if our build is successful. All right, so it's getting built. Let's hope for the best. Let's hope it's successful. All right, so it gives us a blue sign. Blue means that build was successful. Let's try to refresh over here. And yes, it works. Now let's just go to DevOps IQ folder and see if our website is up and running. Yes, so our website is up and running. Awesome, guys. Now, what I want to do is I want to trigger. So first, I want to trigger prod job only when the test job is completed. Now, let's see how we can do that. So we'll go to configure and let's see if we can configure this. All right. So I'll have to go to test job actually. Let's go to the test job. Let's go to configure. And over here, I'll have to go to add post build actions. Okay, let's click on that. And after this, we'll say build other projects. Click on that. And which project to build? I want to build prod and trigger it only if the build is stable. So if the build passes, only then it should start with prod. Okay, awesome. Great. So let's click on save. And if my test gets succeeded, then my prod job will run. All right. So let us check this as well. So let me try running it. So we can run the test job using a pipeline view as well. So if you just have to come back to the dashboard, and over here you'll find both your jobs. Just click on the plus sign that you see over here. And once you click on the plus sign, you should be seeing a build pipeline view option over here. If you're not, so that means the plugin is not installed. So let's install that plugin. For that, you have to click here, go to manage Jenkins, and then click on manage plugins. Click on available, and then search for build pipeline.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Build pipeline, select it, and then install without restart. Just click on that. All right, and now your plugin will start to install on your Jenkins server. All right, so my build pipeline plugin is installed. Let us go back to our dashboard, click on the plus sign, and you can see there's an option now which says build pipeline view. Select that and name this view as CI/CD or anything that you want, right? Click on OK. All right.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Everything seems fine over here. Build pipeline view title, let's name it as CI/CD. Okay, let's click on OK. All right, let's check. So in my CI/CD view, I just see the prod job. So let's see how we can fix that. So I want the test job to also be there. So let's see. So let's click on configure and build other projects after the test is done. Okay. Okay, so we forgot to choose the initial job. So the initial job will be test, right? And let's click on OK. Okay, so now it looks good. So the test job will be executed, and then we'll have the prod job executing. Okay, let's try running these jobs by clicking on run. All right, so as we can see, our test job started and then our prod job started and it completed. So this completed in 1.5 seconds and this completed in 1.5 seconds as well. And both of these have these websites. Awesome. Now what I want to do is I want the moment I commit on my GitHub, this should trigger my Jenkins job. So for doing that, let's go over here. That is my Jenkins dashboard. And let's try doing that with test. Okay, so we'll click on test and we'll click on configure. All right, and yes, so in the build triggers option, just go to GitHub hook trigger for Git SEM polling. All right, and just click on save. The moment that's done, just come back here on your GitHub. So for configuring your webhook, all you have to do is click on settings and click on settings, go to webhooks. Inside webhooks, click on add webhook. And now just copy the IP address and port number of your Jenkins dashboard or your Jenkins page and paste it over here /GitHub -webhook. Specify that and click on add webhook. If the response is received by Git and everything works fine, it will give you a tick, which means everything is working fine, right? And just go back to your dashboard and you can see that everything works out. Great. Now, what we have to do now is we'll have to push a commit on GitHub and that will automatically trigger a build over here. So let us check that. So we'll just open this over here and we'll go on our master. Let us trigger a build. So this build can be triggered from anywhere. I'm just doing it on master for the sake of simplicity. So I'll just do a git clone of your repository. Git clone. All right, everything is done. Now I have something on my I have a website, right? So what I'll do is I'll change the contents of that website and let's see if that content is visible on our servers as well. So I'll just change the index file. The first thing that I'm going to change is the title. So I'll change this as Jenkins prod website. Okay. And let us change the image as well. So I have one more image over there. So let's name the image as 2jpeg. Great. So now let's push this on Docker Hub. So let's add it, commit it. All right. And let's push it now. Git push origin master, the username and the password. All right. So the push has been made. Let's check if anything is triggered over here. So as you can see, the test got triggered and now the prod also got triggered. So both the jobs have been successfully completed just on a push. Let's verify that. So this is my, so let me see which one is my slave one. So slave one is 108. So let us see. Okay, so this is my slave one. Let us refresh this and see which website is coming. As you can see, the background got changed and as well as the title also got changed. Similarly, if this job is successful, it should also be triggered over here. Let us check if the website is also pushed here, and yes. So the job is also pushed here. Awesome. So let us try this one more time. And with this, let us try to bring back the same uh, background that we had, right? So let's do a nano on index.html and let's change the title to Jenkins final website. And let's change the image name to 1.jpg, which was the earlier image. Save it. Now let's push it on GitHub. So we'll add it, commit it, and now let's push it. All right, so our code is now being pushed. It's been pushed. Now let's come here and see what is happening. So our job should now be running. So test got completed. Prod is being completed. So prod is running right now. And prod also got completed successfully. Awesome. So let's check if our website got changed over here. So this is my testing server. So the title got changed and even the background. Let's see for our production, and even our production website got changed. So awesome, guys, we have successfully completed what was asked to us in the hands-on. So we were supposed to create a Jenkins pipeline, which would basically, if slave 1 job is complete, it should be built on slave 2, and the job should be triggered by a Git webhook, and that we have done successfully.
Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else, right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still I mean, they're still working on PHP 5.6 because of, probably legacy problems, or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it, and he installed the PHP software, he installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in argue that why don't we use VMs in this case. Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution, but the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs, and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable, we needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not, right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. that is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right, all you have to do is write docker run Ubuntu, and what would it do? It would basically download the Ubuntu container, and then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. and there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay, so this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Right? So because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, you again, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right, so guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right, now let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. All right. So if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It will install Compose, it will install the Docker software, it will install the other components of Docker. So you don't have to worry about what component is what, but basically just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. Alright, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker -version.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And as you can see that the Docker version is 18.061 CE, and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. All right. So we have installed Docker on our system, guys, and I hope you guys have also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. right? So you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, you that is again a life cycle state, that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command, Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal, because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command, Docker version, you get the Docker version, the current Docker version that is installed on your system, along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right, so what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name, and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that, so sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on is, I think, around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run, and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container. Right, so this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it -d, and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago, and this is the container which has exited, which we manually stopped, and we can see that also by passing the command sudo docker ps -a. Okay, now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running, so if you do a docker ps, you can still see the container running in your docker ps space.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the lifecycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right, moving forward. Now what to do when you have to remove an image? Now you guys know we already have an image in our docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID, and this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and uh, do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code uh, for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command, say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm -f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm -f and then the container ID, and this would remove your container. All right, so I've deleted my container now. And if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. All right, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container, and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. All right, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now. Right, I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID, so I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right, so with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right, and now I can run a container on the image test, and all I have to do is sudo docker run -it -d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it, and once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container, and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps hyphen a and then hyphen q. You parse in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right. So this is the shortcut that you can use while working with Docker. All right. So my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right. So my container is now running. The next thing that I have to do is install Apache server on this container. Okay. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. Alright, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. So service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now. And let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshar/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So on containers, port 80 Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container. This is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container id bash, and if now I do a service apache 2 start, it should basically give me either an error that apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right. So let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right, so for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this id, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub, and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/apache. This was the image name, right? That we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page and you can see this is the image that I just pushed to the repository, which is hshar/apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned. Now, the next step is what is a Docker file? So a little introduction about a Docker file. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this when you're working on production grade environment. When you're working in a production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Docker file, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Docker file is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Docker file. Now, a Docker file is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Docker file that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a Docker file. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Docker file. Now, the first line of a Docker file is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Docker file, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area of your presentation will basically tell you the Docker file content. So this is exactly how the content of the Docker file should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Docker file, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Docker file, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. All right, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker and command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Docker file, this command will be running when we are starting the container. Otherwise, whatever command we specify in the Docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we are doing is, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service Apache 2 start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd Apache CTL-D foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. All right, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the Apache CTL-D foreground with the entry point command. All right, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case, I specified a variable name which has the value DevOps Intellipaat. Alright, so these are some of the commands that you can use to create a Docker file. Now let us create this Docker file on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then Docker file. So let me just create a directory first. So let me create a directory called Docker file itself. So mkdir Docker file. Let us go inside it. So cd Docker file. And now whenever you are creating a Docker file, the name of the file always has to be Docker file itself, right? So I'll specify nano and then Docker file. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground. That is, run it. So Apache ctl -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -a and g, and then docker and then $user. Enter, and now all I have to do is just re-login into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Docker file. Okay. And now I want to build this Docker file. So Docker build dot hyphen t new underscore Docker file. So you can see the Docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore docker file. So let us run this new underscore docker file. Docker run hyphen it hyphen d. Also let us specify the port number. So let us open it at port 84, and then hyphen d new underscore docker file, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec hyphen it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my docker file. So the first thing that we did was apt-get update apt-get -y install apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time docker file was also added. So inside the directory we had these two files, right? 1.html and docker file. So both of these were added inside the container. Now to not have docker file inside your container, what you can do is instead of dot, specify dot slash and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that I specified in the Docker file. I specified the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Docker file in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. All right. So let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. All right. Moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. All right, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. All right, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Docker file directory, right? So what I can do is I can map this Docker file directory inside a container. Now to mount this particular Docker file folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
home/ubuntu/docker file. Now this is the location of my folder, and then what is the mount point of inside my container? So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory slash app in the container. All right, so this is called bind mount, but there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home /ubuntu /docker file is not going to exist, and that is where it is going to give you an error, and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system it will be a little different. For Windows it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount it is a little difficult to basically migrate the data. In volumes it is very easy. You just take the volume up, and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume, right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay, so this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume, so yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? and then -d and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session. And what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new underscore docker file. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source, say, is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm gonna do is I'm gonna launch docker run -it, and then -mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new underscore docker file. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache, and target would be, say, /app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var slash www slash html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that html body h1. This is the new html file. Close the header, close the body, close the html, come out. Okay, now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp dot slash to.html and then slash var slash www slash html and then the container id. Slash var slash www slash html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container, docker rm -f, delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to Apache, target is equal to slash var slash www slash html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d and then the image name new underscore docker file. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address and but on page 82 you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the docker file, right? For volume we have it in attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what docker volumes are, and I am sure that you guys have also understood. If there are any doubts, guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that, guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen, that if I want to change code in notifications, I will have to pull the whole code base. I have to pull the whole code base. I will have to go to the notifications file, and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base even if you had to change the minimist thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the module, so all of these small things like notifications, mail, payments, passenger management, customers, these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. All of your modules that you're defining, all of the features that you have defined, have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now, to solve this, we came up with the microservices architecture. Now, what is the microservices architecture? Each and every module, that is a customer services function or the notifications function or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab, right? So still communication has to be there between these two components, that is the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program, they can communicate through probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab because booking of cab is no way related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down, right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now, you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs wherein values are separated by commas. In JSON you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that all he has to know. And of course the code of his own function as well, right? And of course, if he makes any changes and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservices which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we want to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker run or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers. That is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end, and of course you'll have to configure the DB password and everything inside the container as well. Right now, one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3, and there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we are trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is db underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself. Right, so inside this container, these are the environment values which will be configured, and then so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download, so it's WordPress and that to the latest version. The ports that we want to expose, so inside the container the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables, we specify that the WordPress DB host is DB:3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number, so that we specify over here. Then we have the WordPress DB user, so we specified the DB user, that is the MySQL database user, as WordPress, so that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay, and what else? So this is it, and after that we specify that the volume which has to be created is db data. So this is for the whole YAML file. There's a volume which is being created, which is called db data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install it, does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose -version.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for it, for the file which has just been downloaded, to be converted into an executable file, and that's it. And now if I run Docker Compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file for, so let me first create a directory. So it would be compose. Let's get inside compose, and now let's create a YAML file for WordPress.yaml. Okay, and if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command Docker Compose, for basically running your Docker Compose YAML file, the command is Docker Compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically. and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So DB container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I'll just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well. Password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. This is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Right? So a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f, and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers' health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. All right, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker swarm up and running. Now, how does a Docker swarm basically work? So a Docker swarm basically works like this. So a Docker swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker swarm on a single machine, which can automatically repair containers. But what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So there in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is docker swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log in to this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. And let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter, and you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say -- force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker, and it'll work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. Just specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So alright, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine, and once everything is running great, it'll exit. So now if you want to see what all services are running on your Swarm cluster, all you have to do is say Docker Swarm service ls, Docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it will basically scale down to only 2 replicas. Now if I do a service ps, docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it'll remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. All right, so this is how you can deploy an application on Docker Swarm.
Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically if you want to install any type of or any set of configuration on any node or any group of nodes, the way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now, there are some key features of Puppet which we are going to discuss next. So, what makes Puppet so special? Why is Puppet so popular? So, the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically it is a tried and tested tool which helps every company in its configuration management needs. Right, so Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it. The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet, there are a lot of people who are enthusiasts, right, who are not being paid, they're just doing it because they love working on.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or they love their profession and they love working on this tool which is Puppet, right? And out of that love, they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore, this is a key feature of Puppet, that there's a large open source community for Puppet which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website. Right? So if you don't understand Puppet, you don't have to take help from your colleague, you don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software. Okay? And the fourth thing, which we have already discussed but is very crucial for its success, is platform support. Right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that. Right? So these were some of the key features of Puppet, why Puppet is so popular. Right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into how Puppet actually works, or getting our hands onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master-slave architecture. So there is one master and there could be numerous slaves which are being served by the master. Right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave. Right? So the way Puppet works is, so first the slave basically sends its state to the master. Right? So when the master slave architecture is set up and everything is set, if there is any change on the master or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master, and what master does is it checks whether the state sent by the slave is what is required from the slave or not. Right? So there is a state for that particular slave which is defined on the master. Right? So it checks against the state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to their slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself. Right? So the Puppet agent then installs all these tools on itself or on the Puppet slave. And once it installs everything, it sends back a report to the master saying that, everything has been installed. Please check whether your requirements are now being met with my state or my metadata, which I'm sending it to you. Right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests. Right? So this is a 3-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted, and it is encrypted using SSL certificates. Right? So there's an SSL connection which is established between the Puppet master and the Puppet slave, and the way it works is something like this. Right? Now for SSL connection, we need certificates. Right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master. Right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate. Right? It requests a slave node to give master the certificate, and the slave obliges for this request and sends the slave certificate to the master. Right? But still at this point, the communication has not been established, although the certificates have been exchanged. Right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the puppet master and he shall sign the certificates of the nodes which basically he wants to attach to the puppet master, right? Once the puppet master signs the certificates of the slave, only then a secure connection is established, right? A encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between puppet master and puppet slave, and this will be more clear to you when we'll be setting up puppet, which is basically our next session, where we'll be setting up a puppet master and a puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on puppet master so that the connection becomes encrypted. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the t2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node puppet master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well, so that we don't get confused between the master and the slave. So this is my master server. All right, so while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. The file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet Master here. So we are installing Puppet Master. Puppet Master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet Master is nearly installed now. And now let's check the content of the policy. So yes, Puppet Master has been successfully installed. And now what I can do is I can check the status of the Puppet Master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet Master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet Master for running. Right, here we are. So basically your Puppet Master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet Master can only use 512 MB of the memory. So Puppet Master can work in a 512 MB memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet Master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet Master over here. So Puppet Master is now restarted, and now we'll open port 8140, through which basically Puppet communicates with the slave through the firewall of the OS as well. So that's done, and we're set. So Puppet Master is successfully set now. Let's go to our slave and start setting up our slave as well. So on a slave, we have updated the machine. wcat is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet Master. Over here we're installing Puppet, which is nothing but Puppet Agent, right? So once Puppet Agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano /etc/host, specify the IP address, write Puppet in front of it, and save the file. Alright, so now we're ready to start the Puppet agent. So let's do that. So Puppet agent has now been started. Let's enable Puppet as well, which basically means on restart also, Puppet will be started automatically. So this is done as well. Alright, so now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed. So the moment Puppet slave starts, it basically sends a request for the master certificate. How does the Puppet slave know where the master is? We just specify the IP address in the host file, right? So it knows where the Puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time it also requests for the slave certificate. So this when the master requests for the slave certificate, the Puppet slave basically sends the slave certificate, and now we have to go to Puppet master basically. So we are here. We'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request from the Puppet slave on the master. So how do we know it's the Puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign, and if there are more than one certificates or more than 2 or 3 certificates and you want to sign them all you have to do is sudo puppet sign and then hyphen all. Specify this and your certificate is now signed, right? So my puppet master and puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave, and these are the changes that we are going to do. So basically we are creating a file which exists in this particular directory, right? So the puppet master has to ensure that this file is present on this directory, and the permissions, the read write permissions of this file is this, which is the user should be able to read write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on, and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file, and the content of the file should be this. Let's copy it, paste it over here, save the file, and once the file has been saved, all you have to do is restart Puppet Master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet, and since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent hyphen test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent hyphen test. So this command will basically ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in /temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet Master slave setup is now complete, right? So now you can use the Puppet Master slave to basically do configuration management. So you'll just have to specify the configuration on the master, and then it will be applied on the slave. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you are basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx? We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agent's configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one. Alright, with this guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're going to do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest, so that basically if I want to install say Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go. And now inside this directory you will have something called as code, right? So you'll have to go inside code. Then there will be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p, and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. Alright, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, these whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure, which should be equal to installed, right? Followed by a comma, and now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be, say, status.txt, right? So again, it will be followed by a colon. Then I'll specify the attribute. Now, the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file, there should be a text which says nginx installed, okay? Followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644 followed by a comma, okay? So everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifest folder, which exists inside the environment production, okay? So this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent hyphen test, right? And I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify hyphen test, and we'll hit enter. And now it says applied catalog in 0.01 seconds. All right, so let's check if we have the tmp file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. All right, so I think, guys, I got the problem. The folder name has to be environments, okay? So if you look over here, all right, so let's try this. So let's try to change this folder name. So for that, I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again. So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again, and do a puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed nginx, and it has created a file on the agent itself as well, right? So congratulations, guys, on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are 3 components of manifest. Basically, we can call these components, which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master, so let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps Course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It will be $text. Okay, let's try to save it, and let's go to our slave one, and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent -- test. Let's hit enter. All right, so something happened. Let's check. So cat/tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps Course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right?
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains...
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Two values, one is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service Nginx status. Service is running, so let's stop the service. So service Nginx stop. So we'll have to add a sudo. Yes, so Nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent -- test. I'll hit enter. And now it's basically applying the catalog. So my Apache, so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I just have to specify packages and I'll have to save the catalog, and that's it. If I come back here, if I again do a puppet agent test, let's see what happens now. Alright, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server. So let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed. So we can also check it on the browser, on the terminal. Service Apache 2 status. And you can see Apache is now running on this slave. Similarly, if I want to check service MySQL Server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed 2 packages, 2 softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. All right. So now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here we say we are basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp/status.txt. okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying, is Apache 2 present or not? So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. all right. So what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that /bin/echo. Say we are checking if Apache is present or not. So we'll say Apache 2 is installed. So we'll say this, and this has to go inside /tmp /status underscore apache .txt. This will go over there. So this command should run only if the command /bin the command would be /bin/which apache 2, and only if this command is successful it should run this particular command, right? So, and now we'll just close the resource, and that's it. Let's save the file, and now let's come to our slave, which is this. Let us try to run the test. So sudo puppet agent -test. This basically has now created a file. So let's see if the file has been created or not. cd /tmp /status underscore. So we don't have a file over here. So let's see status underscore. Okay, so let us go inside tmp first and then do an ls. So I can see status underscore apache file is present. So I'll just cat it status underscore apache or txt. So it says apache 2 is installed. Reason being, over here do have apache installed. But let us go to another slave which I have connected to my master. Let's see if we have apache 2 over here. So service apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically, because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change, and the master told this slave to install Apache 2 and all that. No worries. So what I'm gonna do is I'm gonna sudo apt get and I'm gonna purge Apache 2. Okay, so this will uninstall Apache 2, and now if I do a sudo service apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent -test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside /tmp. I'll do an ls over here. It has a file called status underscore apache. Let's check that. So status underscore apache. What we can do is, probably this could have been created earlier. Let us remove this file first. Status underscore apache we have removed. We'll have to add a sudo here. So it's removed now, right? Let me just check if this command actually works or not. So /bin/which apache 2. So it is running service apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm /user /sbin /apache 2. Either we can do this, or okay, let's first do this and then we can probably try something else as well. So user sbin /apache 2. Okay, so now if I do /bin/which apache 2, do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent -test. I'll hit enter. Alright, so the catalog has been applied. Now let's check inside tmp file. So cd tmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is, until and unless this file or this command is not sending me 1, or is not false, or is not executing properly, till then, do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we will do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is, if I go to my slave 2, I'll just do a puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore Apache file. Let's do a cat on that, and it says Apache 2 is not installed. So basically we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet. Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, it's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management. Right? And now what happens is, any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet, using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically. Right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is, there is no room for error because everything happens automatically. Right? So if there was any error which could be committed while installing softwares, that is not the case now, because everything is automated. So that is why, configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem. Right? Now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source, and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed, that Ansible playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So a playbook essentially should have a lot of plays. So guys, the the first level in the tree of playbook comes a play, right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play you define the tasks that has to be done, and each task has something called as module, it has something called as notify, it has something called as handler, and a lot of other things as well, right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So like I said, playbooks has a lot of plays, and each play has a lot of tasks, right? Now let us see how we can define a play in a playbook. So guys, in a play, you can have 2 or 3 tasks or 4 tasks or 10 tasks or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1, and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session, but let us take an example that these are the 2 tasks which have to be done on a particular host. So they can be combined inside one play and then they can be executed. Similarly, if I want to execute a script on host 2 and install Nginx on host 2, this would become play 2. Okay. Now, how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay. Now, out of these, which are plays, what are plays, and what are tasks? Let's look at that one by one, right? So guys, this particular block of code is one play wherein you have defined the hosts, right? So whenever you define the host, you start with a new line wherein you are defining the host. That becomes the starting of your second play. Okay. Now the next thing is, inside a play you have tasks. So as you can see, you have tasks over here, and the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is, you'll have to pass the command. Now what command has to be executed on the terminal? That same exact command you have to mention here. Okay. Then the second name is execute script on server, right? So what is the script that you want to run? test_script.sh. This is the script that I want to run. So in this, I have 2 tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay. Hyphen marks the beginning of a new task. You specify the name of that task, and then you specify how that task will be executed. All right. For example, in this case, there should be a command which is being executed. In the next case, there should be a script which has to be executed. The syntax will remain like this, right? Now, whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this, hosts colon and then host 1. Then whether that particular command or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo colon and then say yes. Okay. Then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run these, run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install Nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay. So apt colon and then the package name, which is Nginx that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you are starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay. Once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks. So it becomes a dictionary. So it has all these information, each play. And once you define that and execute that, then it executes according to what is asked inside that particular play. All right. So when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, when you combine them together inside a playbook, it become a list of dictionary. Okay. So again, seeing what tasks are nothing but they are basically commands that we want or tasks or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first, let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay. So this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay. So let's create a playbook called sudo nano play.yaml. Okay. This is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay. Then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay. And now let's specify the tasks. Okay. Now inside the task, guys, the first thing that you would do.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Is you'll have to define a task. So let's name the task something. So let's call it install Apache. Okay, let's call it this. Then what I'm gonna do is I'm gonna give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2 and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible -m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave 1. Yes, so the name is slave 1. So let's change that in our YAML file as well. So sudo nano play.yaml, and the host name is slave1. Okay, now let's try to run this playbook. Now how can I run this playbook? Type in Ansible hyphen playbook space play.yaml. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave1 right now, and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task. And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, changed equal to 1, and nothing has been failed. Now if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is, let me just uninstall Apache, sudo apt get purge Apache 2. I'll just uninstall the package, and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt get update, and the next step would be to install Python, sudo apt get install Python. Once this is done, I'll just have to go back to my master. I'll have to make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave 2. Okay, so this is my slave 2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here. SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a Ansible-m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do this? Alright, so now let us go to inside Ansible, right? And let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play 2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install, let's say I'm installing Apache on this system and I want to install Nginx on my slave 1. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave 1 now, and I'm installing Apache on my slave 2. Okay, so name is equal to Apache 2, state is equal to latest. Alright, seems cool. Now I will be executing this playbook and let's see how it goes. So basically with one command, what we are doing is we're installing software on 2 different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. All right, now let me execute this command. So it is Ansible -playbook and then play.yaml. Okay, so let's execute this. So it is executing play 1. It is installing Nginx on my slave 1. All right, okay, so it has been done. Now we are executing play 2 and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server 1 is already ready and it says welcome to Nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. All right, so I've configured 2 different servers from my master, right, at the click of one button, right? I just executed one playbook which configured 2 servers of mine, installed 2 different softwares on it based on the name that I specified. All right, so awesome guys. I think we have almost begin we are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh, and what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var/www/html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be 1.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script guys. So let's save the script, and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. All right, so my script is now ready. Now I'll go inside my playbook guys. So I'll go to sudo nano play.yaml, and I want to do this task on my Apache server, right? So I'm inside my Apache play, and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script : and what is the name of the script? hello.sh. That's all I have to do. Now let's save this play, and now let's try to run this play. So I'll do a Ansible -playbook, and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says OK equal to 2, change the equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see automatically a website was created which is now called Hello World. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be, say, I'll go inside the script file. I change the text to hello world 12. Okay. Mind you, I'm not going to any other server. I'm just running the same command again. Right. Again, the commands will run. As you can see, it says on slave 2 there's one change. And if I refresh it now, can you see the website has changed automatically? Right. And this has changed without me going onto this server. And this is the power of configuration management, guys. Now imagine you have 100 servers and you have to change a file in all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide, guys. So if I'll come back to my slide, all right. So now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing, right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right. So we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we changed the permissions for that script file. Once everything was ready, we executed the Ansible playbook, and the script file was automatically taken up and shifted or.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right. So guys, this is how you create a playbook. So the first step that you have to do is you'll have to install Ansible on the master, right? But you do not have to install Ansible on the slave. That's because Ansible works in such a way that, Ansible installation is just required on the master. On the slaves, it just requires Python to be installed. If Python is installed, it can directly connect to that particular Ansible slave, right? So this is the first step. First step is install Ansible on master. Second step is to configure SSH from the master to the slave. That is, you should be able to do an SSH to the slave from the master without any key and without any password. So we'll see how we can configure this. Third step is that we'll have to set up Ansible host, and then we'll have to test the connection. All right, so we'll do this step by step, guys. So let's start with step 1, which is install Ansible on the master. Now, in order to do that, you'll have to first launch 2 instances on AWS. Now, let me just quickly jump on to my AWS console. So guys, this is my AWS console, guys. And the first thing that I have to do is I'll have to launch an instance, and the OS that I want is Ubuntu. The processor would be T2.micro. I click on next. What are the number of instances that I want to launch? I want to launch 2 instances. I'll click on next. Move to the part where you'll have to select the security group. Now, if you don't have a security group, first create a security group and add a rule for all traffic, and it should be basically from anywhere. Click on review and launch, and this will be done. If you already have a security group which has these kind of properties, what you can do is you can click here on select an existing security group and select the security group that has all the rules according to what software you're installing. All right. So once this is done, guys, click on review and launch, and finally review all the settings that you have done and click on launch. Okay. Select the key pair that you have on your system and click on launch instances, and this will launch 2 instances on AWS for you. Next step would be, guys, to basically go to my management console and naming my instances. So let's call my first instance is as Ansible 1, and let's say my second instance is Ansible 2. Okay, Ansible 1 is going to be my master and Ansible 2 is going to be my slave. Let's try connecting to Ansible 1 first. So I'll go to my putty tool, and this already has my my ppk file selected, which is HEM, right? So this is already selected. Now I'll click on open. So I'll click on yes, and I have successfully connected to my master now. Awesome. So I have connected to my master. The next step would be to connect to my slave. So for connecting to my slave, again, I'll go back to my management console, select the second instance, copy the IP address, open a new putty terminal, put the IP address over here. Let us change the color so that we can differentiate which one is my master and which one is my slave. And yes, now we are basically connecting to my slave. Let's enter the username, and we're successfully connected to my Ansible slave as well. So my green terminal is my Ansible master. This is ready now, and this is my Ansible slave. Now what are the next steps that I will do? First, I will have to update the master and the slave. So on my master, I'll type in the command sudo apt get update. Similarly, on my slave as well, I'll type in the command sudo apt get update. Alright, so my machines are now getting updated. Once I've updated my master, next step would be to install Ansible, and for that the commands are these, right? So once you've updated the machines, you'll have to install a package called software properties common on my master. Usually when you're launching an instance on AWS, this package is already the latest version. So as you can see, it says it's already the newest version, which is awesome. The next command that you have to run is you'll have to add the repository for Ansible in your master, right? So just type in this command, hit enter, and this will basically add the Ansible repository to your master. Next step is to update the machine. So let's update the machine with this command. So it says sudo apt get update, machine is updated, and now finally the command to install Ansible. Hit enter, and Ansible will now be installed on this particular machine. So while Ansible is being installed on this machine, guys, what do you have to do on the host or on the slaves? You'll have to update the machine, which you have already done, and just install Python. Okay. So this is my master. Ansible is successfully installed on my master. On my slave, I just have to install Python. Nothing else. No other Ansible software. So Python is being installed on this machine now, and Python is installed successfully. Okay. So Ansible is installed on my master. Python is installed on my slave. These both are ready, right? Now let's see what is our next step. So let me just go to my slides. So the first step was to install Ansible on the master. I've done that. Next step is to configure SSH access to Ansible host. Now what does this particular step mean? This means if I go to my master right now, and if I type in the command SSH ubuntu @ the IP address of the slave, I will not be able to connect to my slave right now with this command. Let's see. Let's verify this. So I'll go to my AWS management console, and this is the IP address for my slave. Let's try to copy that over here. Let me also explain you what is basically happening in this command. So I'm doing an SSH on this machine with the username Ubuntu. Okay, so that's why Ubuntu @ this IP address. Now if I hit enter, if I'll just type yes, this is basically asking should it add this IP address in the list of known IP addresses. I'll click on, I just select yes, and this IP address will now be added. I hit it enter, and now as you can see, it says permission denied. So you're not able to do an SSH to this instance with this particular IP address. Now we have to solve this. This should basically be a success. This should be able to connect to the slave through this particular command. Right now, why are you getting permission denied? That's because the only way to connect to that instance is using the PPK or the PEM file, right? We don't have the PEM file in this instance. So we'll have to enable my slave to be able to accept connections from this particular machine, so that it does not require any key like a PEM file or a PPK file or any kind of password. Now this is a necessity when you're trying to install Ansible. Now let's see how we can do this. How can we enable keyless access into my slave? Now for doing that, guys, the first thing that you'll do is you'll have to go inside the directory .ssh. Once you go inside that, let me first show you the structure right now. If I do an ls, you can see there are two files. One is called authorized keys and the other is called known hosts. What is known hosts? When we were executing this particular command, ssh ubuntu @IP address, it asked us whether this IP address should be added to the list of known hosts, right? So inside this known hosts file, if I do a cat on known hosts, you can see that this is basically the code, or this is basically the encrypted form of this IP address that is that on the slave, and which tells it that, okay, so this is a known host that I'm connecting on. Okay, if you don't understand this, guys, don't worry. This is not a part of you getting to know Ansible. I'm just telling you this for your knowledge. All right, so this is encoded form of the IP address that you'll be connecting to. All right, what else is there in this directory? You have something called as authorized keys. Authorized keys is a file wherein you will be entering all the machines which can connect to this particular system, right? If I do a cat on this file right now, you would be able to see that this is the SSH, or this is the key code that of this particular file. What is this file? This is the PEM file that got downloaded on my system when I created a key pair, right? So when I connected to this instance, I connected using this particular file. So this is there in the authorized keys file, which means that if a machine is connecting to this particular instance and has this particular file as an argument, in that case, that allow that machine to connect, right? So if I remove this, nobody will be able to connect to this instance, even if they have this particular file. Okay, now what I want to do is, on my slave, if I go to this particular directory .ssh, and if I do an ls over here, this file that is the authorized keys, I want to add one more key in this, which will basically allow my master to connect to my slave. Now which key I have to add, I'll tell you now. Now, in order for you to generate a key for your system, all you have to do is type in ssh-keygen. This will basically create a key for this particular machine. It is going to be unique for this particular machine, all right? So ssh-keygen, if I hit enter, it'll ask you to enter the file in which to save the key. Do not enter anything, just hit enter repeatedly, right? And then once you get this kind of a message, that means your file has now been successfully created. And where is it created? It is always created inside .ssh directory. Okay, now if I do an ls over here, I can see there's a file called id_rsa.pub. Okay, now the code which is there inside this particular file, I'll have to put it inside the authorized keys of my slave. Okay, so let's try to do a cat on id_rsa.pub. This is the code id_rsa, sorry for my mistype. This is the code which we have to enter on my slave now. Okay, so let's copy this code, and on my slave, let me do a nano on authorized keys, and now let's just paste the code over here. Okay, we have pasted the code. Let's save the file, and now if I try to do an SSH again from my master, I should be able to do it successfully. So I'll just again go to that particular command. This is it, right? Let me copy this command and let me clear the screen, guys. So I'll clear the screen so that it's visible clearly. Now I'll do an SSH on this particular IP address, and now you can see I didn't get an error. I basically got logged into my slave. And how do you know that? This is the username @IP 172.31.45.176. This is what you're getting on this terminal, and if I see over here, I have the same number over here as well, 172.31.45.176. So I'm connected from this machine onto this machine through SSH. Now if you want to exit the SSH, all you have to do is type in exit. It says connection to this IP address has been closed, and you can see it has reverted back to the same name that was of the master, which is IP 172.31.44.88. Earlier it was 172.31.45.176, which was of my slave. Okay, so I have done my second step successfully, which was basically to configure SSH access to my Ansible slave without any password and without any key. Right, you just enter SSH Ubuntu @IP address of my slave and you'll be able to connect to it successfully. Now what is my third step? My third step is setting up Ansible host and testing the connection. So I have SSH enabled on my master. It can easily connect to my slave now without any password and without any key. But how will Ansible connect? We'll have to configure that now. Right now, in order to add, or in order for Ansible to know that it has to connect to a particular machine, it has to have its IP address. Right now, where can you add that IP address? That IP address is basically added in this particular location, /etc/Ansible/hosts. Right, hit enter, and this is the file that will come up. Right, so these are all the commented lines are all the templates that you can use to basically add hosts, but I'm gonna tell you a new template in any case. So the way you add hosts is you start by square braces. Okay, and inside square braces you give a name. Let's say the name is production. What does this name symbolize? This name means that whatever is below these square braces is basically inside the group production. So this is the group name. Okay, and now what I can do is I can add n number of IP addresses over here, and all those IP addresses basically will be inside the production group. Okay, you can name your group anything, guys. It's basically random. You can name it anything, but whatever IP addresses you will specify after that will get inside that particular group. Okay, now I have created a group. Now I want to add a host inside this group, so I can give my host a name as well, or I can give my slave a name as well. So let's call my slave as slave1. Right, then you'll give a space, and then you'll type in Ansible _SSH_host is equal to, and then the IP address of your slave. So in my case, the IP address of my slave is this particular IP address. Let's try to copy it and let's enter it over here. Okay, so you enter the group name, then you enter the host name or the slave name, space Ansible /SSH_host equals to the IP address of my slave. So whenever I'll ask Ansible to ping any of my slaves now, it will read this particular file to get to know which IP address it has to ping on. Okay, now let's save this file. So my file is now saved, and now let's try to enter the command Ansible-m. So now what we are trying to do is we are trying to see whether Ansible can communicate with my slave. Okay, now in order to do that, I'll type in Ansible-m ping. Ping means ping that particular all the slaves which are basically connected to this Ansible master. How are we selecting all the slaves? We'll type in the command all. So Ansible-m ping on what? All the machines that are connected to this Ansible master. I'll hit enter. So it will go through that file which we created /etc/Ansible/hosts. It will see all the hosts which are added in that particular file, and then it will ping those machines. Right, so as you can see, it on slave1 was the name that I gave to my host. On slave1, it was successfully able to send ping, and what it received was pong, which means that it was successfully be able to communicate with the Ansible slave. All right, I can also type in Ansible-m ping, and I can specify the group name. So the group name was production, let's say. Right, I hit enter. As you can see, it automatically got to know, okay, so if I'm pinging production, these are the hosts which are inside it, and this is the message that you're getting, which is success. If I try to type in the host name as well, so I can also do that. I'll type in Ansible-m ping slave1, which is the host name, hit enter. It will again be able to ping the slave machine. But let's say I enter a name which is not there in the host file. What will happen in that case? It will not be able to match it to any of the name present in the host file, and hence you'll get an error. No hosts match, nothing to do. Okay, so guys, this is how you can set up Ansible master slave on AWS using the Ansible software, which basically does not require you to install the Ansible software on the slave. Just install Ansible master on the master, the Ansible software on the master, install Python on the slave, add the IP address of the slave in the host file, and configure keyless SSH access from the master on the slave, and you're ready to go. All right, so let me just come back to my slide. So let us summarize what we did. We installed Ansible on the master and we installed Python on the slave. Then we configured keyless SSH access from the master to the slave. And the third step was we added the host's IP address in on my Ansible master in the file /etc/Ansible/hosts. Right? Once I did that, I was able to communicate with my slave.
Let's talk about Kubernetes now. So basically containers are a very good way to bundle and run your applications. We talked about this before, right? You can have your application divided into a various number of small independent pieces and you can bundle them together and run it dynamically and manage it. So right. So in a production environment, you need to manage these containers, right? So there are a lot of containers that you have broken your application down into. So you need to manage these containers to ensure that there is no downtime and there is no hindrance here and there. So that is where Kubernetes comes into the picture, right? So what basically Kubernetes does is it provides you with a framework to run on your distributed systems very resiliently. So it takes care of all the scaling that you have to do. So by scaling, I mean if you have, let's say, 3 replicas of a pod, we'll discuss about pods later. So you can make it to 4, 5, 6, 7 or bring it down depending on your needs. And if there is a failover for your application, it can rebuild it if it's required. If it gives you with a deployment pattern. So there are 2 ways of basically deploying things. You can recreate it. So what it means is basically if you have, let's say, 2 things which are running and you have an update right now. So you can either recreate the entire thing, which will give you a little downtime, or you can go with the rolling updates. So the rolling updates will basically move it one by one, all the replications that you have, and replace it with your new updated deployments, right? And it provides you with much more than that. So basically Kubernetes can be thought of as a portable, extensible, open source platform which is used for managing containerized workloads and services, and it facilitates both declarative configuration as well as automation. So it does both of those things. So what do we mean by declarative configuration? So you give your configurations as a file where you declare, okay, this is mapped to this, so this basically does that. So we'll talk about that when we talk about YAML files, and it gives you this automation kind of thing where it basically manages all your things through controllers. So it has a very large and rapidly growing ecosystem, Kubernetes. So various number of people are involved with Kubernetes ecosystem. A lot of people are there, so they give you this service and support, and there are different tools widely available which are very compatible with Kubernetes. So a lot of people are working with it. So there is a huge community to it, where you can find different answers to the problems that you face in and around different communities. So it's a very, very, very happening and hot topic in the computer science field right now, and specifically towards the DevOps. So Kubernetes is a very, very good container orchestration tool. So it helps you manage all your containers and deployments and scale it.
Why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server. right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server, right? Now this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base, right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependency. So say for example, tomorrow my passenger management code fails, so that would lead to all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now my customer service is deployed separately, it's in a separate code base. My notifications have been deployed separately, it's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message, which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services, it was only API calls that is using JSON, that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service the customer service module might not require that much of power that is there in one server, right? But still my customer service module is occupying the whole server and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue, you can also upscale it, but upscaling would also cause the same problem, that is, say your server is able to handle 10 replicas of your customer service uh, module, or say, let's your customer service module is being bombarded with requests and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the 2 servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of a feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in that case it was manually updated that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it, because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. If there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature, and the number of containers that you want for that to be supported with. You just have to specify the number, and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is, for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes, wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system. It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside.
So let us begin with Kubernetes architecture. So basically Kubernetes follows a client server architecture. So basically there's a client, there's a server, you send a request to the server and it replies back, something like that. So along the ways, it follows a similar architecture to that. In this Kubernetes architecture, we have a master installed on one of the systems, and there are a lot of different slaves, as you can call them, or different nodes which are on the separate systems, and these are connected. So there's one master which controls everything, and there are a lot of slaves to it or different nodes to it which are created on different separate Linux machines. So as you can, if you remember in our installation, when we tried using the AWS console, so what we did was we had multiple instances, out of which one we had as a master and rest of them we attached them with the token as a slave. So that's how the architecture is, and you can see the overall architecture here in this picture. So there is this one master node right here. Now master has different components to it. If you look at it, this is a worker node, this is another worker node, and here you can see a master node has an API server, a kubectl. A kubectl is basically a command line interface, which we'll be discussing on later. And there's an API server. So as a master, it has to host, so it has an API server there. And then there is a scheduler which can schedule different jobs, and there is a controller manager. So there are a lot of different things which can be controlled, which have a controller manager, which makes sure that certain things are created and maintained, if you will, for their requirement. And there is etcd, which is another part of the master component. And then in the worker node side, you can see there's a kubelet, there's a kube proxy, there are different pods, and then there is on above it, it's a Docker, but you can have any other containerization platform. If you have, you can create containers through that. You can use that as well. And then there is the internet. So we'll be hitting each of these individually one by one. So if you are starting off, so let's start off with the master. So we saw there was etcd, there was an API server, there's a kube controller manager, there's a scheduler, and there's a cloud controller manager. So we'll hit all of these one by one now. So basically etcd is something that stores configuration information, which can be used by each of the nodes in the cluster. It is a highly available key value store, which can be distributed among multiple nodes. Also etcd, the job of it is has to store all the configuration and the specifications, and it has to be readily available across all of the nodes, so that there's a constant availability of things and you know what is going on, right? So these configurations are accessible only by Kubernetes API server, as it may have some kind of a sensitive information. So it is kind of an encrypted area where you want to keep your sensitive information as a key value store, and it is a distributed key value store which is accessible to all. So this key value store contains all of the configuration information and other sensitive information that is required for it to run. So it this information helps Kubernetes node and server architecture stay alive, and it is just sometimes called as the brains of the Kubernetes, as it has all of the information which is required for it to run. And the next part is the API server. So as we mentioned, the API server is the one which is the only one that can access the etcd, right? So this provides all the operations on the clusters using the APIs. So there are different APIs. As we mentioned, it is a client server platform. So there's a lot of information which is all of the work which is done through APIs. So this makes sure that all the operations which are done on the clusters are done using the APIs. API server implements an interface, which means different tools, libraries can readily communicate with it. So it is a very key part of the architecture. And then there is a kubeconfig package along with the server side tools that can be used for communication. So what it basically does, that kubeconfig thing, is basically exposes the Kubernetes API. By exposing, I mean there are some things which stay internal and some things that you expose which is publicly available that you can see from the outside. So the kubeconfig package lets you expose your API so that others can reach it from the outside, right? So Kube API server is designed to scale horizontally. That is, you can scale more and more by deploying more and more instances. So if you want to scale the architecture, so in order to do that, you have to create multiple instances and divide your workload along it, and it scales horizontally. So it scales horizontally in that way. You can run multiple instances of a Kube API server and balance the traffic between those instances. So if you have multiple nodes, easily you can transfer whatever the traffic that is coming on, or whatever the request that the client is asking for, you can serve those by balancing those traffic throughout the nodes that you have with the help of the API server, as you have multiple instances. Coming to the kube control manager, it is the component on the master that runs the controller. Logically, each controller can be thought of as a separate process, but to reduce complexity, it is compiled into one binary and run as a single process. There are various components of the controller. So these are namely basically four kinds. First is the node controller, which is responsible for noticing and responding when the node goes down. So you have a lot of nodes. If you are creating like multiple nodes, so it has to make sure that all of the nodes are running. So our node controller's job is to make sure that it notices and responds when a node goes down. Then there is a replication controller. Now, when we'll be discussing YAML files, you'll see that you can have multiple replicas of a single pods, and you can have lot of like a pod can be thought of a set of containers, and those containers will have a lot of information, right? So if that container has your application, so you don't want one instance of that application to be running. You want it to have multiple instances. So let's say if I have a client which wants some service to be done, and that service is, let's say, image processing, and it converts image to black and white. It would be okay if I had only one customer. So now I have like 10,000 of customers, all of them requesting that their picture should be turned into black and white. But if you have only one instance, there will be a lot of traffic on it. So what you want to do is you want to have multiple replicas of the same pod. That is the pod which has the containers which basically turn the image to black and white. So what you want is multiple instances of that, so that each of them requests, which are from your 10,000 clients, can be served properly in a faster manner without having a downtime, and so that the traffic is also distributed. So the job of the replication controller is to make sure that if you define in your YAML file that I want, let's say, 10 replicas of this pod to be there, so it makes sure that there are always 10 replicas available, and if some replicas goes down or if it stops responding, its job is to recreate it. Okay, then moving on, there are endpoint controllers, which populates the endpoint objects, that is it joins the services and the pods, and it's basically making sure that the different endpoints of your application is running and they are in constant connection with each other. Then there is a service account and token controller, which create default accounts and API access tokens for different new namespaces that you have. You'll understand namespaces in this module itself. We'll be discussing that in the add-on section. Now moving forward, we have a scheduler. Now scheduler is again a very key component of master. It is responsible for distributing the workload. So if you have a lot of workload, its job is to schedule it and distribute the workload. It is also responsible for tracking utilization of the workload on cluster nodes, then placing the workloads on which resources are available, and then accept the workload. So it'll look at the resources that are available, and then it will accept the workload, and then it's responsible for distributing it and tracking the utilization of whatever the resources that we have, right? So basically, in other words, what you can tell is that this is a mechanism which is responsible for allocating all the pods that are available to the nodes. So as I told you, there are a lot of different containers. So if you understand Docker, you know there are a lot. The basic container has a simple image. Now multiple of these containers together forms a pod, and this pod can be some kind of an application. So as I mentioned before, if we have multiple replicas of these pods, so there are a lot of replicas which can be deployed on a single node. And if one of the replicas is, let's say, busy or is down for some reason, that it's facing some responsibilities, the scheduler is responsible for allocating these pods to different nodes and then making sure that if something is not working, then the work will be given to some other node. And that is the important part of the scheduler.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Then moving on, then there is a cloud controller manager. Now cloud controller manager runs the controller that interact with the underlying cloud providers. So in our case, it was AWS. It could be GCE, which is the Google Cloud Engine, and there could be a lot of different. You can use Azure or whatever the cloud that you are using it. So cloud controller allows the vendors code. So that is the cloud vendors, whatever is your cloud vendor, if it's Microsoft or Amazon, it allows that their code and Kubernetes code to evolve independently of each other. So it can, both of the codes are working, they are working simultaneously on the same thing probably. So it makes sure there is a coherence among these two while they are working as a single unit. So it is a very important part again. So the following controllers, cloud providers have their dependencies. So there is a node controller, there's a route controller, and there is a service controller and a volume controller. So there are 4 kinds in this also again. So the job of the node controller is for checking the cloud provider to determine if the node has been deleted in the cloud after it stops responding. So if it stops responding, its job is to make sure that the node, to determine if the node is deleted or not. And then there is a route controller. So the route controller basically is for setting up different routes in the underlying cloud infrastructure. So it's basically responsible for where the information goes from where to where and routing it basically. So basically what a router does. Then there is a service controller, which is used for creating, updating, deleting cloud provider load balancers. So like we have a scheduler for distributing loads in the master side of things, in the, let's say, pod side of things or whatever we have. In the cloud side of things, the service controller is responsible for load balancing their traffic. And then there is a volume controller, which is for creating, attaching, mounting volumes. Now volumes are again can be thought of as storage, and it's a very this volume controller is responsible for interacting with the cloud providers to orchestrate these volumes. So as I told you, volumes can be thought of storage, like storage. So storage is there. So there's a lot of different storage. What you want is that your storage interacts or properly mounts and attaches itself to the cloud. So the job of the volume controller is for creating or attaching or interacting with the cloud providers and properly orchestrate, that is sending and properly giving the instructions basically, if you will, to these volumes to properly work with the cloud. Then coming to the node side of things. So the Kubernetes nodes has three different parts. There's a container runtime, there's a kubelet service, and there is a Kubernetes proxy service. Now, Kubernetes proxy service is another very key part of it. So let's discuss all of these one by one. Now let's touch upon the node side of things here. So the node architecture, as we saw earlier from the overall picture, contains of basically three major things. First is the container runtime, where we talk about different tools which are responsible for running your containers. Second one is the kubelet service, which is responsible for talking to etcd and the master and getting the information, which we'll discuss when we talk about kubelet service. And the final one is the Kubernetes proxy service, whose job is to make sure that some things.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Are available to the external host without any hassle. So all of these things have been designed in such a way that it becomes a very hassle-free job when you're working with Kubernetes. So let's hit them one by one. So the first one on our hand is container runtime. So a container runtime is a software responsible for running the containers. And as I've mentioned earlier, that Kubernetes is a container orchestration tool. It is not something that creates the container. It is something that manages them. So you need to have a software that creates the containers. So that could be Docker, and I've mentioned here that Kubernetes supports several runtime containers, which is Docker container, and there is Containered, there is Creo, then there is Archlet. There's a lot of different things, or any other implementation of Kubernetes CRI, which is Container Runtime Interface. So you can use any of these to create your containers. So the first thing that is required in the architecture is a container runtime, something which creates and runs the containers. Moving on, the second part is the kubelet service. Now, this is a very small service in each node which is responsible for relaying information to and from the control plane service. Now it interacts with etcd. So if you remember when we were talking about in master, that etcd is a distributed, highly available key value store which contains a lot of configuration information and specifications for your different deployments. So the job of this kubelet service is to interact with the etcd store and to read and store the configuration details. So it interacts with the etcd and it stores and reads and these configuration information, which is very responsible for us. It does more than that. What it also does is it communicates with the master component to receive the command and the work which is required for you to do. So the master and the node interact through this kubelet service where it basically communicates with the master component. Then this process also takes the responsibility for maintaining the state of the work and the node server. So it does three very major things. It does interact with the etcd to get the configuration information. Then it interacts with the master to know what is the command and what is the job to be done. Then it also makes sure that whatever the specifications that we have read and what is the state of the work is required, it is there and the node is maintained. Finally, it also makes sure a few of the networking side of things where it makes sure that ports are forwarded and the networking rules are well working and everything that is required. So it does all of that. So kubelet service is responsible for all the major networking related things. Then there is Kubernetes proxy service. Now, this proxy service runs on each node and helps making the service available to an external host. So what does this mean? Let's give you an example. Let's suppose I told you before, right, that the pods are a set of containers which is deploying an application. Let's say I have two pods in one node, right? And both of the pods are mentioned as a replica of each other. Just what I've done is I've made a very small change in both of these pods, right? So since I'm an external person, I don't know where the pods are. I know where the node is. Maybe I know the IP of the node and I'm trying to reach that node, right? So what would be the information that I get? Will it be what it is inside pod 1, or will it be inside what is pod 2 or the container 2, whatever it is, or it is container 1 or is it in container 2? Which one do I reach, right? In that case, what will happen is when you don't know where it is, the job of the proxy service is to bridge that gap. Since you don't know where it is, it makes it look like you know where it is by routing it you to the proper place. So if I hit the IP of a node, I do not know where actually the pod is, but the proxy service basically maintains that gap. It talks to the node and it communicates it to the pods and or the containers and gets back the information so that it looks like you are actually hitting the pods without actually hitting it. So it basically makes sure that that service, which is the whatever is inside your container, is available to the external host without actually them knowing where it is. It helps in forwarding the request to the correct containers and is capable of performing primitive load balancing. So as I was giving an example, so if I have two containers, if I make a very small change in both of them, let's say one says hello world and one says bye world or something like that. So the primitive load balancing that it does is if you hit that node again and again and again, there will be instances where you get hello world as the reply, and there will be some other instances where you get bye world as the reply. So that is the job of the proxy service, to make sure that you actually get informations from the container without actually knowing where the container is. Its job is to bridge that gap. Moving on, it makes sure that the networking environment is predictable and accessible at the same time. It is isolated as well. So it makes sure that it is predictable. So if I'm hitting a node, so I think it I should receive what I'm expecting. It makes sure that it becomes predictable, that I get what I want, and it makes sure that it's accessible. While I still don't know where it actually is, that is the time it's being isolated. So I don't know where it actually is, but I still receive the information with the help of this Kubernetes proxy service. That is the main job of it. It manages pods on nodes, volumes. Volumes are nothing but storage kind of things. Then there is secrets, which we'll be discussing on later on. So secret is something basically which you use to store information with an encryption. So if you have sensitive information like password and stuff like that, you can use secrets to pass that passwords on. Or creating containers, health checkup, or whatever you want. Kubernetes proxy service does it for you. Now we'll be talking about the add-ons which are there in Kubernetes. So add-ons use resources like daemon sets, deployments, etc. to implement cluster features. These are all different features of a cluster that you can use because these are providing cluster level features. Namespace resources for add-ons belong within the Kubernetes namespace system. So if you have installed Kubernetes, right? You can just write Kubernetes get all pod -- all namespaces. You'll see different namespaces which are already available. Let me show you just before we begin. So this is my master. As we've been talking here in this slide, that there are a lot of different things which are there and it will be available along with the kube system namespaces, right? So I'll just want to show you that if you type a very simple command, kubectl. Now kubectl, as we talked, is a command line interface that allows you to interact with your Kubernetes cluster, right? So this is there on the master. This is my master component. So kubectl get pods. I want to get pods, but what I want is, since I've not deployed any pods, so if I do that, I'll get no resources right now because there is no default namespaces which is there. So what we want to do is we want to get all the namespaces. So we'll type kubectl get pods -- all -namespaces. We'll discuss about namespaces later on. So what you basically want to know is, like, if there is we define resources in different namespaces where they work. So if you type kubectl get pods -- all namespaces, we will see currently all of the different pods that are running inside of Kubernetes, which are responsible for its running, right? So as soon as I've hit, as you can see, these are all kube system. The namespace here of everything is kube system. Now this has Calico kube controllers. Now Calico is our basically our network manager kind of thing. This we installed, you have seen while we were installing it. There is an etcd IP, as you can see. There is kube API server, then there is Calico kube servers, there is kube proxy servers, kube scheduler, and everything. All of these information that we were discussing, core DNS and everything, you can see inside this is running, right? So let's get back to what we were talking about. So these are the different namespace resources. The add-ons belong within the kube system. So whatever the namespaces that add-ons that you will be adding, these all belong to the kube system namespace. As we saw, when we did all namespaces, we saw kube system, whatever namespaces it had. We did not add many add-ons in there, but there are a lot of different things still. So there is DNS. DNS is a mandatory add-on. So in my, if you can see my terminal again, this kube DNS was already present in here. This, see, core DNS. This is still inside the kube system. The core DNS is already present. So DNS is a important mandatory add-on which is there. But along with that, there are a few other add-ons that you can use. There is a web UI dashboard. There is a container resource monitoring tool which you can use. for monitoring how the status of your containers are right now. Then there is cluster level logging also. We'll talk about that, all of these in detail in the future modules, but we'll give you a zest of it now, because we'll show you even how to set up your web UI dashboard for Kubernetes. We'll even show you how to monitor these resources, which we'll be using for using Prometheus and Grafana, where Grafana is used for visualizing those information. There is cluster level logging. We'll show you all the logs and stuff as well in the hands-on in the future modules. But just now we just need to give you a zest of things, so we'll explain it to you here. So starting off with the DNS. Now, cluster DNS is a DNS server in addition to other DNS servers in your environment, with server DNS records for Kubernetes service. Containers started by Kubernetes automatically include this DNS in their servers. DNS server in their DNS searches. So I was telling you, this is a mandatory add-on. This you need to have if you want to work with Kubernetes. It's already present, predefined in it already. But the other things which we are going to talk about in these add-ons, they are not very necessary when you're working with it. It's a good thing to have them as well, because it helps you work better, faster, and in a more informative way. But this is something which you actually require. Moving on to the web UI dashboard. Now, dashboard is a general purpose web-based UI for Kubernetes clusters. It allows you to manage, troubleshoot applications running in the cluster as well as the cluster itself. Even you can, when you go with the web UI dashboard, which we'll show you after on. So all the concepts that I'll be teaching you how to run through a command line interface, you can do most of it through the dashboard as well, but we'll be teaching you command line interface because it is important for you to learn how to use command line interface when you're running with the Kubernetes, because it gives you a better zest of things, and not all the production environments that you'll be working with will allow you to do dashboard based things, right? Moving ahead, there's a container monitoring resource. So container resource monitoring are generic time series metrics about containers in a central database, and it provides UI for browsing that data, right? So for this, you can use a lot of different tools again, but what we'll be showing you in this course is using Grafana as well as Prometheus and Helm, where Helm charts are used to get data through Prometheus, and finally, we visualize those data through Grafana. So we'll be showing you that as we go along the modules. But basically, this is used to see how your nodes are performing, how their health are, and how many of them are getting killed and they're restarting and stuff like that. All of that data you can get and monitor your containers, right? Then there is a cluster level logging. Now, cluster level logging mechanism is responsible for saving the container logs to a central log store with search/browsing interface. So all of the containers that you have, they have logs of their own, right? So what you can do is, sometimes when you want to receive some information or when you're trying to troubleshoot or debug something, you need to have the information of what your container has been through. So cluster level logging mechanism is responsible for that. It stores all of the container logs to a central log store with search browsing interface. Now next is kubectl. Now kubectl, I'd say, is not just add-on. It is again a very mandatory add-on. It is a part of the master, if you will. It allows you to basically communicate or interact with the kube API server and send commands to the master node. Each command is converted to an API call. As you saw in the example that I showed you, I had a command line interface that was my bash terminal, and there I typed kubectl get pods. Now that is a command. Now that command is turned into an API call, which is through the API server. It is sent to the nodes, and then according to whatever the command is, there it reads the information and it gets back the whatever the information that they have to give on our command. Like if I give the command, so they have to give me the information regarding that command, right? So that will come back through there, and all of this is then my information that the command that I want to pass through the master is given through kubectl. I give my commands through kubectl to the master, then the master gives it to the nodes through the API server, and through the API server these are responding and everything works through APIs, and all of the API calls are made, and then finally you get the result, right?
Kubernetes is one of the most sought after container orchestrating tool in the world right now. Almost all of the organizations who are using containers are using Kubernetes as the tool to orchestrate those containers, and hence kubectl is an integral part of it, where you can use it as a command line interface to interact with your Kubernetes cluster. So the first command is create. So what do I mean by create? So Basically, what I mean by first command is the simple fact that if you see on your screen right now, the kubectl will be the starting of all of these commands. So the first word that you write will be kubectl. So it basically tells you that this is being interacted with the help of kubectl. So kubectl will be there, and the first thing that you write after that is create. Now, create is a command which is used to create resources from a file. It could be of the file .json, or it could be of the type .yaml. Either way is accepted. Other use for create is also there, so you can use create to use a lot of different things. So in this, when you are using with a file, the syntax is kubectl create -f and then the file name, and it creates those resources inside of those files. But create can be used to do a lot of different things. You can create service loads balancers, service node port, service account, cluster role binding, config map, cron jobs, deployment, namespace. All of these things can be created using this command. There's another thing that you can use to create files configuration as well. So you use kubectl apply, and using that apply, you can apply some configurations to your cluster as well. So that is something else that you can use. So you can use for creating resources from a file, you can use create or you can use apply. So let's quickly try creating a file using kubectl create. So I have my Kubernetes cluster here up and running. I only have one node right now. Let me show you that really quickly. Kubectl get nodes. So this shows you the number of nodes I have. Just wanted to show my cluster is up and running. Now let's create a file. So I have a file ready in here. So this is a YAML file for deployment. So a YAML file for deployment, basically this has the specifications of the deployment that I want to create. So it has the name of the the kind is deployment, and the name is nginx deployment, that is in the metadata, and it has 3 replicas. So basically it will spawn 3 pods, and you have another match labels, you have images, you have container specifications and things like that, right? So let's create this file. So in order to do that, I will switch to my terminal really quickly. I'll have copied this. I'll move to my terminal really quickly. Now in here, I will type the command nano t2.yaml. I'll just paste this particular YAML file which I have really quickly. And once I've done, I will just save it and I'll exit. So my file is ready. Now what does the command say? The command says kubectl create -f file name. You can see right here, right? Kubectl create -f the file name. So we'll do that. Let's quickly go to the file. Kubectl create -f and the file name, which is t2.yaml in our case. Once I do that, you can see the deployments has been created. Now, if I check for pods, so I have 3 replicas in my deployment, right? So I have 3 replicas in my deployment. You can see, so it has created the deployments and it has created everything. So you can check by kubectl get deployments. This is in the next deployment, which was created, is up and running. Cool. Let's move on to the next command. So I was talking about this, right? So you can use create to do a lot of different things. Like you can create a cluster role, you can create role binding, secret, a lot of different things. All of these things which are mentioned here can be done with this. But the syntax will be a little bit different from what we did just now. So I have that syntax ready for you as well. So if you wanted to say, let's say, create a deployment with the name, and you can give this image. So the syntax for it would be kubectl create, then whatever that you want to create. So if this was a deployment, it's a deployment here. If it was a cluster role, it will be cluster role. If it's a secret, it will be a secret. Then here the things will change accordingly according to whatever you are creating, right? So this will change. For deployment, it will remain deployment's name, and -- image, and whatever the image that you are pulling, that image, and then the commands and arguments. So like for example, you can do kubectl create deployment and call it my deployment, and image of nginx and replicas equals to 3. So let's see what happens when we run this command. So let's bring up our cluster, kubectl create. Let's bring on top of it so that it's better for you to understand. So you can see kubectl create deployment, and name it deployment. I will say name it my dep -- image equal to nginx -- replica equal to 3. Let's see what happens. As you can see, a new deployment is created with the name of my dep. So if I do kubectl get deployments, now I have another deployment coming up. As you can see, the nginx, which was created when we did the before one, and my dep, which we created just now, has been. So you can use create commands in the way to create something from a file, or you can create some another resource with some arguments and some names and everything that you have to keep in mind about the syntax. Using these syntax, you can do this. So this is one of those commands. Let's move on to the next command, which is kubectl get. So we've been using get now exclusively. So we are doing kubectl get pods, kubectl get pods wide and different things like that now. So basically get command, what it does, it prints a table of most of the information about the specified resource. For example, when I was doing kubectl get deployments, it was getting the information with respect to the deployments. You can filter the list using the label selectors, and you can use selector flags, and you can do a lot of different things. So let's say if I wanted to get deployments from a particular environment or namespace, we can do that as well. So that can be done. If the desired resource is in the namespace, then only you will see those results, otherwise you will not. And if you want to see all namespaces, then you have to pass the parameters, which is --all namespaces. Let me show you how that works. So the basic syntax is kubectl get and the resource name. So let's start with the basic one. I'll show you all of these commands really quickly. So kubectl get pods. You can even type get po, and that will also work for pods. I'll show you. Get po. Oh, sorry. Kubectl get po. This will also work, and kubectl get pods will also work. Both are the same thing. You can see same results. So we are getting pods like this, right? And let's say if you wanted to get some particular pods and you wanted to pass some particular thing, then you can have that as well. But let's say if I wanted to, this is getting me all of the pods in the default namespace, because that is the namespace that I've designed. But let's say if I wanted to see pods of all namespaces, so what you can do is kubectl get pods --all namespace and pass this parameter. You can see the S was missing, namespaces, it's namespaces. So you can see all of the pods which are there in different namespaces. You can see which all namespaces it belongs to. So default ones were the one which were coming here, and the cube system is another namespace which we have, and you can see all of the pods which are there in various different namespaces. I have started also spawning, right? You can do that as well. Another thing that you can do is kubectl get pods -o wide. Now what's that command? We've seen something here which is -o wide. So this basically returns you all of the pods with more information, like all the pods which you have in with more information. So you can see before what we were getting is, let's say, only the name, the status and restarts and the age. Now we are getting all of those plus the IP plus the node that it is on, plus the nominated node and readiness gates. So we have all the information coming in, and that is with the -o wide. So if you want to get more information with respect to any particular resource, then you use the flag -o wide, right? So that's that. And you can get services, deployments, anything. So you can get kubectl get deployments. We saw that before. You can also get services, kubectl get services. You can get ingresses. You can get basically anything that you want, which you can if you want to print something, like a print statement for the resources that you have, and that is how it works, right? So that's that. Let's move on to the next command. So we got done with get, right? So next one is expose. Now what you can do with expose is like whenever you have a Kubernetes service running, right? So if by default it is on like the cluster IP interface, and your deployments and everything which are not on the exposed end, it is not reachable externally. So let's say if you wanted to expose a resource as a service to an external point, then you use the command expose. So basically it looks up a deployment service replica set replication control or a pod by name, then uses the selector for that resource as a selector, and it sends it to a new specified service point. For example, let's say my deployment, I have created a deployment right now, right? But that deployment resides inside of my cluster. Nobody from the outside world can see what is going on in there. That's the problem. What if I wanted to, make it externally reachable, so that somebody who can type in the port numbers or the link or the address, whatever it is, they can reach the particular deployment. So what I'll do is I'll expose that deployment as a service at some given particular port, and using that I can reach it externally. So let's try to do that. So the basic syntax for that is kubectl expose, and then you can have the type or the file name. So for example, here the deployment is the type name of the resource that we are providing, deployment and the deployment's name then you have to give. So deployment and deployment's name is nginx and -- port 80, that is the port that it is currently serving on, and the target port is 8000. So you have to provide both in order to do that, right? So you can do that really quickly. So let's expose us deployment that we have right now. So I'll open. So let's run this command. So kubectl first let's get the deployment. Okay, we have the name of the expose deployment. let's say mydep, we will expose mydep port equals to 80 target port equals 8080. You can see a new service is created. So if I do kubectl, now to get service, you can again type a get svc or get service, both will work. You can see a new service has been created with the name mydep, which was the name of my deployment, and it has been exposed to a port 80, which was there initially, right? So that is the idea behind it. So that is how it works. You can also expose it as a particular type of service, which can be externally reachable IPs as well. That can also be done. So, but that is not required for now at the moment. But just know that you can expose your deployments as a service. So my service deployment was exposed. So my deployment was exposed as a service on the port 80, right? So that is that. Let's move on to the next command, which is delete. Now what you can do is you can delete some resources as well. So a lot of times you will be requiring to delete resources, and it depends on what you're deleting, that will determine what all will be deleted. So let's say kubectl delete, and then you can have the file name -f file name, you can have -k directory, you can delete an entire directory, or you can have a type or label and you can delete particular things. For example, if you wanted to delete pod, so kubectl delete pod, and then the pod name will delete a specific pod. But let's say if I wanted to create everything created by my deployment, so that is my deployment should also be deleted. My number of pods created through that deployment should also be deleted. So I can delete a file. So kubectl delete -f t2.yaml will result in all of my deployments with respect to the Nginx deployment being deleted, as well as all of the pods which were created will also be deleted. So and you can delete things with the help of label as well. So you can see this example in here, which is on the bottom left side of the screen. Kubectl delete pods services -n. So you are deleting pods and services which have the label where name is equal to my label, or by the label name equals to my label. So wherever this exists, all of those pods and services will be deleted. So you are passing it as an argument. So these particular things I want to delete. Let me show you these really quickly so you get a better understanding of things. So first, let's try to delete the deployments that we have. So let's see what all do we have. So kubectl get deployments. So we have 2 deployments right now, and kubectl get pods. And you can see we have 3 pods coming from the Nginx deployment and 3 pods coming from the mydep deployment. This is according to replicas that we created initially. Now let's say that I wanted to delete the Nginx deployment and all of the pods associated with it, right? So all of the pods associated with it. So what do I do is kubectl delete -f t2.yaml, because these things I created through a YAML file, right? So I'm going to delete that particular file. So what happens? Let's see. So you can see it has deleted the deployment. So if I get kubectl get pods now, terminating, you can see. And if I do kubectl get deployments, only one of the deployments is remaining. If I do get pods now, you can see my Nginx 3 of them have terminated, only 1 is remaining. And in a second, I think the last one will also be gone. So that is basically how you can delete all of the everything which is created from that file will get deleted if I do that, right? Now, what if I wanted to delete a particular pod, right? So let's say kubectl get pods. So this is the mydep pod name. So this is the pod name. So if I do kubectl delete pod and then the pod name, so you just copy that. So the problem with this one will be that since it's a deployment that we created, that is the mydep is a deployment, so it will keep respawning the pods. But you can see, just notice the name 4DZZ4, it will not be spawning once we delete it. Let's see. So it has deleted a pod. It will take a couple of seconds. We'll just give it a couple of seconds. So it has deleted a pod. So if I do get pods now, I will still get 3 pods from the my deployment kind of thing, but none of them would be this particular pod that we deleted, like 4DZZ4. You can see that particular pod is deleted. Since that is the feature of deployments that we keep on, it will, once we specify, let's say I want 3 replicas at all time, no matter if it gets deleted or it stops responding or whatever, Kubernetes has this capability where it respawns the pods constantly. So that is the advantage of using deployments. That is why people prefer using deployments. So if your pod fails for some reason, Kubernetes automatically restarts a new pod for you. So that is that. So this is the kubectl delete command. Let's move on to the next one. So the next one is autoscale. So you can give a command to autoscale. So you can auto scale your deployments, and basically it creates an autoscaler that automatically chooses and sets the number of pods that run in Kubernetes cluster, and looks up deployments, replica sets, stateful sets, as well as replication controllers. So all of these four you can auto scale, and it basically gets them by the name and creates an autoscaler that is given with for the resource as a reference. So let's say if I say I want to autoscale deployment and then deployment's name, and I will define how many minimum or maximum pods I need. So this is basically done because let's say if you are Grofers or if you are Flipkart or Amazon, you don't get the same number of people trying to access your website every single day, right? It will not happen that every day you will get the same amount of traffic, but sometimes, let's say during a sale period or during some festival season, you will get a lot of traffic coming to your particular website. So how do you know that when it's going to hit, and how do you auto scale? So you can basically tell Kubernetes that whenever, let's say there is huge amount of traffic coming, so let's say if there is something you can define. So if let's say my pod can handle 3 requests at the moment, and for example during a sales season that 3 becomes 6, my Kubernetes autoscale command will basically enable my pods. So let's say I have only 3 replicas, it can automatically scale up to 5, 6, 7, 8 just to serve the requests. It can basically do that. So it has that capability as well of auto scaling. So you can do that with the help of Kubernetes as well. Let's move on to the next command, which is scale. So I'm moving on to the next command because I cannot show you auto scale right now. I can show you scale. I can show you how you can improve the replicas. And basically what you have to do is you can scale for a new size of a deployment, replica set, replication controller, or stateful set. Works for all of these 3, and basically allows you to specify one or more preconditions to scale also. So whatever you need, you can replicate that as well. And basically if you wanted to manually increase the number of replicas that you have, then you use the command scale. So very simple command. So the syntax for it is kubectl scale, and the resource resource version equals to version, and then current replicas count, and then the replicas count and file name and type. So let's try this out. Let's see how this works. So I'm going to be opening my terminal again. So I have a deployment which is running, which is my dep. So kubectl scale replicas equal to 4, and then it says to write the file name and or the type, right? File name or the type name. So replicas equals to 4, and then we are going for my deployment, which is of the name my dep. Let's see. As you can see, it says the deployments was scaled. So I had 3 pods running before. Let's see what happens now. kubectl get pods. Sorry. As you can see, 1, 2, 3, 4. It has scaled my number of replicas just by a pinning of a command. And you can do the same thing with the help of autoscale, where you can define the number of replica sets that you want. You can in here you can define minimum to maximum 10. So at all times it will be minimum of 2, but based on the service request, it can be scaled up to the maximum of 10 to serve all the service requests. So that is the use of the scale command. Okay, let's move on to the next one, which is called describe. So as the name suggests, it's prints out a detailed description of the selected resources, including the related resources, events, controllers, and whatnot, right? So if you are going to get the detailed information for, let's say, one particular resource, then you use the command describe. The syntax is pretty simple and pretty straightforward. So you type kubectl describe, and then you write the type of the thing that you want to describe. So let's say if it's a pod, so kubectl describe pod, and then pod's name. So whatever pod you want to describe, you mention the name, right? And if it's a service, then you write kubectl describe service, and then the service name, kubectl describe deployment, and then the deployment's name. So whatever it is, then you go ahead with that, right? Let's quickly dive in and see how that works. So we have, I'll clear the screen so that, because the describe will give you a lot of information, that's why. So kubectl get pods, that is just to get the pod's name. So that's that. Kubectl describe pods, and then pod name, right? It returns the entire information with respect to the pod. So everything for this pod has been here: the name, the namespace that it is in, the priority it has, the node where it is residing, the start time, the labels it has, the annotations, the IP, the controllers, the ID, container ID, image ID, and what ports it is on, if it is being pulled, restart counts, when was it, type of the conditions like initialization is true, container is ready, true, pod schedules true, and normal everything, all of the events that has happened with respect to this pod and everything, the volume mounts and everything about this pod you can find in here. That is what describe is used for. So when you want detailed information of a particular resource, you go for describe. That is the basic idea behind that. Let's hit clear and move on to the next command. So next command is logs. So basically logs, as you can suggest, it prints the log of a specific pod or a resource, and if the pod only has one container, then the container name is optional. So when you can have pods with multiple containers also, so if they are multiple containers, then you would have to specify the container name as well, but if you have only one container, then it's
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
fine, right? It's optional then. Then if you wanted to get, so the syntax for it is kubectl logs, then -f, -p, depending on whatever that you are using, the pod and or the type name, and the container name that you want. So if you want to get all of the containers in a pod by the label app equals to nginx, then what you do is kubectl logs, then -l for the label, and then the app equals to nginx all control containers equals to true. So what we'll do is we'll try to get logs of one of our containers, and let's see how that looks like. So it's kubectl. Let's get pods first, that we can copy the pod name. Yep. So kubectl logs -f pod, because I think we can give the type name. Yeah, so we can give a pod or type name pod, and then the pod name, which is, let's say, this one. And since I think it has only one container, so I don't think I need to give the container flag, so it should work. Maybe we don't need to specify pods in here. So you can see the logs with respect to this has been printed. So you don't need to give the name, you just need to give the name of the resource and it will work. So that was the logs for this particular thing, right? So don't need to give that, and you can directly go ahead with that. We could have given some label, but we just went with the resource name, right? So that is that. Let's move on to the next command, which is exec. Now exec is something which is used to execute a command. Even you can use exec to get inside of the containers as well. So you can get inside the containers, you can change different sources in there. So you can use exec command for that. So basically any commands that you want to address, you use the command exec. And the syntax is very simple: kubectl exec, and then the pod or the type name, and then you have different flags which you can put in. For example, kubectl exec my pod, and -date, it will give you the running date of the pod. Let's quickly try that. Yes. Kubectl get pods, kubectl exec, then your pod's name, and then whatever the command that you want, right? It's not clear. I just wanted to move this here so that you can see the command, and the way I'm typing is the same. Exec, and then any pod name. So go with this pod, go with this pod, -. You can see Wednesday, deck 9, everything with respect to that has been delivered.
So guys, continuous monitoring is basically the process of continuously keeping a track of all the servers and the applications which are hosted on that servers and creating a log out of it, right? Now, how does it help? Basically, it helps in cases when your application transitions from an active to a critical state, right? And sometimes what happens is you're not on the application all the time checking whether your application is up or down. So your work is basically done by a tool which continuously checks whether the application is up or down. right? If there are any performance issues, is there any non-responsiveness, is there any downtime, all of this is managed or is basically monitored by the continuous monitoring tool, right? Now, the moment application transitions from an okay to a critical state or a non-responsive state, there are a set of rules that you defined, right? For example, if it's unresponsive, probably a mail or a notification is triggered to the administrators, and basically what will the administrators, they'll properly restart the service or they'll restart the application, right? If there is a bug that is encountered, so for example, if the program goes into a infinite loop and the memory goes haywire, or the memory basically gets full under seconds, in that case also it becomes a critical case, right? So earlier we saw that it was probably a non-responsive case, but in this case it becomes a critical case because even the other applications on the same server becomes affected, because now the memory of the whole server, it became full. So in that case, the mail would go to the developers and also the administrators. Developers, why? Because now they have to identify where exactly the problem is, right? So probably the problem is within the code that they've written for the application. So they'll fix it, and the notification also goes to the administrators, because once they are done with the code, the administrators basically have to take that code and upload on the servers again, right? So guys, this is what a continuous monitoring tool is. Now, why is a continuous monitoring tool important? Let's discuss that, right? So let's discuss these points one by one. So your continuous monitoring tool detects any network or server problems. Like I said, it continuously monitors all your services, all your applications, all your servers which are running and hosting your application, right? And it tracks for any kind of change, right? It generates a stream of log, and in that stream of log, the moment there is a change, the continuous monitoring tool automatically creates a notification or an email and send it to the specified contacts in the rule, right? So what kind of changes? It will look at any network or server problems. It will basically see all the security issues as well, right? For example, if someone is planning a DOS attack on you and they try to do that, they initiate attack. So your continuous monitoring tool, if you set up it with the correct configuration, it would be able to identify if a DOS attack is happening on your website, right? And continuous monitoring tool does not only help you to identify what just happened to your set of systems, right, or your server, it also helps you to identify what exactly caused that problem, which is very helpful, because now the developer knows exactly what has to be done, what has to be fixed. Rather than just saying that the application is down, your continuous monitoring tool will also tell you the details of the event which occurred, which is a great thing, because that would help us narrow down on the problem or the segment which basically caused the problem in the whole program, right? The next thing is it also monitors and troubleshoots server performance issues, right? For example, your hardware on which your application is running, your continuous monitoring tool also keeps a track of how the server health is, right? How fast is it to all the requests which are made, right? And how are the response times, how are the performance basically of that server. So all of that is logged, and at times when the performance goes below a certain level, for example, what happens is, guys, the computers never get slow. It's just that the applications or the softwares which run on those computers, they become advanced, right? For example, if you have Windows 10 and you updated your Windows 10 one day, you probably get some new features added to it, but with those new features, that particular operating system is now going to take up more processing power or more resources from the memory, etc., right? And this can cause a problem when you have servers which run 24/7.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
And have applications which get upgraded timely, right? In that case, you might have to change your server or system, or you might have to upgrade your hardware. So basically, your continuous monitoring tool can also help you in identifying when your system health goes into a critical state, so that you know that when you want to change that particular system, right? So guys, these were pretty much all the reasons that why continuous monitoring tool is so important, right? Why companies are preferring the last stage of their DevOps to be a continuous feedback cycle wherein they have put the continuous monitoring tools, right? So these were the reasons. Now moving forward, let's discuss continuous monitoring quickly using a DevOps lifecycle. So we have discussed this diagram before, but let us just summarize what we just learned, right? So that we can picture it better while we are basically implementing our DevOps lifecycle. So a developer does a commit on the version control system. The version control system basically picks up the code and deploys it on the testing server, right? The testing server does its test. If the test fails, the feedback goes back to the developer. In case the feedback doesn't fail, in that case, the code is again pushed by the CI server to the production server. And now from here, the continuous monitoring starts, right? So your continuous monitoring tool is basically going to check the server on which the website has been or the application has been hosted for any performance issues, right? It will check for network errors, etc., etc. So it will be on a vigilante mode in that case, right? And check for any faults in that particular application or the hardware on which it has been hosted, right? And the stream of logs that I was taking, so even if your systems are okay, the logs are continuously generated, right? And if there is any change in the log, a notification is basically passed on to the developer team, right? Now, based on the severity of the severity of the event which has happened, it could be a critical event, it could be a non-responsive event, it could be a minor event as well. So based on the events, we define rules. So if it's a critical event, we'll probably want to employ our solutions architect guy of our company as well. If it's a minor issue, probably only one or two administrators would be able to solve it. Either two administrators or one administrator and a developer, so that if that minor issue is being caused by some code which has been recently uploaded, only the developer can fix it, right? So all of this is followed, and keeping in mind all your organization needs, you create this life cycle, and continuous monitoring becomes an integral part of it, because without it, you will not be able to identify how well your DevOps life cycle is actually performing. Alright guys, so we saw that Nagios is one of the most popular continuous, or is one of the most, like, we looked at top 3 continuous monitoring tools and we saw that Nagios was one of them, right? And today in this module, we are going to discuss in detail about what Nagios is and how it works. So guys, Nagios is nothing but an open source software which helps us in continuously monitoring applications which are running on remote hosts, right? For this, Nagios follows a master slave architecture. There is one server on which Nagios is installed, and the others are basically just normal systems on which applications are running, right? So in order for this Nagios server to interact with the services which are running on some other server, you have to install some plugins on those servers, on those hosts which wants to get monitored, and these plugins are chosen based on the platform that they're running. For example, are they running a Windows platform, or are they running a Linux platform, right? Now, what all can you monitor with Nagios? So as you can see over here, you can create monitoring service for literally any kind of things. You can monitor printers, you can monitor applications, you can monitor switches, network switches, right? And you can monitor hosts, right? You can monitor literally anything in Nagios which is in the computer realm and is running on a remote host. What are the components of Nagios, right? So there are basically three main components of what make Nagios the most effective continuous monitoring tool. So the first component is the Nagios GUI, then you have the scheduler, and then you have plugins in Nagios. So let's understand this one by one, right? So let's first talk about the Nagios GUI, guys. So inside, basically the GUI is the web interface that Nagios offers you, and that is basically a dashboard for you on which you can monitor all the services which are running on different servers that you have attached to your Nagios server, right? And also you can have a look at all the hosts which are connected to your Nagios server, right? So along with checking them, you can also have a look at their status. You can also have a look at the logs. All of that is possible inside the Nagios GUI. So basically Nagios GUI acts as a front end for you, right? The second component is a scheduler, right? Now scheduler itself is again a very main centric component of Nagios, which basically does all the work of scheduling, right? So what has to be monitored and when exactly it has to be monitored. For example, you are basically monitoring the ping service of a server, right? Now, when do you have to manage it, right? So at what intervals you'll have to go ahead and check whether that ping service is working or not, and what exactly do you have to manage, right? If, for example, ping you have to manage, what all other services you have to manage, and what all servers you have to manage it on or monitor it on, right? So that all of this job is done by the scheduler, right? And then you have plugins. So basically, when you talk about monitoring hosts, talk about monitoring different servers. So if you have like 1,000 servers in your company that you have to monitor, it's not that you have to install Nagios on the servers that you have to monitor. For example, like I told you guys, you need a Nagios server. So a Nagios server will basically take care of all the monitoring part, right? And with your Nagios server, you attach your application servers, right? And your application servers are basically going to have some plugins. So you don't have to install Nagios on them, on the application servers. All you have to do is install a plugin on it, right? And those plugins are called NRPE plugins, right? You install it on them, and using the NRPE plugin, what the scheduler does is the scheduler basically sends a request to the NRPE plugin along with the command using which it has to monitor that particular host, and the NRPE plugin basically helps the scheduler to get all the log related to that particular service which was requested. And once the logs have been received by the scheduler, they get forwarded to the GUI part of Nagios, and then that Nagios GUI then represents the log in terms of their status, in terms of graphs, in terms of many other useful visualization techniques through which you get to know how your host is performing in terms of its hardware, in terms of the application which is running on it, and etc. Right? So this is how basically the Nagios architecture works, guys. So Nagios follows a master-slave architecture. All your hosts are on separate machines, right? And your Nagios has a dedicated server for it. You can also have applications installed on the same system as the Nagios is installed on, right? And Nagios has the capability of monitoring its own services as well. But usually when you talk about it in production environment, or you talk about how companies use it when they're dealing with monitoring applications, it always happens on a scale that you have a Nagios server, and beneath the server you have a lot of hosts which are basically hosting your application, getting monitored by Nagios scheduler. So let me quickly jump on to my browser so that you guys can see that we have two hosts right now, localhost and slave one. This we already did in the last session, where I showed you guys how you can add a host to the Nagios server, right? The host which is being monitored. So right now the status of this host is that it is up and running, right? Now what I want to do is I want to create a monitoring service which for an application which will be running on this slave. So what I'm going to do, if I go to services right now, I can see there are no services which are monitoring any application which is running on the remote host, right? So what I'll do is I'll first install a service called sudo apt get install Apache 2. I want to install an Apache service which I can monitor in Nagios for this particular server. Okay, so Apache is getting installed. Yes, so Apache is installed now. Now if I go to the browser, I should be able to see for the Nagios slave an Apache service, right? So Apache page is working. Now what I'll do, I'll go to my server, right? Let me just clear the screen. And now I will go to templates, or let's go to templates, or let us go to localhost configuration first, right? Now in this localhost configuration, you will find a service for, right? So I want this service to be copied. I'll just copy this service, right? And what I'll do, I'll make changes to this particular service and I'll make it a service for monitoring the HTTP connections. So what I'll do now, I'll just go to the configuration file of my host 1 right? And I'll paste the service over here. And let's make changes to the service now, right? So this is the service. Now we want to use a template for the service. Let's say it's not a local service. I'll say it's a generic service. So there's a template for generic service inside templates.cfg. You can have a look at that. The host name for this service would be the same as the host name for your host. So the host name for my host is slave1, right? So I'll write exactly slave1 in my service as well. So I'll do that. I'll call it slave1. Service description, what do I want this description for this service to be? Check Apache. Okay, and the command for this particular service would be check_http, right? So this is the official command for checking the if anything is running on port 80 of any computer, right? So you can have a look. If you want to try some other application that you want to monitor, you can just Google out the service or the command that you would use over here to monitor that particular application, right? And most of the times you will get a command. In case you don't get a command, just Google how you can define a command for basically monitoring the application that you want, right? Now all you have to do is, if you find the right place where you just have to create a command, go inside commands.cfg, right? That is there in your etc directory. And inside the commands.cfg file, all you do is create that command, and which I'll show you in a moment, the way to create a command, and then you can use that command over here as well. So check_http is already a command which is existing in my Nagios server, and I'll show you the definition of this particular command when we go in commands.cfg. For now, the service is ready. So what I'll do, I'll just save the service, right? And now I'll just restart the server. So for restarting, this is the command. I'll pass this command. So my Nagios server is now restarted. Now if I go inside hosts, I can see slave1 is up. Now if I go inside services, I can see that slave1 now has a service which is in the pending state, right? So what will happen, it will basically take like 2 minutes for this to refresh and to check whether a service is actually running on port 80 of slave1. Okay, so let's give it that time and then check after some time. Alright guys, so as you can see, the service that we defined is now under the status of OK, right? So now my service is running fine, and you can check the status over here that HTTP is OK, and 11,192 bytes were responded back to the request in 0.002 seconds. So you can get all the performance details here. You can see that the service is up and running since the past 5 minutes. So I think it took around a good 2.5 minutes for the service to turn green, because Nagios took that time to basically analyze if the service is healthy or not. Alright, now similarly, if I disable the service, you will be able to see that in another 2 minutes this server will go into critical state, right? So let us do that. I'll just go to my terminal and I'll say sudo service apache2 stop. Right, I just did that, and now if I go to the IP address, I can see that the page is no longer coming. Now it is 5 minutes 39 seconds right now, so let's see 6 minutes 45 seconds right now. Let's see when our service gets into a critical state. Alright guys, so as you can see, the status has now changed, and it says that the status has changed since the past 18 seconds, right? So it took a good 4 minutes for this service to go into critical state. I guess that's how long Nagios checks in intervals as to whether a service is working or not, right? So as you can see, it says connection refused, reason being now Apache is not running on that particular system. Alright guys, so this is how you create a service in Nagios, and similarly you can create any kind of service for your particular application that you want to monitor. Right, all you have to do is either check if you have an internal command which is going to match for your application, or you'd have to create a command for yourself using some plugins, right? So all of that can be checked online when you're working, because there could be zillion applications that you would be working with. Having a look at all the applications is difficult, because with everyone, they'll have different kind of needs for the kind of applications that they are monitoring, okay? Alright, so I forgot about one thing. Let us also have a look at how you can create a command in Nagios, right? So let me jump back to my terminal. So all I have to do now is I'll have to go inside commands.cfg, right? So let's go inside it. So we use the command check underscore HTTP, right? So let's first that command first. So if you go inside commands.cfg, you will have all these commands over here. Notify host by email, then you have check host alive, then you have check local disk, check local load, then you have check local procs, check local user, check local swap, check local MRT, check FTP, right? So all these commands are then being mapped to their command line usage. So if you pass this command, this command is basically being passed on your Nagios host if you are using the command check FTP. Okay, then you have check HPJD, check SNMP, check DSP. What I'm going to do is I'll just go click on where is and I'll search for HTTP. Okay, so here I get it. So on this command, you can check that if you want to define this command, the command name is check underscore HTTP. The command line for this is $user1 and then check HTTP-I host address $argument1, right? So this is the command which you are using when basically you are just calling check underscore HTTP while defining a service. So basically what you're doing is in your service, you're basically calling the check underscore HTTP command, which in turn is calling this particular command, which is being passed on to the command line, through which you are able to check whether HTTP is working or not, right? So let's define a command for ourselves. Let us call this command as, command name would be command underscore name. Let's call it test underscore HTTP. Okay, and the command line for this, the command line command for this would be this. Let's paste it, right? And let me just align it. All right, so this is done, and now basically all we have to do is close the brackets, save the file, right? So the file is saved, and now let's go inside sudo nano host1.cfg. okay, and now I would want to create a service, right? Let's name this service as, we'll use everything which is the same here except the command. So we'll just go down to the earlier service that we created, we'll just copy everything, paste it here. So we have to paste this commands here, and then we'll close the brackets. The check command will now change to test underscore HTTP. The check Apache, let's change the text to check Apache test, right? And everything else will be the same. Okay, now let me show you one more thing. So you can also control the interval in which Nagios is basically checking your command. So what you can do is, let me just save the file here. We'll go to templates.cfg, right? So let's go inside. So we're using the generic service template, right? So let us go inside sudo nano templates.cfg.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now let's try to search for generic service, right? So here it is. So the generic service is defined like this, that you have check freshness is 0, notifications enabled is 1, event handler enabled 1, flap process performance data, and you can check over here that in check interval, it's 10 minutes, right? And the retry interval is 2 minutes. So if the service is functioning normally, in that case, it should check for the freshness of the service, or check whether the service is again working or not in 10 minutes from the time that the service goes down. So let us change this to 1. Or what you can do is you can also change this when you're calling this service. So let's change it over there. So basically you have to remember that this keyword, which is check underscore interval and retry underscore interval. Okay, so let's go out. We're not going to change anything here. What I'm going to do is I'll go to sudo nano host1.cfg, and now in the service I'll specify retry underscore interval, and I'll give that number to be say 1 minute. right? Similarly, what I'll do, I'll say check underscore interval, and I'll again specify it to be 1 minute. So every 1 minute, even if this service is up and running, it will check if the service is running now. If not, it will retry again to check the service whether it's up again or not in the another 1 minute. So with this, you should get a faster response onto when your service will become okay on your Nagios dashboard. All right. So we have specified this. So we have changed the services. So let's save the file now. So I'll save the file like this, and now I'll restart Nagios. So let's search for that command. Here it is. I've restarted Nagios. And now if we go inside the browser, here's my browser. What I'll do is I'll do a refresh. I'll go to services. And now I can see there are two services which are running. So because we stopped the Apache service on our server, that's why it is saying it's in a critical state right now. So what I'm going to do, let me go here and so we'll start Apache server, but first let's wait for this pending state to become to critical. So what I'll do, I'll just click refresh once again. I'll go to services and let's wait for this service to become critical. In that case, what I'm going to do, we're going to see that in how much time it becomes okay from the time when we basically up the service. All right. So let's wait for this to become critical. All right. So as you can see, the service is now critical, and what we can do now is we'll go to this system and we'll start the service now. So I'll start the service like this, right? So this service of mine, which is check Apache, is basically working at 10 minutes interval and 2 minutes retry time. On the other hand, this service, which is check Apache test service, is retrying at every 1 minute and checking the service also at every 1 minute. So let's see if there's a difference that we see over here. So we'll just refresh it and see which service becomes up and running again. Alright, so you can see that my check Apache test is already in the OK state now, right? So it became OK faster than the check Apache service. If I again refresh the service, I can see that my check Apache service is still in the critical state. Reason being, the check interval in that case I did not configure, and it took the default values of my generic service template, which had 10 minutes of check interval and 2 minutes of retry. Right? So basically, if this state is in the retry state right now, it should take around 2 minutes for this to become okay, right? On the other hand, my Apache service, because my check intervals is just 1 minute and even my retry interval is 1 minute, it became okay faster because Nagios is now checking the service pretty early than the way it is checking it with this particular service. So if I again click on these services, I can still see that this is in a critical state, and check Apache state is in a OK state. All right. So this was it for this session, guys. So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and that is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. This is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say, I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right. Let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes. And the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I have not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed, right? Now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right. So this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right. So let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like Hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, With a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically, once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay. So we have come back to our AWS server. Let me clear the screen. All right. So if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a docker ps now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a docker exec -it and then bash. Docker exec -it and then I forgot the container ID, so the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a PSAUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the $ prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it -id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right, so let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it -p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID, and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's on exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right, so for doing that, let's create a Docker file, and what I want to say is in the image shhar/webapp, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now they're both container orchestration tools, we just saw that, but why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system, you'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. With Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git, like we took that example. When you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right. So this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. The GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now, where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this, I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p, and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we're naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay, and I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to a remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is, let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was...
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
'82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically, if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log, and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master. Enter the credentials. Everything has been pushed. Job is getting triggered. Job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have say around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRP plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRP plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right, but if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right, so in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right, so our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I've already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now, what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically, my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc /Ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here. I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically I want to use the apt package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below.